everyone, welcome to the Applied Data Science with Python course by Simplilearn. Today, data plays a huge role in almost every industry. It helps organizations understand patterns, make smarter decisions, and solve real business problems. So if you want to learn how to work with data using Python, this course is a great place to start. So in this course, we will take things step by step and build your understanding from the ground up in a very simple and practical way. Here's what we'll cover. We'll begin with the basics of Python and the learning setup, so you will get comfortable with the environment and understand how to start working with code. Then we'll move on to NumPy, where you will learn how arrays work, how to perform mathematical operations, and how to handle data efficiently using dimensions, shape, indexing, vectorization, and broadcasting. After that, we will explore Pandas, which is one of the most important libraries in data science. You will learn how to work with series and data frames, organize data, filter it, and handle things like categorical values and date time information. Next, we'll look at data visualization using libraries like Matplotlib, Seaborn, where you will understand how to use charts like scatter plots, histograms, box plot, pair plots, and heat maps to explore patterns, correlation, outliers, and missing values in data. We'll also cover the mathematical foundations of data science, including linear algebra, vectors, matrices, probability. Now, these concepts are very important because they help you understand how data science and machine learning work behind the scene. And by the end of this course, you will have a solid understanding of the core concept needed to start your journey in data science with Python. Also, if you want to build a strong practical skills in Python and data science, check out Simplilearn's Data Science with Python course. This is designed for learners who wants to understand Python programming, data analysis, data visualization, and machine learning in a very structured and beginner-friendly way. You'll get to work with key libraries like NumPy, Pandas, Matplotlib, and Seaborn, and also gain hands-on exposure on important concepts like data cleaning, feature engineering, statistics, and real-world data analysis. On completing the course, you will receive a course completion certificate from Simplilearn, which can help you strengthen your profile and showcase your skills. Check the description below for the link and start your data science journey with Simplilearn today. Before we jump in, here's a quick quiz for you. Which Python library is mainly used for working with tables of data like rows and columns? Your options are NumPy, Pandas, Matplotlib, or Seaborn. Let me know your answers in the comment section below.
Course is all about, I got it. Applied data science with Python. Okay. So if we talk about this course in particular, right, the learning path that we are going to take is initially we will start with the basic course introduction. That it is introduction to data science, which focuses on data science and its applications. That's going to be covered today. After completing this, straight away we start with the advanced libraries of Python, that is NumPy. All right. So today we will start with the advanced libraries of Python, that is NumPy, which focuses on concepts of NumPy and its uses. Then after NumPy, we will move on to Pandas, which is definitely a basic library required for data analysis, including types, data structures using Pandas, and function. Then we move ahead to the data visualization library, which focuses on visualization techniques and different types of charts. Another important aspect of data science is statistics and mathematics, so which focuses on fundamental of statistics, its type, data categorization, concepts of scalar, vector. Then we will move forward to probability distribution, how distribution is carried out. Then we will also understand in detail advanced statistics concepts, probability, which will help in analyzing the results through hypothesis testing. And last but not the least, we would be practically loading the data set and performing analysis on it with the help of data wrangling and feature engineering. Getting my point? I hope today's introduction is helping you out to understand what is expected from you, how we are going to move forward in this data science journey. Yes. So can the audio be turned on so that we can communicate directly instead by chat? If you want to communicate with me, you can always say to unmute you so that we can discuss also. So that's not an issue, I'd say. If you want, I can unmute you. We can have a discussion if you have any particular doubt. But unmuting everyone can create a chaos in the session. Got it, Hetze? Got it? Yeah. So again, I'm telling you the format. Generally, you can communicate through chat, but if you have issues, you can tell me to unmute you. We can discuss. You can even share your screen. I can help you out with that. Keep my discussions very bi-directional, right? And we will go in for break in the mid of the session. That's after 2 hours, and poll will be conducted. Even last 10 minutes, we will keep it for discussion Q&A if you have any issues. Got it, Dharun, Deepak, Tullapati, Sudhanya, Sivagami? Yeah. Now tell me if you still have any doubts regarding the course, the prerequisite, please let me know. If you are familiar with the format of Simplilearn, we give lots of hands-on exercises of Jupyter Notebook. There is at the end, you're supposed to complete the course and projects, and of course, the ebook and the reference material. So are we excited to start this journey? Yes, learners, are we excited to start this journey? Yeah. Yeah, you will do the assignments, right? The daily assignments that we can discuss it on the session itself, and the project is submitted at the end. Got it? Yeah. And I hope you are also aware about the LMS, your learning management system, from where you get the course material. Learners, are you aware about that? The learning management system, right? You can, yes, learners, do you understand this or not? LMS. No, just 15 days required. Just Devika. After the course ends, then you will get 2 weeks to submit the project. Okay, so this is the LMS. You can log in into your LMS, and this is the screen or the dashboard. Since I am taking a lot of courses, so you have to log in into your applied data science course. You see this? On the left-hand side, you have the instructor slides, notebook, lab guide, incremental, capstone, data sets, all this reference material. I request you to download and be ready with that. Now clear, Hetze? And any extra material that I will share, that will also be shared on the LMS. All right. So as you all are very much familiar now that what is data. So Deepak says I have 5 years of experience from data background as a business. Oh, you're already working into this domain. So you have a lot of knowledge. So you're working in Tableau or Power BI? What kind of business analyst you're working like, Deepak? So Hetze says you already have a software background. So you, which language are you familiar with, Hetze? Can you just give me the background? HTML, web development? Power BI. Okay, Deepak. That's good. So you have idea about data analysis, Deepak. That's great. Good SQL and VBA. My working experience is process engineering. Sagnik Singh, pursuing MBA in rural management from Symbiosis. Is it XIMB is Symbiosis? Is that Sagnik? Have 2 years of X consulting. All right. Arun says web application developer, full stack, net sequence, 10 plus on a break now. Okay, Arun. I'm in quality assurance. Lakshay is in quality assurance. Okay. Darshan is pursuing BE, maybe at a fresher level. I used Python for simple. Oh, great. Great. I'm having 2.5 experience in sales, manage, okay. So, so that was Xavier Institute of Management, Bhubaneswar. Okay, XIMB. Okay. Got it. Got it, Sandhya. Got it. Great to hear from you all. And as I move along, I'll keep on asking. Please give me your background. How is it practically going to be used to you? So I love interacting from my learners, and you can always share your experience, especially analyst analysis, where this learnings can be really helpful. You can always share it with everybody because it's a learning from all of us, and you can always say, I want to unmute, share my experience, knowledge. It would be beneficial to all. Okay. So if I talk about Turlapati, 13 years of experience in production support. Okay, Turlapati, that's good. That's good. Devika says 5 plus in CFD and thermal simulation. What do I understand by CFD? Devika, I don't know what is CFD. Navdeep says 20 years in IT infra and Azure cloud. So Navdeep, you're quite working in that, and now you want to shift into this data analysis domain. Navdeep, is that the case? Devika says computational flow. Okay, CFD is computational fluid dynamics. So how is it useful? What is computational fluid dynamics? I would like to hear something on that. Mansi says, I have 10 years of experience from banking, have been into operations and techno-functional roles. Okay. Currently on a career break, looking into application of machine learning in banking industry, having knowledge of, okay, that's great. You have knowledge, but you want to now totally get into the data science era, right? So Devika, can you just put us a light on what is this computational fluid dynamics? How is it really useful? Data science is used for post processing automation of the CFD. If you can help out with that, if I can unmute you, Devika. Yeah, please unmute yourself and just shed a light on data analysis. This is something very new to me. Yeah. Yes, Devika. We can't hear you. You also please check your mic settings. We can't hear you. It's unmuted. Please check out, log in. I know Headse was able to later on do it. Something issue with your mic. Devika, please check on that. And the moment you are ready, you can always tell it to me to unmute so that we can have a good discussion on that. Okay. Okay. So we all understand what is data. Data is nothing but raw facts and figure. And I have been in 10 years of experience in automation. Okay, Sudhanya. So now let me start with the course and then we'll do the interaction again. Now, my question is data part or is data now a big hit, or is data has always been part of the human civilization? Yes. Is data always been part of the human civilization? That's my next question, everybody. Always part. How can you say that, Tullapati? So Mansi says, yes, it has always been, but now it's been tracked and traced now. How is it tracked and traced now? Why is it a big hit now when it has always been part of a human civilization? Why is it hit now? Hetse, Deepak Upadhyay. Why? Why is it a big hit now? And if I talk about, let's talk about ancient man. What was the data that ancient man used to use? Let's say we are just trying to understand that is data, why is, data now easy to track and trace? Is data has been always part of the human civilization? If I talk about ancient man, where the man did not have anything. It used to live in caves and make food by burning fire and doing that. Then also there was data. How was data stored in those days? Tell me, Hetze. Tell me, Deepak. Yeah, we used to write it. It used to carve it on stones, not exactly paper, maybe on the leaves and bark. People who survey that kind of data are known as archaeologists. Yeah, they even people who really study that ancient time, what was the how old were the coins and what is written, and the different statues associated with that. So they are known as archaeologists. They have their own way of analysis. As with the time, especially with the invention of wheel and the steam engine, the industrial revolution became part of the human civilization. Agreed? Then it was next change, which was there, the industrial revolution. The clothes, everything became more faster and in large production. Do you all agree? After the steam engine, the next big revolution was the invention of computers or the information technology, the internet. right? Which has, where we all converge. And now that data that was being stored in terms of files, paper, where all the documents were kept, right? Now they've all being stored into the form of digital data. That is why you see a big buzz, around globally, where people are talking about saving of energy, where this data is going to get stored, data centers, the energy there to save, to run these huge amount of data. Do we all hear that now? Yes or no? So Deepak says the data has always existed, but the scale, speed, tools have now make it transformative. Absolutely correct. So it has always transformed with every evolution or revolution. And why data science feels like a revolution? It's not about having data, but about finally being unable to. Yes, we are able to unlock its power because with the help of computers, the data is now digitally stored, right? And now this digital data is being generated in huge amounts. We understand now data in terms of big data with 5 V's: volume, variety, right? Veracity, velocity, and the value that we want to add to the data. So there is huge amount of data where we can do analysis and bring benefits to the companies. Got it? And now we are living in the fifth big revolution of human civilization, which is known as the AI revolution. And the new oil for the whole world is not the crude oil, but data. So the every country is running for that particular power because now whichever country will have, the biggest power resources, the energy resources for storing the data, processing the data will become the main part, right? Do we see that globally also? It is such a big impact is happening globally. People are just want to become the big powerhouse, right? Hetze, Mansi, Upadhyay. Can I call you Upadhyay because there are 2, 3 Deepaks? So I think so. Upadhyay is a good way I can call you. Can I do that, Upadhyay, if you allow me? Yeah. Thank you so much. Right. So now, data is the powerhouse, semiconductor devices, because see, ultimately it is the hardware and the software which will go together. Data is not something alone which is kept. So it is the hardware and the software where we combine together to move forward. Got it? Getting my point? And if we look at data more technically, please try to understand. If we look at data more technically, it is divided into two parts. One is known as the categorical part. This is known as the, yes, AI can replace a data scientist. It can do the analysis, but a very important part of Adhya we need to understand with all the AI that we see around us, who is going to verify results of the AI, right? There is no verification when we talk about different the Gen AI tools, the automation happening. So human involvement, at least if you ask me personally, from my experience, is extremely, extremely important. We cannot be completely dependent on it. If you ask me from my personal view, whether it's even a small response, even a small answer that you get from ChatGPT, don't rely. Verification of the fact, the answer, the code, or the result, or the automation definitely needs to be done at the human level. Got it? Of course, it is going to make the work faster, right? Like, for example, making PPTs, designer PPTs was a hardcore time, but now you can generate it in hardly 2 minutes time. But who's going to verify points covered or not? Got it, Upadhyay? Head say. All getting my point, learners? Please be very, very clear with this point because that's the big revolution I see. This was never part of the discussion Do you think it was part of the discussion even in my last 3 sessions in my career? No. But now I have to talk about Gen AI, the output of it, how is it affecting the whole thing, right? It was never part of the discussion even 3 years back, or rather 2 years back also. With evolvement of all the chat GPT, now Claude Anthropic is going to take big wave in the market. They're always talking about that. So we will see these changes in front of our eyes. We are witnessing the revolution itself. Okay. So will we also learn autonomous using Python here? No, no autonomous Python here. That's different course. That's Gen AI course. Okay. No autonomous over here. Here we will learn the very basics, how to code, how to understand different libraries, and how analysis can be performed. We will not rely on any tools. First, learn the basics. Then only you will be able to analyze the results of the Gen AI or the AI tool, whether they are correct or not. Got it? Is this point now clear? Right? So I understand now learners have more confusion. There is so much to explore, even at my level. Being in this field for the past 16 years, I have to learn a lot, and there are so many tools which, are there still open in the market, which I have to learn, explore, and they are really, really helpful to us. So what level of statistics knowledge is needed? Yeah. Statistics knowledge, very basic statistic knowledge is required, I'd say, in terms of mean, mode, median, the graphs, the charts. I think so that's more than enough. And probability is going to play a major role. In whole of AI, machine learning, probability has a major role to play. So few concepts of probability would also be covered. Got it? Yeah. Okay. So now if we talk about data, data can be divided into two main parts. First is categorical and second is numerical. Categorical data, what is categorical data? Which can divide it into categories. For example, what is your marital status? Are you married, divorced, widowed, etc., single, etc.? Which political party do you belong to? Do you belong to the dominant, Dominican, Republican, nationalist? What kind of party do you belong to? Eye color, do you have eyes green, blue, brown, black? What kind of eyes color do you have, right? So categorical data. Then numerical data is further divided into discrete and continuous. Here I'm talking about absolute technical knowledge, how we understand data for analysis. And if I talk about discrete data, they are nothing but the counted item, the number of children, defects per hour. And if we talk about the continuous data, right, it is all about the weight, the voltage. That means the data can range infinity to plus. For example, the weight, of any object can vary from 0 to 10.37 grams to 115.34 kilograms, or even more than that. So it's continuous. That means it can take decimal values. Getting my point? Clear? Right? So now let's understand how practically data science is used in the real world or in for the business domain. Let's try to understand that particular point. So if we talk about data science is basically, used, or the model that it works on it is known as the DIKW model. So what do we mean by DIKW model? DIKW model stands for D stands for data, I stands for information, K stands for knowledge, and W stands for wisdom. Okay. So let's understand it with a simple example what these terms mean. Data is raw facts and figures we understand. For example, sales of a car company for the last 1 year. So data is nothing but the sales of the car company for the last 1 year. Processed data. Please try to understand there is a slight difference between data and information. That processed data is known as information. What do we mean by that? that now when I have the sales of the car of the company, which are the months which have maximum sales? Maybe I can represent it with the help of dark blue, and the green ones, with the minimum sales of the month. Getting my point? Are you understanding? So this is where statistics comes into the picture, finding maxima, minima, average, right? The standard deviation, the variance of the data. Getting my point, learners? Right? Now, if I talk about this data information, this is we are talking about last 1 year, but knowledge is comes with experience. Knowledge will always come with experience. I'm very knowledgeable. It doesn't mean that you worked very in 1 year and you know the experience. So rather than taking the data for the last year, I talk about the data for the last 5 years. What I try to observe is that the same pattern is getting followed, that during the month of festivities, maybe during Navratras, Christmas time, or those times, the sales of the car increase. This is what I have. I don't observe it in my last year, but for the last 5 years. And there are few months where the sale is very, very low, right? So this is the insight. This is what I detect from this data, the pattern, or this is the insight that I get. And using this insight, the wisdom, that means now how I can use this knowledge, this wisdom, this insight to impact my business. So now I can tell my sales and marketing team to apply more offers during the maximum during the maximum months. So how my sales and marketing team can work to have more impact on the business. Did you get this point, Sudhanya, Upadhyay, Hetze? So how we are actually using the data to have impact on the business. And I'll give you one very practical example, which was, it's like, it's now old. It's like 24 years old, right? Because now we are living in 2026. It's a 24, no, it's a 22-year-old example. Still, it has a lot of impact. That there was a hurricane, Francis, was about to hit the Florida's Atlantic coast. But it was Linda M. Dillman, Walmart CIO. She pressed that it's better to analyze the data that Hurricane Charlie struck several weeks earlier. So what she says is, right? So the idea is that that she thought that one hurricane which struck 2 weeks before, right? Let's analyze that data, that what people were buying, what was the data or the history that shows, and that thing can be applied to this hurricane also. So what do you think are the items that people would like to buy when, I say there is a natural calamity. Now we see these events a lot. So there is a natural calamity about to hit. What are the things that you think that, people would want to buy more? Basically that's the idea. So what our idea says that when there is a natural calamity which is about to hit, so the Walmart's people would actually think that people would buy more of the bottles, the flashlight, the groceries, the food items, right? Exactly, the shelter materials. Absolutely correct, Upadhyay. But in the actual scenario, the same thing happened. What happened is the New York Times reported that the experts mined the data and found that the stores would not indeed need certain products, just not the usual flashlight, but it was the strawberry Pop Tarts increase in sales like the 7 times the normal sales rate. And ultimately, yes, Miss Dillman agreed that the pre-hurricane top-selling item was a beer. So can you imagine this thing? What was the item which actually came out to be a big hit and that proved a big profit to the organization? It was not what we think logically, but what the data speaks after the analysis. Getting my point? Are you understanding the power of data analysis and data science now? Everybody is getting this point, and it's 22 years old, right? Example. Okay. So here I've just prepared a few, quick. Okay, we'll do the Python questions later on. Let's start. Yeah. Yes, Sivagami, share it. The example says that the hurricane was about to hit on the Florida's coast, right? But a hurricane had hit before that. So she said that let's, start doing analysis of the data where the hurricane hit it before. So during the analysis they found it was not the grocery items or the essential items which were a big hit or a sale, but it was the strawberry pop tarts or the beer item. The sales had increased 7 times. Got it now, Sivagami? Now, why it was that? That's another level of exploration, Upadhyay. You can check it out on the net, because this is a right example taken, right? But ultimately something beyond what our logic says. That what the data speaks. That is what is your role as a data scientist, to explore something more than what we understand and what the data speaks. Got it, Malipudi? Devika, Sivagami? Hetse, Karthik, Kiryana, Kamal, are you all getting my point? So if you have downloaded the reference material, I request you all to download it. And now we begin with our lesson number 2 to understand what is data science. Yes, learners. Are you understanding? And the PPT that I'm sharing at my level, I will be sharing it after the session, right? Whatever material is shared by me beyond the LMS, I will share it on the LMS. Okay? Got it, everybody? Are we good to go, or still anybody has any doubt? Please let me know. All right. Got it, learners? So in this particular lesson, we will understand what are the basics of data science, how the different data science processes steps are carried out, what are the different packages used for data science, and different types of plots available for visualization. All right, so we begin. So now do we understand the term data science, learners, in a more better way? So data science is a multidisciplinary field. Why multidisciplinary field? Because it does not only involve computer science or programming language, but statistics, maths, linguistic, every field is there, and which uses scientific methods. We will don't draw conclusions randomly. The conclusions are drawn on certain facts and experiments. It's, we don't randomly accept any facts. Got it? So the field that uses scientific methods, processes, algorithms, and systems to derive meaningful insights from structured and unstructured data. What do we mean by structured and unstructured data? Structured data refers to your tabular data, such as your Excel files, your CSV file, SQL data are all structured data. And what do we mean by unstructured data? Anybody who understands this term? What do we mean by unstructured data? Yeah, audios, videos, log files, all come under unstructured data. Absolutely correct, Mansi. Absolutely correct. Clear? Is the definition now clear to everybody? What is data science? So using a search engine or making a purchase on the Amazon provides valuable data to the data science driven software systems operating in the background. Data on interactions with online platforms is gathered to understand user preferences and suggest search results or items to buy. So the idea is to give profit to the business, to give more meaning and insights to the whole idea. So, data science, as I told you, is a combination of subject expertise, scientific methodologies, and technology, such as mathematical and statistical model, scientific tools and method, such as Python, which can operate not only on Mac, even on Windows, even on Linux. Different design, different libraries are available, and different data processing tools are also available, which help in data science, such as Tableau and Power BI are also very, very important tools. Even SQL is an important tool, right? 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 So now if we look at the application of data science, which we see all around us, for the first, application is in healthcare. So we all wear smartwatches, right? So our smartwatch is capable of telling our health. They are able to calculate the BP, the temperature, how many steps we are doing, and how many, and it tells if you're sitting for long, go and take a walk. And is it helping out? Are the smartwatches even? You might have heard about the story where the smartwatch was able to predict that the person is having a heart attack, and then the person was able to rush to the hospital and get itself cured. That's the prediction which the smartwatch had made. Have you heard that story? You can check it out on internet. So that's the advantage. Sometimes your BP is getting low, your temperature is getting higher, you stop activity. So your smartwatch was capable enough, because your movement and your body symptoms were different. So it was able to predict that. So all the data gets collected, it gets transferred to the server and can be analyzed and can help you in giving more informed decisions, in improving your health, in getting a more diet or more calorie conscious person. So that's how it can help in decision making. Getting my point? Is this example getting clear to everybody? Yes or no? Only to Arun? Only to Arun? What about others? Come on, learners, you can respond. Devika, Dhruv, Kritika. Okay, that's great. Another example that we see normally, and we never realize that this is data science, that whenever we are typing into the Google prompt or anywhere, it keeps on recommending the words, whether we want data science in healthcare or a data science in healthcare research paper. These kinds of recommendations are there. So which make it fast, and real-time analytics is made possible by modern and advanced infrastructure tool. Now, there is a big change in this kind of technology also. Now, what is the technology that we generally use? Anybody who can give an insight? There is, when we are doing any kind of search in today's scenario, are we generally typing? Generally typing? Then what are we doing, Tulla? Then what are we doing, Tullapati? Tell me. Can I call you Krishna? Not really autofilling. No. We are generally speaking, talking to the machine. Okay, now tell me. AI is a general word, Uday. Yes, through voice. We are now the machines are capable of understanding what we are talking to them, isn't it? Come on, search this for me, this image for me, that image for me. We are talking. We don't even want to type, isn't it? Getting my point? Is this point getting clear to everybody or not? And this is again a part of AI which comes under the domain of NLP. Please try to understand technically. This comes under the domain of NLP, that is natural language processing. Okay. So of course, that's not part of this course. We are just here to understand data science, and the journey is a little bigger, that you have to understand then machine learning, deep learning, then NLP, and then the computer vision, etc. Okay. In finance domain, again, data science has a major role to play. Are you applicable for a loan or not? So when you want to file an application, you file like What is your earnings? How many dependents do you are there in your family? Are you, do you have a medical insurance or not? What is your CIBIL score? So based on the data analysis, your credit card, credit history, approved amount and risk, a decision can be taken whether you will be granted loan or not. Clear? So somebody into the banking domain. NLP, Sivagami, is natural language processing. All right. So I think so now the data science, how practically it is impacting our lives, that point is getting clear to everybody. Now let's understand the different steps in data science process. First is the problem definition. We need to understand what kind of problem we are looking at, right? You should be clear with the definition. What is the project? What are the people involved in it, right? Once we are clear that why do we want to do analysis of the data, then we move on to data collection. Very important point that now data is in different forms. There's variety of data, structured and unstructured. Data coming from different sources. There's variety of data. So integration of the data is also important. And the third and the most important thing is integrity of the data, or rather not the integrity, authenticity of the data. That data needs to be reliable. If you are working with fake data, will you ever get correct results? If you are working on fake data, will you ever get correct results? You will never ever get the correct results. Getting my point? Right? So we have problem definition, data collection, and here we have data cleaning and exploration. Got it? Right? After you do the data collection over here we begin with data science, that practically we would work on data cleaning and exploration, then move on to feature engineering, that the categorical data needs to be converted into numerical data. Data binning is important, feature scaling is important. So till here, we are going to work over here in the data science, right? This course will cover up to this particular point. Model building, training are part of the machine learning and the deep learning course. Okay. So model building and training are the part of the machine learning and the deep learning course. Then we'd go ahead with model evaluation and final deployment. Clear? I hope you are understanding is this journey, that is what all we are trying to cover in this data science journey of ours. Yeah. Difference between data cleaning and feature engineering. Data cleaning is cleaning of the missing values, null values, duplicate values. Feature engineering is transforming the data so that the data can be fed into the model. Cleaning and exploration is only dealing with null values, missing values, duplicate values. But feature engineering is preparing the data so that it can be fed into the model. Got it, I'd say? And whereas feature engineering, as I told you, involves scaling, binning, winsorization, encoding. These are the, concepts that we will understand in feature engineering. So now are we clear? The first step is defining the goal or the question to be addressed through the data analysis, forming the foundation or for the subsequent steps. Data collection is gather relevant data sets or information sources necessary to address the defined problem. Data cleaning and exploration, pre-process the data by handling missing values, outliers, other inconsistencies, and explore the data to gain insights. All right. But feature engineering is transforming the features data set so that it can be put into the model's performance. Model building and training, we need to understand different algorithm analysis so that we can feed into the data, and ultimately it is evaluate, optimize, and fine tune the model for peak performance. Python is a preferred language for data science because it's a high level language, readable language, interpretable language, and moreover, it supports multiple packages such as NumPy, Pandas for data cleaning, exploration, and visualization. For visualization, we would be covering Matplotlib, Seaborn, and Plotly in detail. Got it? So that is why this course is little advanced on the basic Python, that we would straight away start from these libraries such as NumPy, Pandas, etc. Got it? As I've been telling you why or what is the biggest advantage of Python, it's an open source interpreted high level language, right? That supports object oriented programming, ease of use, simple syntax, scalability, availability of the wide variety libraries, compatibility with all major operating systems, creation of new data science libraries daily by vast number of online communities, because it's an open source language, so it has wide variety of community, powerful visualization, etc. Clear? So the different packages that we are going to cover in this particular course are NumPy. We'll start with NumPy. It is a Python library for scientific computing, supports large multi-dimensional arrays, matrices, and includes comprehensive mathematical library. Then we will move on to Pandas, which is efficient storage and manipulation of the structured data. After Pandas, we'll move on to SciPy. It's a scientific Python open source library on top of NumPy, which is used for implementing the scientific formulas. Stats model is another library which is used to estimating many different statistical models and conducting statistical data exploration. So we have understood statistics is going to be an important part of data science. So there are certain libraries which help in implementing, doing the statistics part of it. Then we have the Scikit-learn, which is widely used open source machine learning library for Python and known for its simplicity also, right? So Scikit we would not be doing in a lot of detail because it's mostly used for machine learning. And if you talk about deep learning, it is the PyTorch and as well as the Keras, which is mostly used as the frameworks or the library. Yes, but we would be covering in detail the data visualization library, that is Matplotlib, which is used for building static, animated, and interactive visualization for different graphs such as line plots, scatter plots, bar charts, histogram, pie charts, etc. Got it, learners? And if we talk about Seaborn, Seaborn is a data visualization library in Python that is built on Matplotlib. Then we will also cover Plotly for creating interactive publication quality graphs and visualization, and it is suitable for web-based applications also. Clear? Are we getting all the points till here? Any questions, any doubt till here, learners? Just a question. Is it necessary to learn arrays? Where do we apply? Oh, we are going to learn a lot about arrays, Mansi. And it has immense applications. Okay. All the unstructured data, audios, videos, images, all are stored in terms of arrays. Okay. So that's the first thing we'll start with. So nothing to worry. Okay. So let's do a quick revision of different graphs, types of plots with example. Let's do a quick revision. So the first type of graph is a line plot. What does a graph consist of? A graph consists of x-axis and then y-axis, right, learners? A graph consists of x-axis as well as y-axis. And the line plot, what does it do? It is nothing, but it is always connected by straight lines, often used to visualize trends or relationship between two variables over the time. So what are the graphs which show any changes during the time? It could be the weather report, it could be stock market, it could be the sales over a month, right, which help us to take investment decision. Agreed, learners? And if I just to make the appearance better of the line plot, I can add markers to it, specific data points where there is a dip in the sales or when there is a rise in the sales or any kind of temperature, or it could be any other entity. So a marker plot displays data, even it could be your marks of a subject, right? Result of any, college, school, university, right? So a marker plot displays data points with markers, useful for scatter plots, visualizing individual data observations. So a marker plot is used to display individual data points on the map, such as marking specific locations for the survey. Great, Sudhanya. Great. Then we also have this scatter plot. Scatter plot is nothing. It is a collection of points plotted on two axes, horizontal as well as vertical, right? So over here, both the X and the Y axis are numerical data. For example, if I want to find out the relationship between height and weight of a person, the sales and the price of petrol. So where both the quantities are numerical, then we use the scatter plot. So scatter plot analyzes the relationship between two variables, like comparing the height and weight in the population. Clear? Are we understanding the different plots? And another important graph is the area plot, which is also known as the stack plot. Please try to understand the area plot is also known as the stack plot because it is built on one on top of each other. An area plot represents data with shaded areas, useful for showing cumulative totals or proportions over the time. So an area plot visualizes the cumulative data which changes over the time, such as tracking total sales. So for example, if I want to keep track of the sales of a company, but this represents the first quarter sale. And I think so we all are familiar with these graphs. We all understand these graphs. Let's say it's a very common popular graph, which is known as the bar graph, which is used for categorical data, which shows the rectangular graphs that show vertical and horizontal data comparisons based on the other axis, usually x-axis, right? So this is the data 1, 2, 3, 4, 5. It could be the sales, the prices for comparisons, right? And grid plots where we divide the map or the graph into different uh, horizontal and vertical lines, which help in assisting chart viewers in determining what value an unlabeled data point represents. So grid plots understand each value of the data points in detail, and it also helps in enable side-by-side comparison of the multiple plots, enhancing visual analysis. It gives the distribution of the data, and this is for numerical data. Please try to understand. This graph is used for numerical continuous data. Whereas if we talk about the bar plot, it is used for categorical data. Here is the technical difference. They both are not the same. All right, learners, please try to understand things more technically. That bar charts are used for categorical data, and whereas histograms are used for numerical continuous data. And of course, they give the distribution of the data set by dividing the values into bins. What are bins? Dividing it into these small groups, right? And representing the frequency of each bin with the bars. Got it? So histograms visualize the distribution of the numerical data like income levels or the exam scores, and they help in finding the characteristics of the data, the underlying patterns, and guiding decision-making process. And last but not the least, I think so this is the graph which almost everybody uses. That's the pie chart where, the whole entity is taken as and parts of that entity are taken as its fraction or the pie, right? We all understand this graph, which is a circular graph in which data are plotted when components and as a segments of pie. And the idea is it shows the proportions of the whole, like the market shares or survey responses. Got it, learners? So finally, a quick recap of what we have done in this lesson number 2. That data science involves the analysis and interpretation of the data to generate actionable insights. Now, have we understood the definition? Right? And now, after this understanding, we will start working on the NumPy library, that is numerical Python, which is nothing but an open source library predominantly used when working with arrays. Seaborn is a data visualization library in Python that is built on top of Matplotlib. And Python is a preferred programming language for data science projects across the industry. Now, so NumPy is the advanced numerical Python library available, right? And as we understand that Python is totally an open source library, so it has this open source community which helps in moving with the NumPy. So I'll just send this link to you. Please check out this NumPy link. Since Python is an open source community, all the data things are available. That NumPy helps us to create powerful n-dimensional arrays, numerical computing tools, open source, interoperable, performance, easy to use. All these things are the practical use of NumPy library. Here you can run the code also, and it can be used for Pandas, stats models, signal processing, image processing, graphs, network. It has enormous uses. Got it? Mansi, I think so. That was your question. Sagnik, Sivagami, Lakshay, are you all getting this point? Right. So this library has lots of uses. Now let's start exploring this library. Okay. So fundamentals of NumPy, this is the link which is there. So NumPy is a numerical Python package which is free, and it is an open source library that is mostly used for mathematical operations in scientific and engineering applications. What are the other advantages? It is a Python library used for working with arrays. It consists of multi-dimensional array of objects and collection of functions for manipulating them. It conducts the mathematical and logical operations on array. So it's a very, very powerful library which helps us to perform different mathematical operations on array. Another important point to be noted over here is the array object in the NumPy is called the n-dimension array. So NumPy is a numeric Python. It is a package for computation for creating homogeneous n-dimensional array. Can you all tell me what does the term homogeneous mean? Can you tell me what does the term homogeneous mean? So the arrays are that they consist of same data type. What does the term homogeneous mean? That the arrays are of the same data type. We will understand it practically. So what are the different properties of arrays? Arrays are mutable. What does the term mutable mean in Python? We understand that arrays are mutable. What does the term mutable? That can be changed or modifiable. Absolutely correct. Let's say by the user, so it's modifiable. Second, it is homogeneous. What does the term homogeneous mean? What does the term homogeneous mean? They are all of the same type. Absolutely correct. Can be accessed using integer position. As we can access different elements using list and tuple, similarly, it can be accessed using integer position, that is indexing. What are the two types? Yeah, what are the two types of indexing available in Python? Great, Mansi. What are the two types of indexing available in Python? Positive as well as negative indexing. Very good, Arun. Arrays always deal with numeric data. And third, last but not the least, it has high performance in calculation. That's the beauty of NumPy arrays. So now let's understand how are arrays different from the list. So the first and the foremost point is that list consists of heterogeneous data. That means it can consist of a numerical value, integer value, float value, Boolean value, as well as string. And it also stores the pointer to the data location. Please try to understand. It also stores the pointer to the data location. And when I talk about NumPy arrays, it only stores the data directly, and that too in continuous memory locations, one after the other. Therefore, accessing the elements are faster and easier. Is this point getting clear to everybody? And can anybody tell me which memory address are we talking about? What, not memory address, rather, which memory does the data or the variable get stored? Excellent, Mansi. You were very quick on that. Yes, it is the RAM, the volatile memory, which stores all the variables. Clear? Is this point getting clear to everybody? So how do we go about creating arrays? First and foremost, it is not part of the basic Python. Therefore, we need to import the library. Import NumPy as NP. So we need to import the library. Second most important thing is np.array is the name of the function to create the array. So if I pass the value as 0, 1, 2, 3, the array will get created. And how do I know whether it's an array or not? By using the type function, I can know what is the type of A, and it belongs to class numpy.ndArray. NdArray stands for n-dimensional array. Then the different attributes of the array are a.ndim. A.ndim gives the dimension of the array. It belongs to one dimension. Shape gives the number of rows and columns. So this data consists of 4 columns. So therefore 4 value. And the number of items is 4. Therefore the value of the length is also 4. Are you all getting this code, or do I need to repeat this? Yes, learners, are you all getting this code, or do I need to repeat it? Everybody got this? How do we create arrays? That we import the library. Then np.array is the function to create array, and these are the function which give me the type, the dimension, the shape, and the length of the array. Got it now? Right? Now, do we understand the range function in Python? Do we understand the range function in Python? Right? Yes, when I give range 40, that by default, it will start from 0, right? And it will go till 39. It will start from 0 and go till 39, right? So we have np.arange function, right? And by using the shape attribute, I am now changing these 40 elements into two-dimensional array with rows equal to 5 rows, and columns equal to 8. Clear? So it will consist of 5 rows and 8 columns. Getting my point? Can I change its shape to 8 rows and 5 columns? Can I change its shape to 8 rows and 5 columns? Yes. Why? Because the number of elements is the same. 8 into 5 is 40. Can I change it to 4 rows and 10 columns? Or vice versa? Yes. Can I change it to 4 rows and 4 columns? No, because it consists of 16 elements. Can I change it to 2 into 2 into 10? Can I change it into that into 3-dimension? So that's the beauty of arrays. So what do we mean by one-dimensional array? One-dimensional array consists of only one axis. Therefore, the shape consists of 4 since it consists of 0, 1, 2, 3 columns. And one-dimensional arrays are also known as vectors. Getting my point? One-dimensional arrays are also known as vectors. Two-dimensional array, it consists of axis 0 and axis 1. Axis 0 refers to the number of rows. It consists of 2 rows. Axis 1 means columns. It consists of 3 columns. Therefore, the shape becomes 2, 3. And two-dimension arrays is known as a matrix, right? 3D array, you can consider it as a slice of bread. When you buy bread, they are slices. So you can consider axis 0 as the slices of the bread. So there are 4 slices. Each slice consists of 3 rows and 2 columns, right? So the 3D array, the axis and shape are strongly connected with each other. Whatever is the dimension, that many axes you will have, and that will define the shape of the array. Clear? Is this point getting clear to everybody? And if we look at the different attributes of an array, it consists of its shape. Shape gives me the number of dimensions of rows and column. Ndim gives me the dimension of the array. D type gives me the data type of individual array. All right. In 32, 32 represents the number of bits required by the operating system to store. So 32 refers to the number of bits. And if we divide it by 8, why 8? What is 1 byte equal to? What is 1 byte equal to? What is 1 byte equal to? Nobody knows in this batch? 8 bits. So when I divide this 32 bits by 8 bits, I get the answer of item size in terms of 4 bytes. Got it now? Are you understanding all the attributes, learners? So have we understood the advantages of NumPy? That it provides an array object that is faster than the traditional Python list. It provides supporting functions. Arrays are frequently used in data science and they are stored in continuous place in the memory, unlike list. We are understanding all these points. So now you can run this first code. Whatever code you feel is missing, you can ask me. I can give you the code or you can type in, right? First, try to find out the version of your NumPy file. Tell me, learners, run this code and tell me the version of your NumPy file. Quickly. Sivagami, Sagnik, Kamal, Devika, Hetse, Upadhyay, tell me the version of the NumPy. None of you are able to run the code? Good, Mansi. Mansi has 2.13. Kamal has 1.24.4, even older version than mine. We've installed Anaconda 2.35. Arun, that's pretty latest. It's double underscore. Yes, it's double underscore. Okay. So what is the first and foremost thing? So everybody is able to run the code. Nobody is getting any error. Everybody is able to run the code. Nobody is getting error. Great. Okay. So what is the first thing that we are supposed to do? We are supposed to first import the NumPy library, right? Do we see the code? Right? And then we are printing this array. The type of array it belongs to is n-dimensional, right? Sorry, the type it belongs to class numpy.nd array. The dimension is 1. The shape is 3, the length is 3. And the data type is that they all are of integer data type. Are you able to run this code, everybody? And if I create the array of a string, come on, this code, this code is not there in your file, right? Copy it. So if I create an array of name, right, this also belongs to numpy.nd array. The dimension is 0. Why? Because there is only one word associated with it, right? So the dimension is only 0. And the shape is again 0. And the data type is Unicode 11. So the string data type is stored as Unicode 11. Learners, are you there with me? So if I have an array, right? Now what do you see? Let me remove this, and now 1, 2, and there is this 1 float type, all others are integers. So what do you see the output? It makes the integers as floating point. Why? Because arrays are homogeneous data structure. They contain the same data type, right? So all the elements now become of float 64 type. Got it, learners? All the elements become of float 64 type. And the moment I add a string onto it, you see the output now. All the elements have become of the string data type, and now the data type is Unicode 32. The elements over here is Unicode 32. Got it? And now let's start creating NumPy arrays and multi-dimensional array. So the array with 0 dimension, that is only with one value, is known as a scalar value. Please try to understand this highlighted code. An array with one value is known as the scalar. So any one value, I've put it as an integer floating value. So the 0-dimensional array is known as scalar. One-dimensional array with one axis. Can you go back to the data type? Which data type? The previous one? Let's say. Yeah. Yeah. What is the confusion? The data type is Unicode 32. And you might say that, ma'am, here it is Unicode 11. Right? So it automatically decides. Seems it's becoming a list instead of an array. No, this is array only. It's like an array, but here it's a scalar value. Here it is a scalar value. Got it? Here the list is converted to an array. Now clear? Are list homogeneous or heterogeneous data type? List and tuple are homogeneous or heterogeneous? Heterogeneous. But arrays are homogeneous. Okay, that's also one big point of difference. Okay. I have a question. Does one data type supersede the... Yes, yes. The floats are superseding the integers, and the strings are superseding the integer values. Do you see this? So if I define one of them as string, all of them are becoming string. Yes, yes, yes. Good question, Mansi. But the irony is, that being a numerical Python library, it gives more preference to the string as compared to the numerical value. Isn't it? Isn't it ironical, Mansi? Since it is a numerical Python library, it should have more advantage, give more advantage to numerical value and nothing else, right? Very, very ironical. Yeah, that's what, that's the analysis which comes up. Clear? Now clear? Hetze, is your issue resolved? No. So here we have this scalar value. Then we have one-dimensional array. One-dimensional array is known as a vector. Two-dimensional array is known as a matrix. Now, a quick trick how to understand one-dimensional, two-dimensional, that if you have these double squares, that means it is two-dimensional. And if you have these triple square brackets, it's three-dimensional. One, then one. And if there is nothing, then zero-dimensional. Are you understanding this quick tip and trick, everybody? Right? Are you able to see the output? Everybody? That if this is the output, it's a zero-dimensional array. This is one-dimensional. This is 2 rows and 3 column. Now look at three-dimensional array. Since it consists of 2 matrices, the first axis becomes 2. Second, each matrix consists of 2 rows. Therefore, the next dimension is also 2. And each matrix consists of 3 columns. Therefore, what is the shape of three-dimensional array? 2, 2, 3. Got it? That is why the shape is 2, 2, 3. That is, it consists of 2 matrices with 2 rows and 3 columns. Sivagami, Sudhanya, Turlapati, are you all able to do it? Uday Kumar, Deepak VK, Upadhyay, Kamal. So are you feeling the need of, the basics is missing, Upadhyay, the beginner level? Are you feeling difficulty in the code? The learners who were saying that they don't know the basics of Python, are you able to cope up with this code or not? Or who all is facing difficulty? Sagnik says need to learn the basics. Are you finding it difficult, Sagnik, to interpret the code? Sagnik, so my suggestion to you is, rather than, struggling in this particular session, it's better you take up the Python refresher course. That will make the concepts of Python more clear, and then you can get back to this course. I would suggest that, Sagnik. The learners who are facing difficulty in loading, understanding this code, then I don't think so it is point going forward, because the code is going to get more complicated with NumPy, Pandas, then visualization. So I request to all those learners who don't know the basic of Python should go through the basics and then get back to the data science course, right? Or Sagnik, you would have to put in more effort to understand the basics. Got it? Anybody else who's facing difficulty, who's finding this course tough, very tough, irrelevant? A quick feedback on that. Sudhanya, Shivagami, Tullapati, Uday, Deepak. Would we learn the applications of array with examples? Yes, we are learning the arrays with examples. Yes, because when we, not here in this, but as we move to linear algebra and when we understand deep learning, then of course arrays will come into the picture. Rather, tensors are all n-dimensional array, Mansi. It's not an error. It says that the memory has been exceeded. So that's the disadvantage, that it is, the list is unable to store the huge amount of elements. Have you got this? Have you understood this point practically? And secondly, percentage time. This is a magical function, the percentage time, which helps us to calculate the time required to multiply these 1 crore elements with 10 times. So this loop works 10 times for I in a range 10 and array into 2, right? So now when I run this, I get this output in terms of 234 milliseconds. And if I want to see the output, same output for the list, what is the time it takes? You see, it takes much more longer than what arrays were taking. It's still not giving me the output. Let's see. So it takes 13.2 seconds. Do you see the huge amount of difference? Yes, learners, are you able to see the difference? So which one is better? Arrays or list? Arrays. Arrays are much faster in communication. That is why arrays have been built. This library of homogeneous data points has been built. Clear? Everybody has got this point? Learners? Now let's move on to our next slide, file. Yeah, that is 3.02. Upadhyay, what we are talking about over here is that we see that the time taken by performing the same function on arrays and list take much longer time to do the same operation as performed by arrays. So definitely arrays are much more faster and efficient than list. Now clear? So what makes arrays faster than the list? You tell me, Mansi. I told you the reason. What is the reason? I told you the reason. How are arrays stored in memory and how are lists stored in memory? The memory allocation part. That NumPy arrays are stored in one continuous place in the memory, whereas list stores the pointer to the data. Now got it? Is this point getting clear to everybody? Now I want everybody to be ready with this 3.02. So what are the different attributes of NumPy array? The first is the endim dimension, which gives the dimension of the array, the shape, the size, the data type, as well as the item size of the array. Yeah. So have you been able to load my file, everybody? So what is the first thing required to create NumPy arrays? What is the first thing that is required to create these NumPy arrays? We import NumPy as NP. Yeah, the library. Can you tell me the dimension of this array? Can you tell me the dimension of this array? Why? They are only, how many square brackets are there? 2. So it has 2 dimension, right? So the dimension is 2. The shape is 2, 3 because it consists of 2 rows and 3 columns. Size, it consists of 6 elements. The data type is integer type. The item size is divided by 8, and array.data gives me the memory location. If I look at the output, yes, learners, are you there with me? So this is the array, this is the type, this is the dimension, shape, size. Array stores integer 32 divided by 8. So the size of one array element in bytes. So each element takes 4 bytes of memory, and array's data is at memory location this. No, good to go. So now if this is my again two-dimensional array, size of one array in elements is 8 for me. Yes, Mansi, then this must be int 64 for you. This must be 64 for you. 64 divided by 8 is 8 only, 8 bytes. Got it? So it depends upon your system. It depends on your operating system. Okay, Mansi? It's system dependent. Okay, learners? Okay. So moving ahead over here. So dimension is completely based on the axis. Axis 0. What does axis 0 represent in a matrix? Tell me quickly. What does axis 0 represent in a matrix? Or in a two-dimensional array? No. No, it represents the columns. Oh, sorry, the rows. Axis 0 represents the rows. Okay, Mansi? Axis 0 represents the rows, and axis equal to 1 represents the column. Very good. Got it, learners? Shape gives me the size of the array. The output data type is always tuple. So what is the shape? It consists of 2 rows and 3 columns. This consists of 3 rows and 2 columns. Got it? When I talk about the size, it is the total number of elements in the array. It is equal to actually the total, multiply it. 2 into 3, 6. So here the shape is how many elements? 3, 4. If you look at this particular matrix consists of 3 rows and 4 columns. So what will be the size? 3 into 4, 12. Got it? Yes, learners. Are you getting this? Moving on to the data type, it shows the data type of elements in the array. NumPy in 32, NumPy float 64, and NumPy in 16, and NumPy in 64 also. It all depends on the operating system used. It completely depends on the operating system that how many bits are being used to represent that particular element. Got it? Yes, learners. Is this point getting clear to everybody? And of course, item size shows the length of one array element in bytes. So float 64, 64 divided by 8, because one byte is equal to 8, it is equal to 8 bytes. Complex 32 divided by 8, it is equal to 4 bytes. And numpy.array.data is an attribute offering direct access to the raw memory of the NumPy array. Got it? Clear, learners? Any questions, any doubt till here? Turlapati, Sagnik, Kamal, Sivagami? Mansi, Etse, Kamal, Upadhyay, Devika? No? I hope these PPTs are helping out in understanding the concepts better. The PPTs that I prepared for you all. Are they useful, Mansi? Yeah. So now let's understand some basic functions of the arrays, right? The first function is transpose. What does transpose do? It interchanges the rows and column. No, they are not from the LMS, Hetski. I will be uploading it after today's session. Okay. I'll be uploading it on the LMS after today's session. Okay. So nothing to worry. There's nothing to lose. Right? So transpose is interchanging the rows and column. So if we look at the shape of this array, it is 2, 3. And when I use the transpose, it becomes 3, 2. Right? It becomes 3, 2. Clear? Right? Another function is flatten. It converts any array, any n-dimensional array to one-dimensional array. There are two ways to perform this flatten function. One is in row major order, or we can give order is equal to C with the parameter equal to C. Now, what does row major means? That first the elements of the rows are flattened, and then the second, elements of the second row, like 1, 2, and 3, 4. Column major order, this is like one elements of the first column, and then the elements of the second column are flattened using the parameter order is equal to F. Getting my point? Is this point getting clear to everybody? Again, when I say a dot flatten, by default, it is row major, that is order equal to C. That first the elements of the first row, then the second row, and so on. But if I have passed explicitly order equal to F, then the elements of the columns get flattened. No order code for row major. Yeah. By default, it is row major only, but if you want to pass the parameter, you can pass order is equal to C. Otherwise, no need. Okay. B is equal to A flattened by default. This is a row major. Yes. Yes. Yes, Mansi. Yes. And then we have the reshape function where you can reshape the data from one dimension to higher dimensions, and from higher dimension to lower dimension. No restriction on that. So if you look at the shape of this data, how many rows are there? 6 rows are there and one column. 6, 1 can be reshaped to 2, 3, can also be reshaped to 3, 2. Agreed? Similarly, original shape is 3, 4. It can be reshaped to 6, 2, 2, 6, 4, 3, 1, 12, 12, 1. Right? See, the multiplication factor has to remain the same, but I cannot reshape to 4, 4, right? I cannot do that. But can I reshape to 2, 3, 2? Can I reshape to 2, 3, 2? Right. Now I want to tell you one major difference, the difference between copy and view. Please look here, learners. Please try to understand the code. Right? We have created the array A over here. and I have created a copy of A and I've substituted onto X. Now, if I make changes in my original array, will there be changes in my X? No. Why? Because X points to different memory location and A points to different memory location. So if I make changes in my A, it does not get reflected in 4 in X. Getting my point? But if I create a view of this B array, whatever changes I make in B, that are reflected in my X. Because why? Because B and X are now pointing to the same memory location. Getting my point? Is this point getting clear to everybody? So now let's understand these concepts practically. So getting back to 3.02. Right. So first is the reshape function, which helps us to create a new shape of the current elements of the array, provided they have to be of the same, factors, or rather the same elements. So if I have created this one-dimensional array of 12 elements, this is how I get the output. Learners, are you there with me? Yes, learners, are you there with me? Everybody is able to run the code? Now, can I change this dimension of one-dimensional array to 12, 1? Is it possible? Can I change it to 12, 1? Yes. Can I reshape it to 3, 4? Yes. Can I reshape it to 2, 6? Very good. And can I reshape it to 3 dimension with 3, 2, 2? 3, 2 means the number of slices or matrices. 2 represents to each row, another 2 represents to the column. So these are my 3 matrices with 2 rows and 2 columns. So this is my 3 matrices with 2 rows and 2 columns. Got it? Can I reshape it to further dimension? That is 2, 3, 2, 1, 1. Yeah. So with reshape, you can change it to lower dimension to higher dimensions to lower dimension. Agreed? Yes, learners, are you there with me? Great. Right. And this, if I give reshape equal to -1, it will automatically flatten it back to 1 dimension. Okay. Now coming on to flatten function, these are the parameters, arguments that can be passed. By default is C, which means the row major style as we have seen it. F stands for column major order. A and K are very less used because that was used in very older version of Python, rather used in Pascal and Fortran. So A means to flatten array elements in column major order, and if the fortran contiguous and in memory, or row major otherwise. K means to flatten array elements in order to elements laid out in the memory. So as we have seen that A and B, A is my array, B is A dot flatten. By default, it will do it in row major order, and this flatten is equal to order F, which is going to be in column wise. So Kamal, now you want a break. You're just about to end the session in the next 40-50 minutes. Still you want a break, Kamal? Kamal is asking for a break. Learners, do you want a break or no? Maybe a 5 minutes break is helpful. I can give you that. Okay, so let's get back to the discussion. So this is my flatten. So by default, we understand it is in row major order, first row and then the second row. And when I give order F, it is in column major order. This is clear. But the important point to be noted over here is that B is a copy. That means it is a new variable created in the memory. So what do we need to understand? That flatten creates a copy of the system, not a view of the array. What does that mean? That if you change elements in array B, the elements in array A are also not changed. Clear? Is the difference clear? So flatten creates a copy of it. And how can we check? If B is equal to 10, we have made changes in B that is reflected in B but not in A. Clear? Are you all there with me? Everybody is getting this point? Yes, learners. Great. Right? Now moving on to flatten function, it returns the copy of array flatten into one-dimensional array. So flatten will always create any n-dimensional array to one-dimensional array. So this is a three-dimensional array. And when I do an array flatten dot order F, what does order F mean? Column major order. So first and then 7, then 2, and then, then 4, and then 10, then 2, and then 8, then 5, and 11. Getting my point? Is this point getting clear to everybody? Everybody is able to run the code? Right, so this is how we get this array three-dimensional flatten. So if I do it by default, it is going to give me 1, 2, 3, 4, 5. Right? And when I run the transpose interchanges the rows and column. So if this is my two-dimensional array with 2 rows and 3 columns, it gets changed into 3 rows and 2 columns. Got it? Clear, learners? So if this is my array and now I reshape it into three-dimensional array with 4 rows, 4 slices or 4 matrices, 3 rows and 1 column. Yeah, I can specify the dimensions of the transpose. Yes, I can. Let's see. For the first example, if you look at over here, this is my first array. And when I take the transpose of it, the 2, 3 changes to 3, 2. This point is clear? Okay. Now look at another example. Here, what am I doing? Here, I am creating a one-dimensional array and reshaping into a three-dimensional one with the shape 4 matrices, 3 rows and 1 column. That point is also clear. I've created a three-dimensional array. Now when I run the transpose of it, so it changes the 4, comma 3, comma 1. Now do you see the transpose? This has got interchange with this and this has got interchange. So now I have one matrix with 3 rows and 4 columns. Got it? Mansi, Devika, Upadhyay, Kamal, Uday, Purla. And as you can see, every file has a assisted practice associated with it. Please look here, learners. Please try to practice this assisted practice here. Like over here, this is the temperature, list given over here, array. And once we convert it into an array, you can find out its dimension, shape, size, the data type, the item size. So with my files, Hetzki, the advantage is you get the solutions of these assisted practice also. Okay? So will you all be able to do it, the assisted practice? Please do that so that you can understand more and understand it in a much better way. Turla is ready, Hetzki is ready. Quick response, learners. Quick. Dhruv, Karthik, Kiruba, Lakshay, Madhubirta, Dharun, Uday, Sudhanya. Okay, great. Now look at over here. What are we doing? This was the question that I asked you in MCQ. You remember this question? This was the question that I had asked in MCQ. So what were we doing? That list 1 is equal to 1, 2, 3. And when I do an asterisk 2, it is not multiplying each, it is repeating the list. Agreed? Learners, are you getting this point? But if I want to multiply 2 with each of the elements in the list, how do I go about it? If I want to multiply each of the elements, how do I go about it? I have to explicitly run the for loop. Yes, absolutely correct, Mansi. I have to explicitly run the for loop. So what am I doing over here? I have first created an empty list for I in list 1 and I keep on appending each term by multiplying it by 2 into the list 2, and therefore that's how I get the element 2, 4 and 6. I mean multiply it by 2. Got it? Is this point getting clear to everybody? Other way is, do we understand this kind of notation? Anybody who understands this notation? What is this concept known as? Very good, Mansi. Only Mansi understands in this batch, nobody else. This is known as list comprehension. It saves on a lot of code and a lot of extra memory space, right? I don't need to define another list empty. List 3, I into 2, every element would get multiplied by 2 for every element in I. Just by writing this one single line, I am able to multiply each of the elements. Now clear, right? So now do you see the difference? So now if I have to multiply or perform any arithmetic operations on the list, I have to explicitly run the for loop. But look at the beauty of array. When I just write A into 2 in any for loop, directly I get the output. Or if I'm doing addition of the two, I directly get the output. So isn't it giving me fast mathematical results? Right? And how and why is it giving me? This is because it works on two main concepts. Please, very, very important point of NumPy library that we are about to understand. It runs on two main important concepts. That arithmetic calculation works on the concept of broadcasting. Please try to understand, learners. The first point is broadcasting, that is making the arrays of the same shape. Broadcasting is the process that makes the arrays of the same shape. And second concept is vectorization, that is using for loop for element by element operation. Got it? Broadcasting is making the arrays of the same shape, and vectorization is using for loops for element by element operation. Getting my point? Now, again, to make the concept clear, if it was a list, we have to explicitly run the for loop where each element gets multiplied to it and then we get the output. But in arrays, how do we go about it? I'm sorry for the pen. Again, I don't know. On this slide, it always gives me this issue. I've seen that. Anyways. So for arrays, how does it work? First, the broadcasting will happen. That is, the arrays will become of the same shape, right? And then automatically at backend, element by element multiplication will happen to get the output. Clear? Is this point getting clear to everybody? To understand it even better, let's understand it with this example. I want everybody to be concentrated here. What is the shape of this array? What is the shape of this array? Shape. I'm not asking the dimension, Hatsky. It's 4, 3. It consists of 4 rows and 3 columns. What is the shape of this array? The second array, Mansi, Hatsky, Upadhyay, what is the shape of the second array? Again, it is 4, 3. Why 5, 3, Sagnik? 1, 2, 3, 4. How come 5? Right? So both the arrays are of the same shape. Yes, both the arrays are of the same shape. That means no broadcasting is required and element by element operation is done. Element by element operation is done and then we get the output. So it is not necessary that every time the broadcasting will happen. But definitely, yes, vectorization, implicit for loop will run to perform the mathematical operations. Okay. Now look at the second example over here. What is the shape of this array? It's 4, 3 and the other one is 1, 3. Are they of the same shape? No. But the columns are matching. Do you see the columns are matching? And can I expand this 1 to 4 rows? Yes, I can broadcast 1 to 4 rows and therefore now the two arrays become of the same shape. Sorry. And therefore vectorization or arithmetic addition happens. Clear? Just give me a minute. Something slow. My net is working slow. So this is 4 rows and 1 column. And what is the shape? 1 and 3. Now you would say, ma'am, nothing is matching. Please try to understand. If one of the shape or the axis is not equal to one, the others have to match. But in this case, it has 4 rows and 1 column. So one of them is 1. Can I expand it to 4 rows? Yes. Again, over here, it has 1 column and 3 columns. Can I expand it to 3 columns? Yes. So broadcasting happens in both the arrays to make them of the same shape and size. and therefore the arithmetic operations happen. Clear? So the important point to be noted over here is that it is not necessary that broadcasting will happen. And it is not necessary that it will happen for both the arrays. It all depends on the dimensions. Now clear? Clear? Let's understand it with more examples. Please look here. Here, learners. Okay. So first of all, we have NPA range with element 0, 2. The shape is 1 row and 3 columns. This is a scalar value, so it again gets expanded to 1 rows and 3 columns, and then the vectorization element by element addition happens. Clear? Are you all getting this point? How one-dimensional and scalar values are getting added? Then NP dot ones, this is 3, comma 3. That means we have created a matrix of the shape 3, comma 3. NP dot ones create all the values ones. And what is NP dot A range? This is 1, comma 3. Now, since 3 and 3 are, if this would have been 4, it will not broadcast, it will give you an error. Since 3 and 3 are matching and this 1 can be expanded to 3, therefore both the arrays become of the same shape and we get the output. So over here, 3 rows and 1 column. Now do you see this? This gets expanded to 3 rows. 3 columns, and this gets expanded to 3 rows to make them of the same shape, and therefore vectorization happens. Have you got this? This is the most important concept of NumPy library, that why are arithmetic calculations fast? Because of the concept of broadcasting and vectorization. Clear, learners? This one, Padya? Yeah. NP dot ones means that we are creating an array of 3 rows and 3 columns with all values equal to 1. That point is clear? NP A range means that it will start from 0, go till 2, and the shape is 1, comma 3. Now, since the columns are matching over here, can I expand this 1 row to 3 rows? Yes, so it gets expanded to 3 rows. So now both the shapes are 3, comma 3, and I get the output. Better, Upadhyay? Mansi, Kamal, Uday, any doubt? Devika. But where broadcasting will not happen, where the columns will not match, or if they are not 1. Suppose if one is 1, comma 3 and the other one is 1, comma 4, right? Then if these two are not matching, then the broadcasting will not happen. 4, comma 3, the prior one, this one. This one? Yeah, what is the issue? Tell me. The concept is that if the arrays are not of the same size, then broadcasting will happen. Broadcasting will only happen if one of the element is 1 or the other two dimensions are matching. One of the element has to be 1 to be broadcasted. Broadcasting will only happen if one of the element is 1. Like this is 1, it gets broadcasted. This is 1 row, it gets broadcasted. This is 1 column, it gets broadcasted. This is 1, comma 3. So 1 row gets broadcasted if any one of them is 1. NP.A range 5, this is a scalar value. So 5 gets broadcasted into 1, comma 3. Now clear? This is, if you see, this is 1, comma 1. So it broadcasts into 1, comma 3. Now clear, Hatski? Mansi? It is not necessary that the broadcasting will always happen. If the two arrays are already of the same shape, then vectorization will always happen. It is the vectorization, the implicit for loop will always run. Now better. So now if you look at this particular example, is broadcasting happening over here? Tell me. A getting multiplied by 2 or A plus 2, is broadcasting happening over here? Yes or no? Yes, because it will make it of the same shape and then multiplication or addition will happen. So vectorization will definitely happen. Broadcast depends on the shape and size of the arrays. Clear? So the different arithmetic operations that can be performed in NumPy arrays are np.add using the plus symbol, np.subtract using the minus symbol, np.negative using this negative unary sign, np.multiplied using asterisk, np.divide. What is the difference between this and this symbol? Tell me quickly. Single division and multiple division, also known as floor division. What is the difference? This gives me the quotient. Nobody remembers. This gives me the integer quotient, right? That is 5. What is 5 divided by 2? It is 2.5 by single division. But if it is floor division, it will only give me 2. And how do I get the remainder? Using the mod. Right? If I do 5 mod 2, the answer will be 1. The remainder. Modulus or the remainder. Clear? Is the difference getting clear between the operators? That's part of the basic Python. So when I do an array with this shape and B, now tell me, is broadcasting happening over here? So one-dimensional array with zero-dimensional array. Right? If I am adding one-dimensional array with zero-dimensional array, is broadcasting happening? This is a vector. This is a scalar. Yes. Is broadcasting happening? Quick response, learners. Yes or no? Yes. It will become 10, 10, 10, and then element by element addition. Agreed? You can use np.add or a plus sign also. Let's understand subtraction. Yes, we are using np.subtract or a minus b. Is broadcasting happening over here? What is the shape of these two? This is 2, 3. This is 2, 3. Is broadcasting happening over here? No, no need. But vectorization, is element by element vectorization happening? 30 minus 10, 40 minus 20, 60 minus 30. Yes. Good, Hatski. Good. Ansi, Kamal. Now, what about here? Is vectorization happening over here? Sorry, broadcasting happening for A and B in multiplication? Is broadcasting happening over here for A and B? No, because again, they are of the same shape. Vectorization? Definitely yes. What about division? A and B of the same shape and size? Is broadcasting happening over here? Hatski, it's no or yes? It is yes, because this is two-dimensional. This is one-dimensional. So it will repeat it 1, 1, 1. So broadcasting is happening. and then we get the output. Clear? That's key. What is the shape of this? This is 2, comma 3 and this is 1, comma 3. So this will get repeated. The 1 will get repeated and the columns are matching. Got it? All right. So the power of is A and B. Again, no broadcasting, same shape. So it means A to the power B, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 6 is 64. Right? And why is it known as NumPy? Now, can you tell me, after understanding the concepts, that why is it known as NumPy? Can anybody tell me? Anybody tell me why is it known as NumPy? And why is it a homogeneous data structure? Why do we create it as homogeneous? See, basically, we are going to deal with numerical data. We don't do a lot of arithmetic calculations for strings, right? So it's the data with either be of integer type or float type. That's important. That's why it is homogeneous. It does the numeric computation fast because of the two concepts, that is vectorization and broadcasting. So this is the strong foundation whenever we talk about NumPy, right? Yeah. Because it deals with array, we create arrays. But what are the properties of that array? That you need to tell, Sudhanya. Arrays itself is not things. So when we create arrays, the properties of arrays that you need to understand is that they are mutable, that they can be changed, of the same type. They can be accessed using integer positions, right? Indexing, as we understand positive and negative indexing. And they always deal generally with numeric data, and they have high performance in calculation. And one of the basic list and an array is that list is an heterogeneous type of data which stores pointer to the data location. It stores pointer to the data location so that accessing can be done. And whereas we have this NumPy array where all the data is stored one after the other memory location. That makes its accessing much more faster. And implicitly, when we say broadcasting and vectorization, broadcasting is making the both arrays of the same shape and size. And vectorization is that implicitly it runs the for loop at the back end. Getting my point? These are the points that you have to remember while answering the questions in your interview. Simply saying that it deals with arrays, homogeneous, will not, be impactful. Now coming on to the practical part of it, how do we create arrays? First and foremost, we need to import the library NumPy, and it is the np.array function which helps us to create the arrays, right? We understand type. This belongs to class numpy.nd array. So a is an object of class n-dimensional array. The different attributes of array are endim, which gives the dimension of the array, dot shape, which gives the row and column, length gives the different number of elements in the array. And as we had the range function in array, in normal Python, range function in Python, we have the arange function for arrays in NumPy. It works exactly same as the range, which will create elements from 0 to 39, and we can shape it to 5, 8. And we are very clear that the parameters that we are passing over here is only those which are the factors of 8. When we multiply it, they should be factors of the 40. Can I change it to 3 dimension also? Yes, 5, 8, 1 can also work. Clear? Are you all getting this point, learners? Yeah. Today I'll be uploading this headset. Today I'll be uploading it because we'll be completing this topic. Once we complete one topic, then only I upload the slides. Today I'll be doing that. Fine? That's it. Is it fine? Okay. Now, the dimensions of the array. The dimension of the array is very strongly linked along with the axis and along with the shape. A one-dimensional array is also known as a one-dimension array is also known as a vector. Wrong, Mansi. Zero-dimensional arrays are known as scalar. So zero dimension arrays are known as scalar values. One dimensional arrays are known as vector value. Two dimensional arrays with axis equal to 0 and 1 are known as, it's known as a matrix. And of course, more than three dimensions are known as n dimension array. This point is getting clear to everybody? Right? And what are the different attributes of an array? The shape gives me the number of rows in column. Ndim gives me the dimension. Dot D type gives me the data type based on the operating system, the number of bits required to store that data. Item size gives me the size of one item in bytes, and size gives me the total number of elements. Clear? The attributes are also clear to everybody. To the functions. What does the transpose function do, learners? What does the transpose function do? It interchanges the rows to column or columns to rows. Either of the things can work. Absolutely correct. What does the flatten function do? What does the flatten function do? Can reshape the array to any dimension from lower to higher or higher to lower. Yes, different dimensions. So transpose is also clear. Flatten. Now flatten can happen in two ways. What does row major order mean? When the order is equal to C, this is the by default order. That means first the elements of the first row are flattened and then the next row. Or other one, we can have order F, in which the elements of the first column are flattened and then the next column. Clear? Location view is the same memory location, right? So copy is creating a new memory location or a new copy, and the original is not disturbed. Very good, learners. Good. And reshape, we have to understand it has to be in the factors of that particular number, so we can reshape the objects also. Clear? This is also different. Difference is clear. Now, when we move on to the arithmetic calculations that need to be performed in arrays, broadcasting is the first concept. That first of all, the arrays have to be of the same shape. No calculations can happen unless the arrays are of the same shape, right? And it is not necessary the broadcasting always happens, because if the arrays are of the same shape, then vectorization will definitely happen. That is when we are using for loop for element by element operation. That is the implicit running of the for loop, so that each and every element can be calculated. Getting my point? So when we are talking about the looping logic over here, right? In arrays, this talks about the explicit looping logic that we have to apply for the list. But in vectorization logic, first the two arrays will become same. That is, the broadcasting happens, and then element by element multiplication happens to get the output. And this is the power which NumPy library has, which makes its arithmetic performance faster. Getting my point? This is the power which, again, I'm repeating, NumPy library has, which makes it faster. Getting my point? So again, repeating those examples, since these two arrays are of the same shape, 4, 3, no broadcasting happens, but definitely vectorization happens because element by element addition of each element. Here the element is 4, 3 and this is 1, 3. Please remember, learners, the columns are the same. And if any of the parameter is 1, then only it can be broadcasted. The rule is that the other parameters have to be equal or 1, then only the broadcasting happens. But in this case, what happens? This is 4, 1 and 3. So if we look at rows, one of the parameter is 1. So we will expand the rows. And this parameter is 1. We can expand it to 3 columns. Again, making it of the same shape so that vectorization logic can happen. Now clear, Mansi? So Dhanya, Turla, Devika. I hope this revision is helping to everybody. And if I talk about np.arange function, right, it creates again a 1, 3 array for me with 1 rows and 3 column, and I am adding a scalar value to it, right? So this is 1 row and 3 columns. So this is 0, 1, 2, and this is 5, and therefore we keep on adding elements onto it. Clear? Right? So broadcasting is happening over here. And when we look over here, we have this 3, 3 array and 1, 3. Since the columns are same and one of the parameters or axis is 1, it gets expanded to change the shape. Similarly, over here, this is 3, 1 and 1, 3. They both can get expanded in rows and column to perform arithmetic calculations. And if there is a mismatch that the columns do not match, this is 4, 3 and this is 1, 4. See, the 1 can get expanded, but if the columns are not matching, then the broadcasting will not happen. Clear? And now we are supposed to understand indexing and slicing. So what we can do is, let me complete the theory part and then we move on to the practical file. Does it help, learners? Let's quickly do that. So there are two types of indexing in Python, positive and negative. And that indexing is supported in our arrays also, right? So if we talk about one-dimensional array, it's normally like a list and tuple. We understand positive indexing starts from the left-hand side 0 and moves from left to right indexing. Similarly, negative indexing starts from right to left. So if I say what is the value of A at equal to 2, can anybody tell me? What is the value of this array at index position 2? Can anybody tell me? So it is equal to 3, we all understand. And if I give this as minus 2, what is the value? At minus 2, the value is 5. Yeah, this is simple as we have been using in a tuple or list, right? When I talk about two-dimensional array, here we have the rows and column. So if we are talking about positive indexing, we start from 0 and go till 2. And if I talk from columns, talk to column, it is from 0, 1 and 2, right? So here, how do I access any element? Suppose if I want to access 5, this refers to the first row and first column. If I talk about this, we are talking about 0th row and the second column. Getting my point? Can we have a mixture of positive and negative indexing in arrays? Yes. Please be clear with this particular point. This point is not there in basic Python. That can we have a mixture of positive and negative indexing? Yes. For example, rows I've given positive indexing 0, 1, 2 and columns as -1, -2. So I can access this as 0th row and -2 column. Can they all be negative also? Yes, it can be -1, -2 and -3 also. Getting my point? Okay. So another important point that you need to understand is when we are talking about two-dimensional array, the rows always come before the column and the comma. Before the comma, we are talking about the row value, and after the comma, we are talking about the column value. Clear? Now let's see how well you can answer this question, right? So this is the array. Before the comma, I am talking about the 0th row. And if you remember slicing, which column am I talking about? Third and the fourth column, because the fifth is not included. Agreed, learners? Are you understanding my point? So if I talk about this, this is 0, 1, 2, 3, 4, and 5 row. And this is again 0. So whenever we are talking about this two-dimensional, it's a two-dimensional array. So the rows, if I'm talking about positive indexing, I would start my rows with 0, 1, 2, 3, 4, 5 values. Agreed? And my columns as 0, 1, 2, 3, 4, 5. This point is clear. If this is given my array, this point is clear. Okay. Now look here. Now if I am asking about this indexing, okay, if I'm asking about this indexing, before the comma, this is my row. So I'm talking about this as my 0th row. And after the comma, do you understand slicing, Sudhanya? This is going to start from the third column, right? 0, 1, 2, 3. Start from the third column. 5 is not going to be included. So the fourth is including. So what are the intersecting value? I will get the output as 3, 4. Now clear, Sudhanya? Hatski, Devki, Deepak, Arun, Navdeep. What does 4 colon mean? That means we are starting from the fourth and going till the last. That's for the row also. That's for the row also, as well as for the column. We'll start from the fourth and go till the last, right? So which are the intersecting common elements between them? 28, 29, 34, 35. Now tell me what will happen in this case. Before the comma, there is only colon. What does this colon stand for? This colon stand for? Only Mansi knows the answer. What about others? That we are talking about all the rows. We are talking about all the rows. And second here, about the second column. So we get the output as 2, 8, 14, 20, 26, 32. Agreed? Getting my point? Is this point clear now, Sudhanya? Yeah. Now, who's going to tell me the last point? There are 2 colons over here. Who's going to explain me the last point? What is this concept known as, Arun? This is known as, basically, this concept of single colon is known as slicing, and concept of double colon is known as striding. Agreed? Right? So what happens over here? Here, if I am talking before the comma, I'm talking about the row. So if this is my 0, 1, 2, 3, 4, 5. So starting position is 2. I start from 2 and I will go till end. The step parameter is also 2. So it will jump 2 steps. Okay. So we are talking about the second and the fourth row. And if I talk about columns, it starts from 0, 1, 2, 3, 4, 5. It starts from the 0th column, jump 2 parameters, and it's talking about the 0th, second, and the fourth column. Clear? So what are the elements which are intersecting? 12, 14, 16, and then 24, 26, 28. Getting my point? To three-dimensional array. Learners, are you there with me? Three-dimensional arrays are specified with the help of three axes. Axis equal to 0, axis equal to 1, and equal to 2, right? So the first axis or the index basically represents, it helps us to select the matrix. Please try to understand, learners. The first index I helps us to select the matrix. Second index J selects the row, and the third index K selects the column. Getting my point? Is this point getting clear to everybody? Right? So if this is my array, a three-dimensional array, since I've used 3 square brackets, a three-dimensional array is being, created over here. Now, if I want to access a particular element, we understand three parameters I, j, k are given. Value of my I is 2. Value of my j is 0. And value of my k is equal to 1. Right, learners? Can you see that on the screen? So this is j. My net is going slow and my pen is not, that smooth. So now do you see I, j, k values? What does I represent? To this, which selects the matrix. So there are three matrices. So here we have, or the slices of the bread as 0, 1, and 2. Getting my point? This is as 0, 2, right? So we are talking about this particular matrix. J is representing the row. So we are talking about this 0th row. And K over here is 1. We are representing the column 0, 1, and 2. So this is the value that I get when we talk about the matrix, the row, and the column. We get the output as 31. Getting my point? Did you get this? Everybody got this? How are we accessing element in three-dimensional? Yes or no? I'm waiting for the response. No, ma'am. Okay. Yeah, Sivagami, please look here. Have we understood J and K doing? I selects the matrix. Second index selects the rows. And the third index selects the column. So if I is equal to 2, which of the matrix, see, n-dimensional array, we have the number of slices. So which of the matrix gets selected is 0, 1, and 2 over here. So we are talking about this matrix. J represents the rows, right? So this is the 0th row that I am talking about. And this is the K that we are talking about. 0, 1, and 2. This is the K that I am talking about. Clear? Is this point getting clear to everyone? Now let's see how well you understand the next example. So please be clear with the commas. Commas play a very important role. So here I is the number of matrices that we are going to select. There one here 1 : represents the J, and here the K value is 0:2. Getting my point? Right? So here, when I talk about I, it means it is talking about the first two planes because the second one is not getting considered. If I talk about J, that is the row 0, 1, and 2. So 1 after the 2. So now since there are two matrices or slices considered, we are talking about the first and the last row. And similarly with the column, I'm talking about the first two columns. So the elements that come out column which are common come out to be 13, 14, 16, 17, 23, 24, 26, 27. Got my point? Sivagami, why I is not included in this? I is included in this. I is 0:2. So it starts from it's slicing 0, 1. So the second matrix is not included. We are talking about the 0th and the first matrix. We are including the I also, Sivagami. Got it now? J is the number of rows and K is the number of columns. Now getting my point? I stands for the matrix selection, J stands for the rows, and K stands for the column, right? So NumPy library has a lot of applications in the real world scenario, whether it's data analysis, machine learning, NLP, neuroscience, image processing, robotics, climatic science. All of this use a lot of applications. Got my point? Can we move ahead? Are you ready? I'm waiting for your response. Can we start with 3.04? Are you ready, everybody? So again, NumPy library also supports positive as well as negative indexing. So what do we understand? NumPy library also supports positive as well as negative indexing. Getting my point? Got it? All right. So here we have created three arrays. Do we understand? This is my one-dimensional array because one simple square brackets. These are two square brackets, so we use two-dimensional arrays. And here we have three square brackets. We are using the three-dimensional array. Getting my point? Got it, learners? All right. And positive and negative indexing. Do we understand that positive and negative indexing? This is 0, 1, 2, 3, 4, and 5, and -1. So when I give a -1, I get the answer as 6. And if I do positive indexing 1, I get the answer as 2. Got it, learners? Everybody is able to interpret the output, run it. And if I talk about And if I talk about this, this is my two-dimensional array with 2 rows and 3 columns, right? And if I say A is equal to element 1, comma 1, what will be the answer? Can you tell me? If I want to access 1, comma 1 element, what will be the answer? This is 0. This is my first row. This is 0 and this is my first column. The answer will be 5. Why, Arun, 4? It will be 5. Got it? Everybody is getting this point. It will be 5. Getting my point, learners? Right? Now, if I talk about three-dimensional array and shape, now do we understand this? Now, if I say find out the element 1, comma 1, comma 1, how will you do that? So this is my first matrix. This is my second matrix. So this is 0, this is 1. So we are talking about this matrix. In this, we are talking about this row and this column. So the 11th element comes out. Everybody's getting this point? Everybody has understood indexing very well. So if I want to access 0th matrix, 0th row and the first column, so answer is 2. Are we getting this? Why are we getting 2 over here? Facing difficulty, please let me know. Anybody who's facing any difficulty, please let me know. For you, different datas are displaying. Why? Have you not copied my file or have you taken it from the LMS? Even if the data is different, what difference does it make? The answer, logically, you should understand it correctly. Like I keep changing values in my file. So that could be one of the reasons, Sevagami. Otherwise, the arrays are the same, right? Yes or no? Oh, that is why it's okay. It's okay. But are you able to get the concept or logically the output? Yeah, that's okay. That's perfectly fine. It's okay. I keep changing things. Maybe I can put this as 101. What will be the output? So I keep making changes. So it's okay. Yeah, we can have more than 3 dimensions also. Yes, we can. Should I give you an example of more than 3 dimension? Let's say you want me to create something with more than 3 dimension. Okay, I'll explain you with that. It's something with more than 3 dimension. Can you tell me? Can you tell me how will I create that? Okay, now let me give you the code for that. For example, okay, so now let's do this array ARR, right? NP, like we had done, NP dot A range. Start typing with me. No, what we'll do is we'll play smart with it. NP dot A range 40. We had given like this, right? And now I will straight away reshape it to the dimension that I want. Suppose if I wanted as 4, comma 5, comma 2, and maybe I can now break it further to 2, comma 2, right? Got it? Are you getting my point? That's the beauty of reshape. So now do you see this? So of course a 4 dimension one would have 4 brackets, but I did not write the code. I did not put any logic. So what is it doing? 1, So how do I know this is 4-dimension? 1, 2, 3, 4, right? 1, 2, 3, 4. So it has got 4-dimension. Now, how is it working? It has got 2 rows and 2 columns. Then what is this 2? Every, item has these 2. Every item has these 2 groups 5 times. Are you getting this point? How is it working? Now, suppose if I want to increase the dimension of it, how will I go about it? How will I go about it? Since all are prime numbers, I will just keep on adding 1 onto it. So now it becomes 1 column. And suppose if I add 1 over here, I can increase further columns. So 1, 2, 3, 4, 5, 6. Exactly. But the number of factors need to be the same. Got it, Sudhanya? Hadse, Mansi, Sivagami? That the number of factors have to be the same. Now, clear? Right? Of course, understanding and dealing with them becomes a little more tedious, right? So this is with array with 4 or 6 dimensions. So this is equal to, maybe I can put this as D. So now how will I access the element? Maybe element as 0, 1, 0, 1, 0, 1. So the logic becomes a little more complicated, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So what is the error? Oh, they change. Index 1 is out of bounds for access 5. So this is out of bounds. So that's why it's giving me an error. So let me take that 0. Right? Element 22 gets extracted. So logically, it little changes, like in rows and column, then the number of slices, then the number of matrices, little change in that. Now clear? Is it better? That's it. Is your doubt clear? Or still you have doubt? Hadse, Mansi, Naz? If you want, I can share this code with you. You can play around with it. Fine? Is this code fine with everybody? Okay. So now getting back to the example we were here. So if I access one element, I think so indexing is quite clear to everybody. And can I access individual elements and do arithmetic operations on that? Of course, that if I access individual element as 2, 1, then I can do addition or subtraction, multiplication, anything. Clear? And another important factor or point for NumPy library is that we can have mixture of indexes, both positive, both negative, or positive and negative indexes. Getting my point? We can have both mixture of indexes. Clear? So when it is beyond 3, then matrix would pick up I for here. Then you have to check. See, the logic changes over here. If what I have understood is that basically, if we go back to this particular slide, please look here. What I'm trying to explain over here. Since the shape is 1, it talks about axis 0. So how many columns are there? 4. So that is why it only gives me the columns. But the moment it becomes two-dimensional, it becomes row and column, right? But when it becomes three-dimensional, it becomes the slice or the matrix and then rows and columns. So the logic keeps on shifting of the row and column. Getting my point? So with four dimension, it becomes with the number of matrices and other things and more complicated. So sometimes it's difficult to visualize also, see also to understand. Got it, Mansi? So IJK is going to be the last three ones. In the if I talk about six dimension or any of the four dimension, IJK would be the last three ones, and the first one would represent the other matrices. Now clear? And that logic would keep on shifting. It's not straight logic. Now got it? Exactly, with the dimension. It changes with the dimension. Absolutely correct. Got it, Arun? Navdeep? Okay. So now we are clear that in whenever we are talking about indexing and slicing, we are talking about both positive as well as negative elements. Okay. So if this is my two-dimensional, I can access this 1, 1. Three-dimensional is also now very much clear to everybody that we are creating these three brackets. And when I use 1, 1, 0, this is the first matrix with first row and the 0th element. I hope you all are getting this. I hope everybody is getting this point. Everybody, you can play around with the code. I would suggest everybody to be confident enough now to play around the code and check out the results. Okay. Now, can anybody tell me that this is my array 3D1? Okay. This is my array 3D1 and this is my array 3D. Okay. With all the three brackets. Why is this giving me an error? Why am I getting the error over here? This is my 3D1 and this is 3D. Why am I getting error over here? Yeah, because they cannot be broadcasted together. That is why it is giving me an error. Broadcasting, the shapes are different. Got it, learners? Negative indexing is also clear. It starts from the right hand side to the left hand side. So when I give -3, it gives me 4. And for the two-dimensional, it is -1, the last row and the last element. Clear? And another beauty of NumPy is we can have of positive as well as negative indexing. So now you will be able to do the assisted practice since now, if you were not able to do it yesterday, you're getting 1 week break. Then we can discuss it next week. Will you be able to do the assisted practice? Well, if you're taking my files, you already have the solutions also. Will you be able to do it? And if you face difficulty, we can discuss it again. Right, learners? Now, if I talk about slicing, can you tell me what happens in slicing? How does slicing work? We have one colon and then there is a start and an end parameter. If the start parameter is not given, it always starts from the 0th index. If the end parameter is not given, it will go till the end of the particular array. But if there are two colons given in between along with the step parameter. This concept, please be clear, nobody understands. This concept in Python is known as striding. Getting my point? This concept is known as striding. Clear? Please do not forget, they both are not same concepts. This concept is known as slicing and this concept is known as striding. Got it? Any doubt till here? Yeah. I am saying this, Hatse, that when we have this one column with start and stop parameter, this concept is known as slicing. But when we have two columns with the step parameter, that is known as striding. Fine, Hatse? So Mansi says, thank you for this. I never knew the name of the concept is striding with it. Yes, that is there. No, most of the, you know, people don't know this concept. This is known as striding. Clear? Great. So do we understand now if this is my array, one-dimensional array, and if the starting position is missing, it will start from 0th position and go till n minus 1, second position, 0, 1, 2. And if nothing is mentioned, nor the stopping position, it will give me all the values. Fine. Are we good to go? Now, how do we go about printing the list of 3 subjects from 4th index to the end? So this is 4 colon. How do I go about it? Or minus 4, 0, 1, 2, sorry, 2, 3, 4. It will start from the 4th and go till the end. Agreed? Similarly, if it is negative indexing, minus 1, minus 2, minus 3, minus 4. So it will start from minus 4. So in this case, the value is coming out to be the same for Hadoop. It will start from Hadoop and go till the end. Got it, learners? Please go back to the above line. This one, example 1, let's say, yeah, what is the issue? So if you do it without the colon, then what will it give you the output? Tell me. It will give me an error because you are not supposed to send it black. Obviously, it's a syntax error. Either you give one value or you give the slicing. Now clear? Yeah, good to clear your doubts. Any question, any other doubt, learners? And what about slicing with step value or striding? If these are my numbers, what does 1 colon 6 mean? 0, 1, 2, 3, 4, 5, 6, 7. So we start from 1 and go till 6. So this is the output I get. And when I'm using the step parameter as 2, it will start from this, jump to. So I get the answer as 7, 5, and then 3. And if it is 3 parameters to jump, it starts from 7, 2, 3. 7 and 4 will be the output. Are you understanding, everybody? Or is it Hatse and Mansi only understanding? Can I get a quick confirmation from everybody? Are you all there, awake in the session? Uday, Deepak, Tullapati, Sudhanya, Sivagami. Come on, respond. Mulla Pedi, Kamal, Dushyant, Devika, Arun, Akhil. Great. So is 1 is to 6 is to 2. And no, Sudhanya, no, let's try that. Let's try this. See, 1 is to 6 is to 2 is that I start from the first position, go till the fifth, and I jump 2 parameters. All right. But the other thing that you are trying to say over here is start from first, colon 6. That means, what does it mean? That it will start from the first position and jump 6 parameters. Are you getting this point? That means if this is 0, this is 1, it starts from 1, then jump 6 because it has to go till end. So 1, 2, 3, 4, 5, 6. So the output is 7 and 1. So there is a lot of difference. So this is the answer, right? Now clear? What is the difference? Everybody is getting this point. Please clear your doubts. Different from striding, start, end. It is different from striding. Striding is the step parameter. It's jumping 6 positions. Here we are jumping 2 positions. Here we are jumping 3 positions. But here we are only jumping 1 position. We start from the first position and we go till this position. Got it, Atse? By default, there is no jump parameter. We are moving one after the other. But here we are jumping. Now clear? Or stepping? Now clear? And what about two-dimensional array? As we are very clear, you have to be very careful about the comma. Before the comma, it represents. What does it represent before the comma? It represents the row. We are talking about the 0th row and 0, 1, 2, and 3 columns. So this is the element that I am talking about. Got it? Clear to everybody? And of course, negative slicing is also clear. We can slice out negatively also. That means we have to first write the left-hand position, the lower position. This is -1, -2, -3. So it starts from 56 and the last one is not included. So therefore, we get the answer as 5637. So again, this is 1 colon, this is slicing. This is again slicing. Clear? Is there a negative stride? Yes, we also have negative striding also. I'll show you. So if I talk about negative slicing, I'll just show you with this. Now, if I say colon, colon, -1, what will be the answer? Can anybody tell me what will be the answer for this particular stride? It will read the whole array and give me the reverse of that particular thing, right? Getting my point, Hatse? Yeah, it's going to be reverse. And if I make it -2, then it will jump 2 parameters. So Sudhanya says not clear. And if I do -2, it will jump 2 parameters, right? So let's understand it over here. Now look at over here. This is my array of negative slice which starts from 13 and goes till 24. Now, if I'm doing a negative slice, the start parameter says I have to start from 0, right? End parameter I have to start from 24. But jump parameter is -1. That means I'm here. So I have to jump -1, -1, -1. Therefore, I get the output first as 24, then 37, 57, reverse of the array. Now clear? So Danya, Hatse, Devika. I make this -2. What will happen? Now it will this jump 2 parameters. So 56 then 69 and then 34. Right? It will jump 2 values in the negative direction. It will always go in the opposite direction. Plus means 0. Positive indexing is left to right and negative is from right to left. Fine, Hatse? Now clear to everybody? So Dhanya, still anybody has any doubt or question? Negative indexing or slicing is only used for reversing or does it have a lot of use? We are yet to know about. Mostly for reversing. For reading it in the reverse manner. Okay. Practically, that's the only use. Right. So this is again the assisted practice with solution. I hope you will practice it out in your break. Right. Will you all be able to do it, learners? Okay. Now getting back to 3.03. Are we understanding all these concepts of arithmetic operations? How broadcasting and vectorization gives output for addition, subtraction, multiplication, division? Are we clear with the difference between these two operators? Yesterday we discussed what is the difference between these two operators. Tell me quickly. Values, both the operators give quotient. Absolutely. One gives the decimal value, other one gives the integer. So the floor divide gives the nearest lower integer. Excellent. Good learners. Very good. So everybody is clear with the arithmetic operations that we had done yesterday? Yeah. Can we begin with statistical function? Everybody has this file 3.03. Anybody who needs this file 3.03? Do you need the file, Hatse? Is the yes for that? Come on, I'm waiting for the confirmation, learners. You got it? Yeah. Can we begin? Everybody has this 3.03 file. Okay. So if we talk about statistical functions in NumPy, yes. Can you tell me the difference between median and mean? We discussed this point. What is the difference between mean and median? Yeah. Now tell me. Nobody knows the difference between mean and median, learners. Mean is the average, median is the center. right? So what is the advantage of median or mean? Which one has more advantage? Can you tell me? Advantage. Median is the most of the data concentrated, not affected by extreme values. Okay, mean is the average of the numbers affected by extreme values. Good, Mansi. So which one has more advantage? For example, if you are, students of a class and I want to take the average of their heights, which one would be the better method? A mean or a median? Are true values. Mansi, I don't understand the term true value. Both are true values. So I'm saying if you have to take the average of height of the students, which one would be the better method, mean or median? HA says mean, most of the data surrounds. Why, Sudhanya, mean? Why mean would be better? Then if I want to calculate mean, I want to know the height of each and every student. Will I measure the height of each and every student and then calculate it? Well, that's possible, but why to do that? I can arrange them in ascending order or descending order and then pick the one in the center, right? Agreed or not, Hetze? Are you getting my point? Okay. Median represents or what most of the population is. What I'm trying to say is that if in a student of class, a class, I want to find out the average of the height, mean is better or better? I want to know that I need to know the height of each and every individual of the student. Some student might not know the height, exact height. So do I need to measuring with the tape? That's also possible. But with median, the situation, the position, calculating the average would become easier. That I would arrange them in ascending or descending order and take the value in the center. Getting my point? With one person's height, the height of the others can be estimated. See, idea got my point, Hadse. That would represent the average. That's the beauty of median. That would represent the average. Median are nothing but the center value. If they are 11 students, the sixth position or the fifth position will represent the height of the all of the students, right? That's your notion. Statistically, it is correct. Getting my point or still not? Yeah, so please be clear with statistically. One way to calculate average is that we take the sum of all the values and divide it by the total number of errors. And other is through median. We arrange the data in ascending and descending order and then pick the center value. Clear? Is the difference between mean and median getting clear to everybody? Yeah. Then we understand STD, that is standard deviation. Very, very important. Sometimes it is important to understand that how far are we away from the average value. That is also equally important to understand. Percentile is that if the whole data is divided as 100%, and if I want to know the 25% of the data, that helps me to do that. 30% of the data, 70% of data, 65% of the data. So it helps to return the nth percentile of the element in an array. Minimum, it returns the minimum element of the array. Max returns the maximum element of the array. Getting my point? Now clear? So what are the different functions available in Python? Please make this point noted that no data science is complete without statistics. So NumPy also supports statistical functions. Pandas also supports statistical functions such as SciPy, Stats Model, and Statistics Library, which also help us to understand. So that we will cover up in detail as we move on. Got it? So if this is my A range function, right? And if I want to calculate the median over here, right? Since they are 11 values over here ranging from 0 to 10, the middle value is again 5. So the mean and median could be same sometimes and it could be different also. Now clear? Standard deviation, np.std is used to calculate the standard deviation. np.var is used to calculate the variance of the data. Similarly, even if I have the beauty of all these function is now if the array is one dimensional, two dimensional or higher dimension, we will need to use just the same function. I will just use NP median. It will give me the center value of all these points. Now, do you see that there is a difference in median and the mean value? Do you see the difference between the median and the mean value? This is the difference that we get, right? And this is the value of the standard deviation. And this is the value of the variance. Getting my point? Learners, are you there with me? And calculating percentile, if I say 50th percentile, it gives me the same answer as the median. So if we check it over here, so it was A. So it was not array. So this is the answer. Clear? Coming on to the string functions in NumPy. What does the plus operator mean in strings? Yes, learners. What does the plus operator mean in string functions? It concatenates them. So will I be able to directly concatenate x plus y? If this is my array, please try to understand. Will I be able to concatenate x plus y? No, it doesn't allow me to concatenate. U function add does not contain. Okay, so this is, so how do we do concatenation of NumPy strings? By using np.char.add function. Clear? We need to use np.char.add function. Clear? Right? So as I tell you, this is not possible over here. Can anybody tell me why this is giving me an error? Both are numerical type. Why x plus y is giving me an error? Anybody who can tell me? Yeah, because broadcasting is not possible. Got it? Okay. Now, if I want to replace a old substring with a new one, then I can use np.cat.replace, that is str hello with hi. So the hello gets replaced with hi. Got it? And of course, the simple function by using the upper, the lower, case gets converted into upper. Using the lower function, the uppercase gets converted to lowercase. Simple. That much we understand in Python. Okay. So this is a very important library which decides or which is useful in data analysis. Practically, it helps in loading of the data, how different analysis can be performed. So after Pandas library, you will get that confidence. Okay, this is how the real-time data gets loaded, how the cleaning gets done, and how the different analysis can be performed on the data. So this is going to be very, very useful. Getting my point? Right? So this is the library which helps in representation of the data in the form of tables. Now, when I say in the form of tables, it means that the data is generally structured. It's represented in terms of rows and column, right? So rows and columns. These slides are my slides. I will upload it after the session. These are my slides. I will share it with you. Okay. Right. So these are the column names over here. Got it? Right. So pandas basically consists of two data structures. First is known as the series, which is like a one-dimensional array. And the other one is data frame, which is a two-dimensional array, right? Can we say that a table is nothing but a two-dimensional array? Can I say a table, Excel file, SQL, CSV files are all there? So the question arises when we already had arrays library where we could create n-dimensional data. What was the need of this pandas library? Till now, I'll tell you the reason. Till now, what kind of indexing was being used? Till now, what kind of indexing was being used? Positive and negative indexing. That was by default part of the language. But in Pandas library, we can define our own label indexing. I can give my own indexes. So this makes the whole tabular data more approachable and understandable. Getting my point, learners? Is this point getting clear to everybody? Right? So the two types of data structures available are Pandas series, which is nothing but one-dimensional array, which is nothing but the column of your table, and Pandas data frame, which is nothing but your two-dimensional array, which is nothing but the table itself. Getting my point? Is this point getting clear to everybody? Right? So the different data structures in pandas are, we have the series that is one dimensional labeled homogeneous array. So the difference comes over here is that they are labeled, which we can label them according to our way. And data frames are nothing but two-dimensional tabular structure with potentially heterogeneous type column. Right. So a column will always have a data of same type. For example, name, marks, address, they will all be of the same data type. Whereas a table or a tabular data structure can be heterogeneous in nature. Got this point? Is this point getting clear to everybody? Right? So now if we look at the pandas series, what happens is that this column of your data, you see that indexing over here is positive indexing. So if I do not give my label, my own label, then this will refer to positive indexing. So a panda series is like a column in a table. It is one dimensional array holding the data of any type. Clear? So a series consists of a series name, its index value. If we define the index value, it will contain that. If we do not define them, yeah, it's always and always one column. Series is always and always one dimensional data. Okay. And if I do not provide any label indexing, it will take the default in positive indexing, that is 0, 1, 2. And of course, the values. So now if you look at the code, the first thing that we require is to import the pandas library, right? Since this is not part of the basic Python, import pandas as PD. Getting my point? Anas, are you there? Right? Then we move ahead with the temperature, right? This is what is temperature and days? What is the data structure of temperature and days? Can you quickly tell me? Yeah, they both are list. And how do I create a series? I will use the function pd.series. Please remember, Python is a case sensitive language. So capital S is being used and I pass the parameters temperature and index is equal to the days. Index is equal to the days, right? So my data is equal to temperature. Please look here. So this is my data. Now do you see the alignment? Output is automatically vertically aligned. Do you see that? That was not in the case of one dimensional array. It was giving me flat, straight line. So it is vertically aligned automatically. It gives me the data type of the data. And now since I have given my index equal to days, these are my index values. Clear? Code how the series are, they are null array. And this pandas library is built on the NumPy library, but still it is different. It makes the understanding accessibility much more easier. Do you see that, Lana? No, not necessary. Not necessary, Arun. There is no rule for indexing over here. It's not like database indexing. No, there is no rule like that. Clear? Yes or no? Arun, Hatse, Mansi, Sivagami, Devika. Everybody's getting this point. Can I move ahead? Right. So again, if they are two same indexes, which value it will be? Pick. Now let's try to understand that, Arun. We'll do it practically. What's your question? So if these are my two series over here, right? Since I have not given the index value, so by default, it will have 0, 1, 2, 3, and 4. And this is again, it will take the first one, Arun. We'll do that. We'll do that. I'll answer your query. 1, 2, 3, 4. All right. And if I do addition of the series, it will automatically add the 2. And what is the concept behind arithmetic operations? Same as NumPy. What is the concept behind arithmetic operations? What are the two concepts? Quickly tell me, learners. What is that known as, Hatsi? Broadcasting. So now both the series are of the same shape. So only vectorization happens. Element by element operation, right? Or implicit running of the for loop. Only vectorization happens. Getting my point? Is this point getting clear to everybody? So again, this is the open source for Pandas library. All the, libraries that we are doing, whole of Python is an open source community. So all the functions, everything you will get it online, right? So of course, there is a lot to explore over here. Yeah, please open the link, and this is the all the documentation related to the Pandas library. Got it? So basically, if we talk about pandas, the advantages of pandas over NumPy is intrinsic data alignment, that the data is, you will see a beautiful output for column. It will give you as in vertically aligned, and for tabular data also it gives you in in a form of table. Then it has two data structures. Data operations are easy to perform as it is built on the NumPy library. So this has again advantages of high performance in memory merging and joining, intelligent and automated data alignment, tools for reading and writing data, a fast and efficient data wrangling are also part of it, right? And are we also clear about the two data structures? First is series, one-dimensional labeled array. Another one is data frame, that is two-dimensional structure. All right. If we can get the learning materials in advance, that I will try, Hetze, because see what material I prepare, I keep working on it. Then that is why I always give it after the session. It's a little difficult to give it before the session, but I'll try. Okay. You. Thank you all so much. Now let's begin with series. A series is a one-dimensional array-like object containing data and labels or index, right? So as we have understood that the speciality of Pandas library is that we can create our own labels, right? Series can be created with the help of n-dimensional array, with the help of dictionary, scalar value, as well as list, right? So now let's understand how to go about it. First, I would like everybody to run this import.pandas pd. Is this code, is this import file, importing running fine? Anybody who's getting an error? If we get error, then we always do pip install pandas. But I think everybody has Everybody is running this import pandas as PD without any error. Quick confirmation from everybody. Kamal, Devika. Great. Good. All right. So now look at over here. What are we doing? Please try to understand the code. Okay. So if this is my data 11/23/83 and this is days, right? And I create pd.series, this becomes my data. So Sivagami, you had this doubt that D type is equal to int64. Int64 refers to this data type, right? Different data types. Now, again, your question was that is this going to be homogeneous or are we going to change this? Let's see. If I change this to 2.3, do you see? It's like arrays. It changes into homogeneous. All my data type changes to float. Devika, are you getting this? Sorry. Uh, Sivagami, are you getting this point? Right? Now I am passing this as my data. Index is equal to days. So here I am able to get Monday. This was the value, Tuesday this, Wednesday this, and Thursday this. What happens if I do not pass my index values? Okay. If I do not pass my index values, then by default, it will take it as positive index value. By default, it will take it as positive index value 0, 1, 2, 3. Getting my point? Okay. And if I interchange the two, the interchange can also be done. There is no restriction on the interchange, right? So this is the data type object of this. Questions, any doubt till here? And again, if I add any uh, string value, all my values in the series change. Output, it's a one-dimensional array, but all of them are vertically aligned along with their index value, their data value, and their data type. Do you understand the beauty of Pandas library? Yeah, because in Pandas, we do not call this as string, we call this as object data type. The string data type is known as object data type. Fine, Hadsik? Yeah? Okay. Right? And if I want to change the specific index value, then I can create indexes which can be heterogeneous in nature. And to be noted over here is that data can be homogeneous, but the index value can be heterogeneous. If we have two strings in the data also, it will show the, yes, yes. Yes, yes. If one of them, see, there are three string type, all of them have become the object data type, Sivagami. Do you see this? Anas, are you all understanding this? Now, as we have understood, there are two types of indexing available in the Pandas library. One is integer or position-based indexing. That is the normal one we use positive or negative indexing, and another one is label based indexing. Does the index? No, that's what I'm trying to explain. It is not necessary that it needs to be unique. So if I change this 5.7 to 100 again, let's see. All right. So again, getting to this point, that series with index. So another important point to be understood over here is that it is not necessary have to, access it with these values only. If I'm not accessing, I can use the default indexing such as 0, 1, 2, 3 also to access the value. So what I mean by that is, see, one way is I pass the value 100, whatever. Okay, I'll just show it to you. See, one way is I pass the value 100, right? And the other way to achieve it is if I give the value as 0, give me an error. But if I pass this ILOC parameter, that I'm specifying it, that now I am using integer base indexing. So then I get the first value. Now clear? Both ways you can use. Both, if you want to use the default indexing, then ILOC or integer base indexing needs to be passed. Clear? Right? So here, if I say ILOC 0, that I'm accessing the 0th element. But if I want to use the label index, then I can pass it as LOC, also label based indexing, that is B. And of course, negative indexing is also part of it. This is -1, -2, -3, -4, and here we have -5. So -5 position is at 10. Clear? Integer location is ILOC, label based is LOC, and integer based can be both positive as well as negative indexing. Even if we have float value, it will work. Let's make it, let me change it to 3.45. Okay. So now if I give this as 3.45, I get the value as 30.96. Got it? It will work. It will work. No restrictions on that. That's it. Do you see this? With ILOC, no. Only, not with ILOC. ILOC is only positive and negative indexing. Only with LOC. It will give me the same answer if I do LOC or over here. Not with ILOC. The moment I give it as ILOC, it will give me an error. Got it? Yeah. So now when I want it for a particular index, be it is cat, and for 100, it gives me both the values. Is slicing also covered? Is slicing also a part of it? Yes, slicing is also a part of it, but there is a difference attached over here. Please look here, learners. right? If this is my series in text and I've given it 2, 2, 4, what does it mean? It is like 0, 1, 2, 3, and 4. So let me change this. Let me give it to 1. Yeah, please look here, learners. Again, then there is an error. Okay, now look at over here what is happening. Please look here, Sivagami, are you getting the code now? I'm running each and every code. Okay, so if this is my series, are you getting the is that this is integer base 0, 1, 2, 3, and 4. It starts from first position, fourth is not included. It starts from B and fourth is not included. So it gives me B 3.5, 3 outputs. Clear? But when I give B to D, in label indexing, the last part is included. It is inclusive. This is the difference in the slicing. Please be clear. This is exclusive in ILOC, but this is inclusive in LOC. Getting my point? Now creating Pandas series from dictionary. Let's try to understand and create series from the dictionary. So what is this? What does a dictionary consist of? A dictionary consists of key value pairs, right? Very good. So the keys automatically become my index. The keys will automatically become my index and the values will become my data. Again, they can be of heterogeneous type, because dictionary is a heterogeneous type of data structure. Clear? Right? So we can create series with the help of dictionaries also, which is very simple. The keys become my index value and data becomes my data. Got my point? Is this point getting clear to everybody? Use, I know, LOC and ILOC, now it becomes series. We can use it with series only. Okay, Mansi, don't get confused. Now there is no concept of dictionary. Then the concept, we have converted the dictionary into series. Okay. Are we good to go? Can we move ahead? All right. Very, very important. Some basic functions that we need to understand in Pandas series function. The first function is the head function. What is this head function? Head will always return the first n rows. So if I give 3, I get the first n rows of my series. If I do not pass any parameter, by default, it will give 5. Right? By default, it will give 5. And what does the tail function do? Tail will return the last n rows. If I have passed the value as 2, I get the last 2 values. Got it? And can you tell me what will be the dimension of series? What will be the dimension of the series? Always and always one dimension. If the dimension is not one, obviously it is not a series. Got it? When we talk about the shape, since it is one dimensional, it will only give me the number of columns, right? Shape, axis, dimensions are all related with each other, right? Another very, very important function is the describe function, which is part or heart of any pandas library because that gives the tabular descriptive statistics. So as I'm telling you, without statistics, no data analysis is complete. So describe function tells me the count, the number of values, mean, the standard deviation, the minimum, the first quartile, the second quartile, median, and the third quartile values along with maximum value. So that is the beauty of this describe function, which gives these all summary values. Got my point? Is this point getting clear to everybody? All right. So what are we doing over here? We are again creating a series function and trying to find out the unique value. So what does the unique value of series function do? It tells me the unique values in the data. So I have 1, 2, 3, 5. So there is like you can use set to find out unique values, but there is no set as such. So the unique function tells me the unique values in the data. Clear? And n unique gives me the number of unique values. N unique gives me the number of unique values. Sivagami, are you able to run the code? Are we clear till here? Are we all understanding series? Or anybody is facing difficulty in understanding the concept, running the code? Please let me know, learners. Please let me know. No? No response? Are you there in the session or no? Yeah. Now let's understand the different operations and transformations that can be performed, right? So now we are clear. This is my data. I convert it into series. These are my index value. I create series index value. And now I add the two. So let me, just cut paste it to other things. So this is my series. Have I passed any index value to this series? No. So by default, the indexing is 0, 1, 2, 3. Getting my point, learners? So by default, the indexing is 0, 1, 2, 3, 4. And now if I do it with index, what was the output? This is with A, B, C, D. Do you see the difference between the two series, learners? I've just separated the code. So I just keep doing these little changes. So this is normal series, pd.series data. This series with index. Getting my point? Yes or no? Right? So if we do element-wise series addition, how since they are two different values of the indexes. Now, do you see? The indexes are not the indexes matching? No, the indexes are not matching. So when I want to do the addition, I get all the null values. So none of them get added. Are you understanding the output? So while doing arithmetic operations in series, index matching. Only if indexes match, then the arithmetic operations can be done. Got my point? For example, I give the same data and I create this series 1. All right. Since the indexes are matching, can I now do series plus series 1? Yes. Then I'm not getting null value since the indexes match. Now, for example, some indexes don't match, some match, then they will get added, others will not get added. Let me show it to you. Let's keep it as the basic one. Here I'll add my own index. 1, no, let's keep it as 0, then 10, 2, then 30, and then 4. Okay. Now let's see how it is working. Here I've not made any changes. The index values are 0, 1, 2, 3, 4. Here I've only the matching ones are 0, 2, and 4. Others are not matching. So this is my new series. And now if I add them, now look at the difference. Now you'll understand that for 0th, it gets added. 1 is not matching, therefore it will be NaN. 2 matches, 3 it will be NaN. 4 matches, and 10 and 30 will also be NaN. What does NaN stand in Python? Not a number. What does NaN stand in Python? Not a number. Now clear? Have you understood how the arithmetic operation is carried out in series? Yes, are we good to go now? Have you understood the differences? Yeah, you can have this small code. Of course, you can have that. Yeah, take this first code, paste it. Take the another one, take it. And then we go ahead with series and series 1. Yes, learners. So now when the indexing is not matching, that is why the output is null. Now are you able to interpret this output? Why all the values are NaN? NaN stands for not a number. Got my point? There is another function available in the Pandas library, that is null, which helps us to check the missing values. So NaN stands for missing values or null values, and that is why I get all the output as true. Now you see the data type has changed to Boolean automatically. We don't have to do anything. automatically it will change the data type and give the output. Getting my point? And exactly the same way we use the is null, there is this function as is NA. Both mean the same thing. Both are checking the null value. NA also stands from the same function. It does exactly the same thing. Got my point? And how do we deal with null values? When we check null values, then we can use fill NA. So wherever there is NA or null value, automatically the values get filled with 100. You can change any values. It's completely up to you. You want to change it maybe to 50. That's also possible. Got my point, learners? Devagami, are you able to run the code? Others, Kamal, Devika? Good, Devika. Good, Sivagami. The concept of series is very important to understand the huge errors in Python throws when there is an error. Hopefully, don't scare me as it is. Good, Mansi. Can we do exclusion for NA? What do we mean by that, Hadse? What do we mean by exclusion for NA? What do you mean by that? Elaborate your point. Yeah. Yes, learners, do we understand lambda function in Python? Quickly let me know. What do we mean by lambda function in Python? Function with no name, and you can pass and single line expressions. You can always say single line expression. So what are we doing? We are passing one argument and multiplying it by 2. So s dot map is that it will take each element from this particular series, right? And then multiply it by 2. So 1 multiplied by 2, 2 multiplied by 2, 3 and 4. So you get this output. But can we directly also do this? S into 2. Can I do a direct multiplication? Yes, I can do that. And how is it possible? How is it possible? What is the concept that is running behind? Can anybody tell me? Yeah. Broadcasting also, because the scalar value will be broadcasted, and then vectorization. Good, Mansi. Good, Hadse. Clear? Is this point getting clear to everybody? Are you there with me? To creating a text series and a dictionary one, and then we are trying to map the dictionary. So what are we trying to do? Let's understand this. Print s underscore text, and then we are doing print mapping underscore dict. So now do you see this? In the first case, I've created a string series, and this is my dictionary. Do you see the outputs, learners? I've just printed the output so that we can understand it better, right? And now we are taking this apple to red, banana as yellow, and orange as orange color. So automatically it maps them, and my new dictionary is mapped like this. Got it? So how are we able to do it? We are able to do it with the map function. So map function matches or maps each element of the dictionary with whatever parameter has been passed. Here we are trying to match with the string values. Automatically it does that. I'm not doing any effort. And here we are trying to multiply each element with the 2. Got it, learners? All right. All right. So basically there are other functions and transformations also available on the series function. For example, we have this apply function. That is, we are going to add each element. Every element gets added with 2 value. Then we can map onto the dictionary we have just seen. We can also sort the values output with the help of sort underscore values, and then check the null values also. And what is fill now? If there are any null values, we can fill it up with 0. Are you understanding all these functions that help in transformation of data? Everybody is able to run these functions. Right? So this is my series and this is the other series. And when I add and map them, this is how I get the different output. So wherever the values are true, they are filled with 0. Do you see this? Could we fill with, yes, we can do that instead of 0 necessary for data. Yes, yes, we all, and practically we do that, Mansi, absolutely correct. And practically we do that so that it is easier to fill it with mean or median values. Yes, practically we definitely do that. Absolutely correct. All right, good. Yeah. So moving forward, can we query a series selecting and filtering data based on specific condition is an essential aspect of querying Pandas series. So how do we go about it? Can you tell me how can we create series with the help of dictionary? What happens to my key values? My question is, how can we create series with the help of dictionaries? What happens to the key? No, wrong. What happens to the key value in dictionary when it is converted to a series? Absolutely. It becomes the index value, right? And my data becomes my data. Please be clear with this particular concept. Got it, Atsuki? That the key value will become the index value of the series function. So how do we go about it? Again, simply by using the logic of series. That series, we want to all the greater than 30. So those values get printed. Values which are equal to 20 get printed. And in this case, the index is unique. Yeah, in this case, it could be unique. It could be non-unique values. It's not giving any error. It's completely up to you. In this case, it is unique. Yes. Okay. Then the values which are not equal to 40, then you can also do multiple condition check using the AND operator. Then you can also check is in function whether that particular value is in the list or not. Then we have the LOC, that is A, C, and E. And finally, series I LOC function also. Got it? So now you can check out the output. Please try to understand the output, learners. Are you understanding all these conditions? That's it, Devika, Sivagami, Kamal. Come on, other learners can also respond. Akhil, Arun, Kiruba, Madhuprata, Malipudi, Nikita, Navdeep, Mukesh, Uday. What about you? What about you, Deepak? You've not been responding today. Sudhanya, Turlapati. Yeah. Are you able to interpret the code now? Try to understand the code on your own. Run it one by one. There is no ACE. So series.loc ACE. It's not able to extract because it doesn't have that. It has 0, 1, 2, 3, 4. So that is the issue with .loc. Do you see series.loc? There is no ACE values, right? So you can comment this. We've already understood. Since it is not there, it will give you an error. Comment that particular line. Query based on index labels. Selected by index. Got it? Yeah. Now run it. And the rest we can do is that if we can create a series of string type, yes, we can create a series of string type by default index. And then we can also find out the values which start with BA. So banana starts with BA rather than BA, we can say it with B. All right. So if we talk about descriptive statistics, do we understand mean, standard deviation, minimum, maximum, Q1, Q2? Let's understand it quickly. Mean, we understand. It's the sum of all values divided. And somewhere down the line, sometimes median is more useful than mean. Let me be clear. Let me explain you the difference between mean, median, and mode. You might have heard about it. Mode is generally used for categorical value. For example, I want to find out which of the t-shirts sell more. Is it the XL, medium, large size that sell more? So will mean be useful to me? No, there is no value that I can calculate. Median will also not be useful. Mode is the maximum number of sizes of the shirts that get sold, right? Mostly it's going to be large size or medium or XL. So that is going to tell me the frequency, the maximum frequency of the item is known as mode. All right. So there are different ways to calculate the average. It is not always we do it through mean. Mean is only useful when we know the values, right? But it is most affected by outliers. If I don't know the value, then mean is not used. Median is when we want to find out the positional mean, as I gave you the example that if they are 50 students in a class or 100 or 500 students in a class, we will not measure each and everybody's height. We'll arrange them in ascending or descending order and pick the middle ones. Got it? So these are the different ways in which statistics helps us in the analysis. For skewed distribution, median is a better choice because medians are not affected by outliers. Mean does, right? Standard deviation tells me that how far we are away from the actual mean. Quartiles tell me that, as I've told you, they divide the data into 100% and how much we can divide them into 4 parts, right? And are we clear about describe function? If we have numerical value 2, 3, 4, so count gives me the number of values, mean gives me the average of this, standard deviation, how far are we away from the mean, minimum, maximum, and the quartile values. Got it? Is this describe function clear to everybody? right? And if my data is objective type or categorical, count gives me the number of categories. Unique gives me there are 3 unique letters, P, Q, and R. Top value over here is P, and how many times it is getting repeated? It is getting repeated 2 times, right? And the biggest power that Pandas library has, that it helps in representation of the data in the form of tables. Getting my point? It helps in representation of the data in the form of tables, right? So table means a table has rows and column. Every row has its index value. If I'm not defining label to it, by default, it will use positive indexing, and every column will also have its name. Getting my point? Is this point getting clear to everybody? So the two data structures are series and data frame. Series refer to one-dimensional labeled homogeneous array which are generally mutable. So series refer to one column of the table, and data frame refers to the two-dimensional, tabular data structure that is potentially heterogeneously typed, right? So we understood Pandas series is like a column, and the two components of any series that we create is its values, what the data we are passing, and is its index value. If I do not explicitly pass the index value, it will contain positive index labels. Getting my point, right? So this is what we had, seen, that temperature and days are my to list, and to create series, I use pd.series function, right? This is temperature, and this is equal to index is equal to the days, right? So now we can convert the temperature into days. Getting my point? Another beautiful point about Pandas library is that it gives the data in vertical alignment, tabular form, along with the data type of the data. Getting my point? These are the values, so it gives that type. And whereas index value can also be of any type. It is not necessary that it has to be of int, float, or string data type. Can I interchange these two lists? Can I make the data as the days and the index as temperature? Can I do that? Yes, we can do that. That is allowed. Everybody is getting this point? Now this Pandas library is built on NumPy, right? The Pandas library is built on NumPy. That means what are the two main concepts of arithmetic operations in NumPy? Are the two main concepts of arithmetic operations in NumPy? Broadcasting and vectorization. Excellent, Devika. What is broadcasting? Broadcasting is making the arrays of the same shape and size, and vectorization is element by element operation. So, what is vectorization? Here, vectorization will happen. Since they have the same index value, the elements get added together to get this output, and similarly subtraction. Do you see the vertical alignment? The data type along with the labels. This is how this series is different from one-dimensional array. Getting my point? Is this point getting clear to everybody? We are doing revision. We also understand statistics also plays a very, very important role. So we have Pandas df.mean function, standard deviation as STD. Do you remember this point? Then we have the min, the max function. Using the quantiles, we can calculate the quartiles function. Clear? Are you all getting this point? So do we understand what does the describe function tell us? Tell me, what does the describe function tell us? It gives the statistical summary of numerical values, the count, the mean, the standard deviation, minimum value Q1, Q2, Q3, and maximum. And if the data set is categorical or string values, then it gives the count, the unique values PQR, the topmost value, and the frequency of that particular variable. Now let's start. Tell me, till what we had done. So data frame is a two-dimensional data structure. That is, the data is aligned in the tabular fashion, right? So the features of data frame are potentially columns are of different data types. Size is mutable, labeled access rows and column, and it can perform arithmetic operations on the data frame. Got it? Yeah, I remember Turlapati. Yeah, I remember you in the last session. Hetze also I remember now. You've done this? Right? So axis equal to 0 refers to the df dot index value. That's the, the labels for the index, right? And then we have axis equal to 1, right? This is the columns that we have, right? The column. And to get the value, we get df dot values. And I think so. Somebody from you only told me that you were unable to see the data types from here. Let's say I think so it was you. Right? Now are you able to see the screen? Yeah, now I remember correctly. Okay. Yeah. Did we work on how to load the CSV file? Did we do this also? You remember that? Good. So data frames can also be created when we load the read underscore CSV file from music.csv and we get it in form of data frame. Another way to create data frame is using the data structure dictionary. The function that is used is pd.dataframe and we pass the value data. So the keys automatically become the heading of the data and the list becomes its value. Clear? Getting my point? Is this point getting clear to everybody? Right? Did we also understand the indexing? That this is the two types of indexing available in Pandas library. One is known as the label indexing. You remember that? The .loc. Did we do this also? And the other one is integer or position based. It's known as .iloc. You remember this point? Right? So if you want to access the labels, the column values are employee ID, skill, age, pay, and name, right? And the row index is this. But can I access them through the default values? Yes, I can also access them through integer-based positive indexing also. That is also possible. Clear? So the two types of indexing is label and ILOC. For label, we pass the values as 0 and integer values here. List, do you understand list index? want to access more than one column or rows, then I can pass them as the list. But the difference in indexing comes only in the case of slicing. What is the difference? That if I start from 0 column, it will also include the last part if I'm using label indexing. But for integer based, it is same as normal indexing that we have been doing, that only the 0th and the 1 column is extracted. Got it, learners? To make the point more clear, this is list indexing. So if I pass employee ID and skill, so only the column employee ID and skill get extracted. Clear? Getting this point? Right? Then if I say df.iloc0, then if I talk about the first row over here, what is the like value which gets extracted? The first row, the index based of the first row gets extracted. Clear? Why the row? Because no comma is given over here. So 0th is going to be considered as the row. This is again list indexing. Here we are talking about the 0th as well as the first row. Got it, learners? Now look at over here. This is label-based indexing. This refers to the rows and this refers to the column. What is this concept known as? The one with 2 colons. What is this known as? Striding. Very good. So we start with 0th and then we jump to values. We start with the 0th column and then we jump to values. Clear? Is this point getting clear to everyone? Over here, if I say employee ID till age, so employee ID is also included, skill is also included, and even the last parameter, stop parameter, age is also included. So these value get extracted from here. And did we also understand the in place parameter? Do we also understand the in place parameter? That whenever this parameter is true, that means the changes in the original data frame are seen. And when I give to false, that means no changes are being shown. Getting my point? Yes, learners, are you there with me? All right. Did we do this correlation part? I think so. We have not done this correlation. We stopped here. Did we do this or no? Not yet. Okay. Okay. So now let's get back to the code. Everybody has this file. Everybody has 4.02. Are you ready with 4.02, learners? Yes, learners, everybody is ready with this 4.02. So now we are clear with the code part of it. So what are the different ways from which data frames can be created? Yes, learners, tell me. What are the different ways from which data frame can be created? First is using a dictionary. The keys of the data frame become the column. First is dictionary. Second one we understood from list of list. Have we done it? Have we run all this code? Yes or no? List of list. Two-dimensional arrays. That's the third point. Then we loaded through the CSV file. Then we loaded the Excel file. Yes, Devika. Let's say, Arun, did we do all these? Then how can we access the data frame column? We did the beginning only, not the XLS. Is it that? We did not do the XLS and the CSV. We have to print from here. Okay, we did not do the Excel. Okay. So I'm sharing this data set. Please download this Excel file and be ready. Yeah. Please download this Excel file and put it in the same folder as these files, iris.xls, and load the data. Yes, learners? Everybody do it. And if anybody is not able to do it, please let me know. That's Yogesh, Navdeen, Muthu. Yes, learners, are you there with me? Others, I'm still waiting for response. Please download the file and copy it in the same folder where you have copied this pandas, and then run the code. It will run fine. Anybody who's getting the error, can I move forward? Let's say. Arun, can we move forward? Can I get a quick thumbs up from everybody? So, using pandas data frame involves employing various methods for selecting and retrieving data, whether it be specific column rows or individual cells. No, there is no library. There is no library to be installed. No, 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 you don't need to. You simply do pd.read underscore Excel, let's say. Got my point? Which is the library that you installed? Tell me, let's say quickly. No, not required. Not at all. Not required. Is it not running for you normally? Did you install this library, Hatse? Can I unmute you quickly? Yes, unmute.
Hello, can you hear me?
Yeah, I can.
Yeah. So it asked me to install this stuff. Then when I click
NPY,
install,
NumPy.xls, not required at all. We are using pandas over here, not the NumPy.
okay. So I think it is the PD or Empire. It just popped in here, and then I did
Okay.
install it. It says, let me put on the chat.
Yeah, put it. Or you want to share your screen? We can do that also. You want to share your screen and show us?
Sure. Let me do that.
Yeah, please go ahead.
I'm sharing, right?
Yeah.
Can you see my screen?
Yeah. Just zoom out.
Okay, so you see this one here? It just asked
No,
me, so
you
I,
need to zoom out. It's so small, I can't even see. Read it. And
oh,
it's, yeah, the screen is so black.
okay, I cannot zoom it. This is a,
Just copy, paste it, and put it on the chat.
okay. Let me copy and paste in the chat, so.
Conditions that analysts can navigate and extract the necessary information from the data frame for further analysis and manipulation. So if we look at over here, look at this particular code. We are converting a data frame from the dictionaries of lists, right? And if I want to access a single column, how can I do that? Simply by giving indexing, simple column name. But if I want to access multiple columns, I have to pass it as list index. This point is also clear. Are you all getting this particular point, learners? Yes, learners. Can I get a quick confirmation? Are you all there in the session or not? Or are you all sleeping? Going ahead. I told you this point, Hetze, that this single bracket is for the indexing. This is for indexing, and the other bracket is used to pass it as a list for multiple items. All right. Got it now? This concept is known as list indexing. Right? Now, if you look at df.iloc0, then you can extract the first row and see these items, right? The elements of the first row. Got it, learners? Please run the code. And if you're facing any difficulty, please let me know. Right? So now if we have df columns greater than 10, right? If I want to extract certain values based on conditions, then it can be done that only the values which have only the rows or that have column underscore name values greater than 10 are extracted. So you can access rows based on condition. So single columns, multiple columns, access columns based on condition. Are you understanding the different syntax? If I want to access a single cell by label, then the other function can be used is add function, right? By label, or you can also use .loc. Both mean the same thing. .loc or .at mean the same thing. This refers to your 0th row and the column underscore name. Clear? So just to make things easier, I'm just separating out the rows. Got it, Hatse, Sudhanya, Yogesh? You get integer at 0, 0, right? So what is the value at 0, 0? We can also access it via the positional values. Are you getting it or not? Please look here, learners. The label indexing is column name, column 1, column 2, another column. And if I talk about index, this is 0, 0, 0, 0. And the label index is also 0, 1, 2, and the default index is also 0, 1, 2. So when I do the df dot ILOC 0, 0, what will be the output? I'm talking about the 0th row and the 0th column. So the answer is 5. Now clear? Right? Now getting my point, everybody? Can I use conditional statement also? That all the column names value greater than 10. So conditional access for the value of another column. So here we are accessing with column underscore name greater than 15, but I want to extract the value of another column. Got it? Is my point getting clear to everybody? Yeah. Then we also talked about the basic, functions available in Pandas library. Do we understand the basic functions? Head function, do we understand? Tell me, learners. Do we understand the head function? Yes, it refers to the top 5 values. Tail, the last 5 values, right? Info gives the summary of the data types and non-null values. Describe gives me the descriptive statistics, summary of the statistics. Very good. Shape gives me the row and column of the tables. Column returns the column labels of my data. Then we have understood label and integer-based indexing for accessing of elements. Sort underscore values sorts the values. Then we will also understand group by groups the data frame based on one or more columns that we will understand as we move along. Getting my point? Apply, merge, plot, and drop. Clear? So now let's take this forward. Import pandas as PD. Again, I've created my data frame. So now if I explicitly pass the parameter head over here. Yes, please look here, learners. If I explicitly pass the parameters head over here, then it will only give me the first 2 head values. If I pass tail over here, it will give me the last value only. Data frame summary gives me info and shape is the number of rows and column. Everybody is able to understand the code and run the code? Yes, learners. Are you able to understand the code and run the code? Clear? We also need to discuss the statistical operation. Statistics is the heart of data science. I've been saying it from day one, right? Without statistical operations, you cannot get deeper insights into the data. So what are the different statistical operations that we can do? So one of the favorite function is describe. We all understand describe. We've understood it pretty well. We calculate the mean, the median, and the standard deviation. right? The same functions were available in the NumPy library also using np.mean, np.median, and np.standard deviation. Yes, learners, can you tell me the difference between mean and median? Can you tell me the difference between mean and median? Exactly, exactly. Absolutely correct. Mean is the average value, median is the middle value of the data. Are you getting this point? And look at the beauty. If I want to use the data frame dot mean, it automatically gives for each of the columns. Do you see that? And if I want to see it for rows, then I can pass it for, maybe access equal to 1. Yeah, I can show for each row again. See, by default, it is access equal to 0. There will be no change in the output. Look at over here. Is equal to 0 means I'll get it for each columns. Yeah. And the moment I change the access, I get it for that. Now clear? Devika, Hatse, Yogesh. Yeah. Another important, kind of analysis is correlation analysis. And this correlation analysis is completely based on coefficient, Pearson's coefficient of correlation. Yes, learners, are you getting this point? Okay. So the Carl-Pearson's coefficient of correlation will have values ranging from -1 to +1. Okay. And here, this is the formula that we are supposed to understand. Please try to understand. We need to understand the mathematical intuition, not the formula behind it. Okay. Sorry, we need to understand just the formula behind it, not the mathematics part of it. I'm really sorry. So these are the value. We take it, the difference from the average. Then yi, take the difference from the yi, right? And then we are able to do that. Right? So if you look at this, what does +1 mean? +1 means perfect positive correlation. What does it mean? That when x increases, there is a direct relationship between x and y, or a proportional, direct proportional relationship. X increases, y also increases, decreases, y also decreases. Right? What is negative correlation? That they share an inverse relationship, that if x increases, y decreases, or if x decreases, y increases. Getting my point? Are you all getting this point or not? Yes, learners, are you there? And when r is equal to 0, that means there is no relationship between x and y. So the stronger the value closer to 1, more positive relationship, and the value more closer to the negative 1, the more stronger the negative relationship. Getting my point, learners? Right? And which is the Python function which helps us to find correlation? It is df.core function. Which is the function? It is the df.core function. So if this is my data frame with maths, physics, and history marks, right? And when I run a df core, it will always and always create a square matrix n by n. Why? Because here there are 3 columns. It will also create a 3 by 3 matrix. The diagonal elements will always be 1. Please be clear. I have a very strong relationship, a perfect relationship with myself, a strong relationship of maths, strong relationship of physics with physics, history with history. But there is more valuable information added over here that maths and physics share a very strong positive relationship, whereas maths and history and physics share a negative relationship. Got my point? Is this point getting clear to everyone? Yes, learners. Are you all getting this point? Right? This point is clear? No, we are not going to discuss regression. That's part of machine learning. That's part of machine learning. I'd say we will not discuss that. So getting back to the code, how do we go about it? Here I've created my own data frame. And when I run df.core, this is the output of the correlation matrix. Getting my point, learners? I think so. I've made few changes in the data. So here you can see that again, diagonal elements are all 1. Negative relationship between column 1 to column 2 and positive relationship between column 1 and column 3, right? And a perfect negative relationship between column 3 and 2. So it is a negative perfect relationship. Yeah, I've made a few changes in the data values, you can check it out and you can get this output. Clear? Clear to everybody? Right? Then there is this another important function, value underscore counts, that the function tallies the occurrences of unique values. It is very, very useful for categorical data. Very, very useful for categorical data. How do we go about it? That if this is my category A, B, C, D, it gives me the category along with the number of items repeated. Clear? Yes, learners, are you all getting this point? Right? So if this is the region, right? Right? So the how many categories are there? East, north, south, west. And then it gives me the number of time it has been repeated. Clear? Value underscore counts function is also clear. Can we begin with the next topic? Are we all good to go, Ruby? Muthu, Deepak, Navdeep, who all are? This is the first session. Who all are the ones? Ruby is there. And I think so it was Yogesh also. So I would just, suggest you that please go through the recordings, and if you feel any difficulty, then you can get back to me. Okay, Ruby? You understood then till now? That's great. Can we move forward then, Ruby? Let's say, can I move with now 4.03 learners? Okay. Thank you. Thank you so much. What about others? Navdeep, Yogesh? But you're catching up, Mansi? Okay, that's okay. Okay, great. Now we need to understand the most important aspect of real-time data is the datetime module. If we talk about real-time data, every data will contain date or time as one of its column, right? Whether it's aviation industry, what time did the flight depart, what time did the flight come, whether it's retail industry, at what time did you buy those grocery item, whether it's our session, how long this session is going from this time to that time. So everywhere date and time logs are created. Agreed? Agreed, learners, or not? Right? And Pandas library, the datetime module is very general to Python, but Pandas, especially Pandas library, because here we deal with datetime data a lot. Therefore, it is our duty to convert the data into its special data type. We don't want it to keep it as object data type. So whenever any CSV file or an Excel file is loaded, right? By default, the data type of date column is always object data type. Clear? Right? It is always of the object data type, right? And it is our duty to convert it into date time data. What is the advantage? What is the advantage? If I want to know what will be the time after 1 week, 3 hours, after 1 year, that is where the date time module will help me to access that. Clear? Are you getting this point or not, learners? So in Python, there is this class date time, right, which has been created, which has different modules in it. Date gives all the access to the date. Time class gives all the access to time. Date time is a combination of date and time. Time delta is the class which helps us to perform arithmetic operations on date time object. Please be clear with this particular point that it is this time delta function which allows us to do mathematical operations on the date time object. And then we have the TZ info, which is known as the time zone info. Clear? Yes, there is a specific library for it. I'm just telling you, Hatse, that we have this date time, that's the module. We will import the date time module. Then we will specifically load the date class and then find out the today function. All right. Right. So the creation of date time objects can be through date or date time class, getting current date or time, conversion of object data type, pandas date range function, or the string parse time. We can convert a string to a date time object also. Okay. So how do we go about it? Let's get back to the file. Okay. Now please write today's date. Today's date is 7/3/2026. All right. And if I print this date, it gives me the value -22 and it says it is of class int. Right. So am I able to add any value if I want tomorrow's date? It does not give me the, correct answer. And even if I put it in strings, then then it does not even allow me to add the value. Do you see this? By default, there is no date time object. How can you create date time object? Date time object can be created by importing the date time library as DT. Please try to understand, right? Please try to understand by importing the date time library as DT. Got it, Hatse now? Devika, Navdeep, Yogesh, Mansi, Ruby. And now if I print it, it prints me in the format first year. Year values come that the year is 2026, month is 03, and the date is 07. And this belongs to, its type is date time object. Now clear? And similarly, I can do a date time now, which gives me the combination of date and the present time here. I'm waiting for your response. I don't want to be in a hurry. Learners, are you there with me? Everybody is able to run this code or not? Everybody is understanding this? Great, great. But we understand the beauty of pandas that now if I want to, no, I did not change any format. This is the by default format. By default, the date time objects are stored as year, month, and day. Okay, Hatse? I have not changed any format, anything, or anywhere. You want me to change one? Okay. So now if I want to change its format, right? No, I want to change the format of the date time object, right? This is what you want me to change today, right? So I will use dt dot, you can write down learners with me, dt dot strp time, right? Then which is the date I want to change? Today, right? In which format I want to change? I want to change the format as %d slash %m percentage capital Y. Okay. Did I am using the function correct? strp time. Okay. It is a string that I can change. And if I want to format it, okay, sorry, we will not use strp time. I'm so sorry, that is only used for the string. We will use strf time. strf takes at most one argument. Okay. Yes, this is how we will do it. Sorry for that. Sorry for that. Got it now? Sorry for that. Yeah, I'm just copying the code now. You wanted the month first? Yeah. Now better? Can I change it to different styles also? Yes, I can do that. Let's change it to small y. Let me put this as B. Yeah, look at the different formats now. It's March 7, 2026. Clear? Are you all getting this point? How can we change the format? So the small m, I'll just show you all the points. And this is my capital Y. Now clear? Everybody is able to run the code along with me? Okay. So if I get back to the PPT, I think so the PPT will give you more clarity. What is the issue? Who says I have issue? Let's say what is the issue? Would this format of the date, which is into string, be used for time series? Yes, yes. Exactly. That's the idea. Not taking percentage T. Share your screen quickly. Let me check. It does it for all the values. Now clear, Mansi? Yeah. And your question had said this point is clear? Yeah. Yeah. And coming to your question, does it sort automatically? So let's put this date as 2026. Let's put it as 10th month. This is 23 and this is 23. Okay. So let me see that. This is the data frame, right? So df, let me do the sorting for you. No, it will not sort it at the moment. It will not sort it at the moment. Please try to understand. Now, please understand. Let me explain the concept and then I'll show you the sorting. First, try to understand that when I am creating this data frame, what is the data type of this date? By default, it is of an object date type. Agreed? That's it. So even if I want to do sorting of this, okay, it considers this as string. Yes. Okay, let me try it then. The function is index. No, we want sort underscore values. It sorts. Is it sorting? Yes, it is. Got it? Yeah. Now from this column, is it possible to fetch just the month? Yes, yes. Even if it is a string type. No, it's difficult for a string we to extract. But now then accessing, then why do we want date and time column? So now the beauty is, Mansi, that now we will try to convert it into date time object. Now you see, by using pd.to underscore date time, I am able to create this new column of date time object. Clear? And then we have this DT accessor. Now suppose if I want to access it from the date is of string type. Does it give error to me? Yes, it will give me error, right? Because date is of string type or object type. But the moment I convert it into date time object, then by using this DT accessor, I can extract the day, month, and the year. Now clear? It does not give me any error. Now suppose you give any wrong value over here. For example, let's understand. Suppose I give this month as 13. Okay. Does it give any error over here? No. Why? Because it is It is a string. It does not make any difference to it. But the moment I convert it into date, it will give me an error. That's the beauty of date time object, that the month will be in 1 to 1 to 12 values for this particular date. See, it gives me exactly where the problem is. So that's the beauty of date time object. That's why the logics are inbuilt, right? And the logic is so beautiful. The logic is so beautiful that if I give the February month day, this is 20th, and if I suppose give it as 29th February, there was no 29th February this year, it still gives me an error. Got it now? That's the beauty of this library and creating date time objects. Strings will not do any kind of verification for us. Got it, everybody? Clear, learners? Are you all getting this point, what I'm trying to say? That the date time object will also check the month. It is so smart that if you give, like, suppose you give the 10th month, suppose you give the month as, which month is this? March. March has 31 days. Okay. So let's put it as maybe April 04, and I pass this as 31. It will still give me error. It will still give me error. Let me put it over here. See how smart it is. It will still give me error. So it's the 4th month and the date is 31. Got it? Everybody is getting this point, but the moment I give day over here, it gives me the correct answer. Got it now? Mansi says dates have been very challenging for me. Which are the most important function we need to keep handy, which converts string to data object, vice versa, then fetching the month or day from the date object. I'm telling you that only, Mansi. First of all, conversion of the object to the date time object can be done, right, using the Pandas library directly using this. Conversions can be done using this function. For the Pandas library, please use this function. This is the most handy function, pd2 underscore date time. Okay, this is the first function. And if you want to make changes into the format of date and time, then you can use strf time that I explained over here. Okay, second point is clear. Third point, you are saying that you want to access specific month and date out of it. Then once you have created the date time object, then use this DTX specifier for day, month, and year. Now clear? Are your three queries clear? All the three queries clear? Yeah. Now, another important thing that I want to tell you is that now suppose, Mansi, you are interested in creating a roster, right? Where you don't want the weekend values to be entered. You only want the values to be from Monday to Friday, right? That can also be there. That kind of logic can also be there, right? So when you say that I only want the days from Monday to Friday, that logic you have to implement over here, right? For example, let's start with 7 because we understand the today's scenario. We are on 7th of March today, and within 1 week, these are the values that will be generated, right? From 7th to 13th of March. Agreed? Right? Now, when I want to extract the weekday value, by default, this date time library will put 0 value for Monday. 9th is Monday. This is Tuesday, Wednesday, Thursday, Friday, and Saturday, Sunday, it takes 5 and 6 value. This point is getting clear? So what logic you will apply? We will apply the logic. Everything it will not do. We will apply the logic that if the division is equal to 5, then it is a weekend, or it is greater than 5, then also it is a weekend. Rest all the values are weekdays. Agreed? Have you understood this concept? Yeah, that's the logic that they have put in. You can say that, yes, Python calendar or value starts from 0, right? And it is not only for this. Suppose if I give the values for 10, right? 10 days, right? So again, for the next Monday, the value will be 0. For all Mondays, the value will be 0. Got my point? And for all weekends, the value will be 5 and 6. Better? Is this point getting clear to everybody? So you will have to put certain logics if the functions are not there. Now clear? And another important thing that you need to do is addition and subtraction of the dates, right? Now suppose you want days after 1 week. What is the value? Day before, and what is the value day after? Suppose I want to run this. What is the error? It's not day, it's days. Okay. Yeah. So 7th of March, the previous days was 6th, and the next day is 8th of March. For 8th, it is light. And if I change the date, now suppose if I change the date so that we understand it better. So we start at 28th of February and then try to find out the values. So do you see 28th of February? Previous date it is saying 27th February, and next date it is all automatically telling me 1st of March. I have not put any logic. Clear? So this is what you want to play around. Now it's going to be easier. Once you load the data with this date time library. Learners, are you all getting this point? So the time delta function in Pandas helps us to create duration or differences between the dates or time. So this is the, function or the library which helps us to perform mathematical operations, right? So how am I creating a date time object over here? Using pd.date underscore range. The start value is 1st of January 2023 with frequency h, and these are the values that I get. Are you all getting this point, learners? The frequency specifies that now the 10 values will be created after each hour. Right? And the beauty is, if I give the frequency as D, it will create it on daily basis. Now, if I give the frequency as month end, it will create it for January, February, March, then April, May, June for 10 months, right? So everything can be created with this time delta function or the date time library. Clear? Is this point getting clear to everyone? Yeah. So now moving ahead, now we want to add 3 days onto the delta. So now when I run this code, so 31st of January, 3 days becomes 3rd of February. Similarly, 28th of February adding 3rd of March. Clear? Is this point getting clear to everybody? So how can you perform arithmetic operations on the date time object? Time delta objects can be used to perform arithmetic operations on dates. For example, adding time delta to a date results in a new date, right? So it's not about only days. You can add weeks, days, and hours also. So again, if my starting date is 31st, you can add the, the next week along with the number of hours and days. Got it? It will do the mathematics and the logic, all logic for you. Got my point? Is this point getting clear to everybody? How do we learn about parameters for the date function? You can check out the online resource, Mansi, that would be the suggestion. Date, time, delta, Python. Yeah. So this is the link. I can share it with you. Got it? So online resources are the best since everything is available online. You can find out what W, what R's, what everything means. Everything can be studied over here. Clear, learners? Is this point getting clear to everybody? Questions? Any doubt over here? So this is the link I've added in this particular file. Now clear? Are you able to make the changes along with me? Everybody is getting this point? And then we move on to the resampling of time series. This point is clear? How arithmetic operations can be performed? Then there is also known as resampling the time series data, right? Mansi, sometimes you want to increase the value or resample it. So time series often comes with irregular time. Resampling the process of changing the frequency of time series data, either sampling or down sampling. So again, that can also be, you can find out how resampling can be done, right? So this is how the resampling can be done. That will give you more idea since you work maybe more on the date type. Can you quickly share, Mansi, like what is your background? Where are you using? Are you working as an analyst at the moment? Learners, are you understanding this point? Yes, Mansi, can I get about that? So here what we are doing, we are setting the index with date. In place is equal to true. That means we'll make the changes in the original data. Then select the data types, include number, resample D, and find out all the values. So what it is doing, let me run it. So these are my values over here. It's not been able to give me the sum of the values. Let me put it to hours only. I'm again changing back the data. Right? So when you take the values, it will give me the sum. You can also take the sum, the average, whatever you want to take, right? Okay, okay, Mansi, got it. Clear to everybody? Are we clear with this date time module? The resampling of the data values is, suppose, you have these values, for the last previous months and you want to calculate all the values, then you can use resampling to calculate the sum of all the values from all that particular date. Resample it, take the summary of the data. Got it? Hatse, are you getting this point? Right? So have we understood this date underscore range function, which helps us to create date time index object belonging to a particular range? How can we extract the date and time components using the DT accessor, where we can extract its month, date, and time also? And then we have also understood the time delta function, which helps in mathematical calculations of the data by adding, subtracting the days, weeks, or the years. Clear? So now if you want to know how much time a particular flight took from one place to another, then by using time delta, you can perform these operations. Clear, learners? It's non-numeric, it's qualitative. Very good. What are the two types of categorical data? Tell me. What are the two types of categorical data? We have quantitative data as well as we have ordinal data as well as nominal data. Ordinal as well as nominal data. No, do we understand ordinal and nominal? Do we understand that, Mansi? No, not yeah, categorical data is also known as qualitative and we convert it into binary. But what is ordinal data? Something which is in order. For example, the grades. Exactly, the marking, the ranking, they all are ordinal data, right? And when we talk about nominal, there is no ranking, for example, postal codes or gender. Why is it necessary to analyze categorical data separately in data science or analysis? Tell me, why is it important to analyze it separately? Because machine learning algorithms, please try to understand, because machine learning algorithms do not understand them separately. Okay, they don't understand your eyes colors are red, green, or brown, or you're male or female. They need to convert it into binary data. Absolutely correct. Absolutely correct. We need to convert it into binary data, and there are functions available in Python. I've given you a quick snapshots of that. If the data is nominal, we generally use one hot encoding. In Pandas, we use the function get underscore dummies, which is very, very popular. We use it in a lot of machine learning algorithm. And then we use the Scikit-learn as one hot encoder. Clear? Then we also use as label encoder, that is the Pandas cat dot codes, that's converting it into categorical values, or we can also use the label encoders. So Scikit-learn is the library that we use for machine learning. So just given you insights about that, but here we will understand Pandas categorical codes. How does it work? Let's understand. If we have a column in our data set with different categories such as apple and orange, so by default, this fruit column, the data type is object, right? But the moment I do the data conversion dot as type category, I get this output. Then the moment I do the conversion as dot as type category, we get this output. Clear? So we get two types of objects or categories, that is apple and orange. It looks the same, but internally it has converted the string data type to categorical data type automatically by detecting. So pandas give us function to handle categorical data, which is that function pd.categorical data. So here I pass the values such as low, medium, high, low, and I pass the categories. So it understands that low has value lesser than median and medium has lesser values than high. So low is lesser than medium, medium is lesser than high. Clear? Is this point getting clear to everybody? And how do I calculate the frequencies of different categories? How do I calculate the different frequencies of category? By using the value underscore counts function. Very good, Mansi. Let's say, are you getting this point? Navdeep, Yogesh, Deepak, Devika. Great. And how can I create? How I can do one hot encoding for ordinal and nominal? For the nominal one, I can use the pd.get underscore dummies function. For df category, prefix is category. So this is one hot encoding. So the output will always be in true and false. So since the first value, so I've not printed the data frame over here. Let's print the data frame. Right? If this is my data frame and this is my categorical value. So since the first column only contains A, right? So the first value will be A. So let's print like this. I think so that would be better. Please look here, learners. So since A is there, so only the first index value for A is true. So its alignment has shifted. So again, let me share the code. This is the category. Now look here. Now since the first value is A, Therefore, the first value is true. All other values will be false. For the second row, B is true. All others will be false. Got it? One hot encoding. Get underscore dummies function is clear. And how can we do label encoding? By simply df.category, changing the category type as categorical codes, and then we get the output as 0, 1, 2, 3, 4. Clear? Very good, Mansi. It's generally converting the lowercase to uppercase to lowercase, stripping, finding the length. So the Pandas library also gives me support of this, right? So if I have created a data frame of all string values, or a column consists of string values, and if I want to know the length of each of the column, then I can use the str.length function. Getting my point? Is this point getting clear to everybody? So if this is my data frame, right? And I create a new column length just by giving a new value and just passing this str.length function. I give length of each of these words. Getting my point? Let's say, are you able to run the code? Turla, Yogesh? Yeah. Can we move ahead? What will this str.lower function do? What will this str.lower function do? Yeah, it will convert all the values into lowercase. And if I give it to upper, what will happen in the upper? Yes, Ruby. Got it? Then there is this function known as contains. What will contains function do? What will the contains function do, learners? Please check the code and let me know that it will if a string contains a particular data or not. That if the data is part of that string or not, it is there, it gives me true. And it is not necessary that it has to be a whole word. It can be a character also. For example, I give it as L. So hello also contains L, world also contains L. Other two become false. Right, learners? Getting my point? Clear, learners? Are we good to go? Right? Now, let's understand the concept of iteration. What is iteration? What is iteration, learners? Looping. Now, why in Pandas looping is considered more important? Because Pandas represent the real-time data. So either you want to iterate each row together. We don't want to, iterate separate items. Agreed, Mansi? Rupi, Yogesh? We want to iterate the whole row together. So Panda library has developed different functions to iterate the rows of the real-time data set. So iteration in pandas typically involves traversing through the rows or elements of the data frame or series. However, it is important to note that the direct iteration over data frame rows using Python's for loop is generally discouraged due to performance reason. So generally the direct iteration that we want to perform is discouraged. Why is it discouraged? Right? Why is it discouraged? Because we want efficient methods for iteration to access all the elements in the data frame. So therefore, several functions have been developed. The first one is iter rows. The second one is iter tuples. The third one is iter items, right? So let's understand one by one. Yes, learners, are you there with me? Yes, so we have created a data frame with column 1, 2, and cal values, some 100, 200, 300 values. Yes, learners, are you there with me? Getting my point? What does the iter rows do? Please try to understand. Iter rows will do index and row. It will take two values, index and row. For each value of index, it will store the value as a tuple. Getting my point? Then in the next row, the next value as this tuple, and in the third row, next value as this tuple. What I'm trying to say is, let's understand over here. I hope these PPTs are also helping you out. I hope these PPTs are also helping you out to understand things better, to get your concepts right. Okay. So iteration in pandas. Iter rows is generally used for smaller data set and it's quite outdated method right now. Apply function for complex row wise transformation. We generally apply for complex row wise transformation, and then we have the vectorized operation. What do we mean by vectorized operation? What do we mean by vectorized operation? One-to-one area, element by element operation. Clear? Is this point getting clear to everybody? So one of the limitations of iter rows is that it does not preserve the data types across the rows. It can change the data types. Each row is automatically converted to a series because a single row is one-dimensional array, which might lead to type changes if columns are of mixed data types. Why? Because series are of homogeneous data type, whereas a column can be a heterogeneous column. So that is why this was the flaw in iter rows. And we also understand that this is less efficient for large data frames compared to the vectorized operations or methods like apply or iter tuples, especially when performing operations that can be applied to entire columns or data frame at once. Clear? Got my point? It is generally not recommended to modify data frames while iterating over it using iter rows, as this can lead to unexpected behavior. Got my point? Are these points clear? The limitations of iter rows and why we avoid it at the moment? Okay. Okay. Then let's move on to the iter rows syntax. The syntax of the iter rows methods in Pandas is that for index and row series, automatically it gives me two outputs, index and row series, when I iterate using a data frame with iter rows. Clear? So if you look at this particular example for this data frame for columns year and sale, we get this ID for the index values and the row as tuple. So when I extract the value for row year and row sales, I get these points. Clear? Is this point getting clear to everybody? Are you all getting this point? Right? Got it, learners? Yeah, this can be repeated. Mansi, if this is my data frame and I am using this iter rows function, two values which it returns is the index value by default and row as tuple. Index is the index of the current row where we are iterating. A row underscore series refers to the data of the current row. So what does it return? An iterator yields a pair of tuples containing the index and data of each row. So how do I access them? Once I'm iterating, I can access them using index value. Now clear, Mansi? Okay. So which are the better other methods to iterate over the data frame? Another function that we use commonly is the df.apply function. So df.apply function, I want to find out the sum of the value when axis is equal to 0. Axis equal to 0 means taking all the rows together. So for P column index 0, 1, 2, if I take the values, I get the value as 27. And for the other one, I take all the rows, I get these value. Clear? That means I don't have to iterate. And in this case, I don't even have to run explicitly any for loop. It will automatically do it for me and give me the result. Clear? Right? And when I give access equal to 1, access equal to 1 refers to taking the all rows together. Clear? Getting my point, learners? Iter tuples are generally not used only. Generally, these two methods are pretty outdated. We are not using them. This is just for your information. We are not using these two methods at all. Okay? Got my point, Mansi? So now let's understand the apply function. So this is my column, and in the existing column, I apply function using the lambda function. What is a lambda function in Python? Yes, learners. What is a lambda function in Python? Yeah, function with no name, single expression. So it will take the square of the values. But actually, do we require this apply function also? Not really. Not really, because now we are looking at the vectorize operation. That is element by element. So if this is the thing, I can directly use the plus sign also, right? Can I do this operation like this also? Rather than even using the apply function, can I directly do it as into 2? Right. So this is the new technique, Mansi, that is I'm talking about. We all use vectorize function nowadays. Got my point? Let's say Yogesh, Ruby, others, please respond. And which is the fastest method? Can you tell me? Among the apply, vectorized, and the iter rows or iter tuples, which one is the faster method? Of course, the vectorized operation. Of course, you all understand that. Right, learners? Clear? Clear to everybody? And similarly, can we do it over the series also? Yeah, we can do it over the series also by using the series dot items. Clear? Now let's understand sorting. What is sorting? What is sorting, learners? Arranging the data in ascending or descending order, right? Right? And what is ascending and descending? Ascending is from lower to higher and descending is higher to lower. And what about strings alphabetically? What does ascending mean alphabetically? Very good. Everybody understands this? And descending is Z2. Very good. Right? So if I have this data frame, sort underscore values employee ID. By default, it is arranging the data in ascending order. And if I want to arrange in descending order, what will I do? I will pass the parameter ascending is equal to false. There is no descending parameter, but we will pass the parameter ascending is equal to false. Clear, learners? It's okay, Mansi. Right? But what happens if I want to apply sorting on multiple columns? Please look here, learners. Now, if I want to apply sorting on multiple columns, how do we go about it? So the first one says skill based on ascending value. So skill is alphabetically. So we see that J comes before P and capital values have higher priority than the lowercase. This point is also getting clear. The capital letters have higher priority than the lower case. Getting my point? This point is getting clear to everybody. But in the case, please try to understand, multiple columns come into the picture. Now, when we have this JavaScript over here with same values, then the employee ID will do the sorting based on false. Got my point? Is this point getting clear to everybody? Got my point, learners? And can we do the, I think so, this is what Hetze was talking about. If we want to do sorting for the row wise, then first we will set the index employee ID in place equal to true. That means the changes are reflected in the original data frame. And then we can, right? And then we can do the sorting also. Got it? Set index is used for sorting of the rows. Got my point, Hetze? And if I want to do it alphabetically for the columns, then I will just say sort underscore index, pass the access. So age will come before P and P will come before S. Clear? So the first sorting I want to do is by name, that to ascending, false. That means the S is coming before C, before B and A. Or if I want to change the column type, I can of course do that. Do it on the basis of salary. It's completely up to you, right? And if I do not pass this ascending is equal to false, it will by default do it in ascending order based on salary. Clear? Are you all able to run the code and try different combinations? And if I want to do it on, and if I want to do it on multiple columns, how do we go about it? The first is age. Age is done in ascending order. And then name in descending order. So what is the criteria? That if the age of these two is same, then I'm giving name in descending order. Therefore, Sam will come before Bob. Clear? Mansi, Hetze, Yogesh, Ruby. Is this point getting clear to everybody? Sure, I will. Yes, Hetze, is it fine? Or do I need to scroll down further? Is it fine, Hetze? Why Alice is before, Charlie? Now, if I am doing age, Alice, because it's in ascending order, na? Ascending order by the age. First criteria is age. So these comes before and then 25 and 30 in ascending order. First criteria is age. Then by name. Now clear? Is this point getting clear to everybody? And can we do sorting by index also? Yeah, we can do it by df.sort index ascending false. So automatically it will change the rows based on the index values. All right. Not necessary to set the index. If you don't set the index also, still you can sort via the index values. Clear? And if I want to change the through the axis, let's do that. Let me do it as axis equal to 1. Please make the changes in the code. Now I see first salary will come, then name, and then age. I'm doing it via the column. Are you understanding this? The change, I am now doing sorting based on the column. Clear? Are we all good to go? And similarly, we can sort the series also. Series is like one column. So series dot sort values ascending is equal to false. And that's how we get the point. Yes, learners, are you back?
Okay.
Are you there? Mansi, there was no file such as 4.05. We have a file named 5.01 because now we are moving to the next lesson. All right. That I can share it before for sure. It is a different notebook, but with now the indexing changes because now we are moving on to the next topic for data visualization. Exactly. Got it, learners? Are we good to go? All right. So what is data visualization and what is the need of it? Can you tell me, learners? Graphs, is there? Yes. What kind of graphs? What kind of charts, Ruby? Yeah, bar, histogram, violin, right? Why do we require different types of graphs? Why do we require different types of graphs? Very understanding of what data speaks to understand the data easily, right? Because for different types of data, absolutely correct. Hinsay. So every graph gives different types of data. Absolutely correct, right? Now, again, we have understood the crux of data science is the statistics. So there is a very strong relationship between data visualization and statistics. So let's try to understand that particular point. So now when we try to analyze the data, basically we are trying to analyze its data distribution. What do we mean by data distribution? Yes, learners. What do we mean by data distribution? How well the spread of the data is, how the variables, no, how the spread of the data is. I'll try to explain this particular point with the help of a very, very small example. Exactly. But why do we need to know the spread of the data? Let me explain this point to you that why standard deviation and variance are important. Now, if I have a data set with 555 values, what will be the average of this data set? It will be 5. If I have values 0, 7, and 8, what will be the values? What will be the average of these values? Yes, it will again be 5, right? But when I talk about the data distribution, this is like a single line data, and here it is spread between 0 to 8. Yes? Are you getting this point? Why different statistics is required and how graph helps us to analyze that distribution? Clear, learners? Another important concept in whole of data science is probability. What do we mean by probability? Yes. So probability is an important point because it tells the what is the possibility of occurring event, right? What is the range of the value? So generally, we are now going to understand the distributions in terms of probability. Let's understand it with an example. And before that, in this whole of data science concept, we also need to understand the topic of population and sample. So what is population and what is sample? What is population and what is sample? Population, we are not talking population about the whole world, a country or a city. Sample is the subset of population. But what is population? Population is the entire data set or all the values or items under observation. Getting my point? Absolutely correct, Mansi. Population is all the items and values under observation, and sample is part of it. But why do we talk about the sample? Hadse, Mansi, Yogesh, Ruby, Navdeep, Yogesh, tell me, Kamal. Why? Why do we need to understand the concept of population and sample? Elaborate that point, Mansi. Represent the behavior. Yeah. Why? Because the whole population can be really huge, time consuming, as well as lot of cost taking. Getting my point? It can be time consuming and lot of cost taking, right? So rather than analyzing the whole population, we only take a part of it, and from that particular part, we conclude about the population. Got this point? The concept of population and sample is clear to everybody? Clear? So, another very, very important part of data visualization, which nobody covers, statistical data distribution is important part of the whole analysis because it describes how data points are spread out across different values in a data set. Understanding these distributions help in analyzing and interpreting the data, revealing the patterns. They help in revealing the patterns, the trends, and the underlying structure. Got my point now? So, what is this probability distribution? Let's try to understand that. So, the different types of graphs or the distributions that we will understand as we move along is bimodal, having two peak values, comb having several peaks, edge peak, like at the end, we can have this edge peak. Normal is this is normally distributed. Skewed is left or right. And then we have uniform distribution. Getting my point, learners? Are you all getting this point? So now if we move on to data visualization, visualizing the distributions of our variables is an important step, right? So it is the Matt, did I miss I missed that distributions. Yeah, probably. That's what I was wondering. Yeah. Please look at this probability distribution. So when we are segregating the data into training and testing, so what is training and testing data? Is it the whole population or again a subset of the population? Mansi. The training and the test data is also not the whole population. It's the sample. So that's the whole criteria that from the sample we will try to conclude about the whole data set. Got my point? Yeah. So I was talking about probability distribution. What is the probability of getting one when I roll a dice? What is the probability of getting? It is 1 by 6. What is the probability of getting 2 when I roll a dice? Again 1 by 6. So my x-axis consists of all the events. So when I roll my dice, what are the possible outcomes? 1, 2, 3, 4, 5, and 6. They can only be 6 outcomes, right? And what is the probability of getting each one of them? It is 1 by 6. Getting my point, learners? Same probability. So when I look at this graph and on the y-axis, this is the probability which represented. So what represent this? So what kind of distribution I get? I get this as uniform distribution. Clear? Isn't it very much clear through the graph? Got it, learners? Clear, learners? Then if I talk about the sum of, if I roll two dices, what could be the possible outcomes when I roll two dices now? What are the possible number of outcomes, total number of outcomes when I roll two dice? First dice can give me 1 to 6 values and the second one can also give me 1 to 6 values. So 6 into 6, 36. And on the x-axis, if I want to calculate the sum of the two dices. So what is the minimum value when I roll two dices? 1, comma 1, right? That is 2. Then I have 1, comma 2, 1, comma 3, till 1, comma 6. Getting my point? And it will go till 6 comma 1, 6 comma 2, 6 comma 3 till 6 comma 6. So the minimum sum of rolling two dices is the sum of the two values is 2 and for others is 12. Getting my point? This is 2 and this is 12. Clear? Are you getting this point, learners? So what is the probability of getting the sum as 2? Tell me, Tulla. What is the probability of getting the sum as 2? 1 by 36 because the option is only 1, 1. What is the probability of getting sum as 3? It is 1, comma 2 and then 2, comma 1. And what is the probability of getting 7? What is the probability of getting 7? It could be 1, 6, 6, 1, then 2, 5, 5, 2, and then 3, 4, and 4, 3. So 6 outcomes. So 6 by 36, 1 by 36. So now if I look at this kind of distribution, it shows me normal distribution of the data. Clear? Is this point getting clear to everybody? So data visualization is very, very important for our variables. It is an important step in exploring and analyzing the data. Matplotlib is one of the basic foundational libraries which we use for drawing different graphs in Python. It helps us to draw different graphs such as bar graph, histogram, scatter plot, area plot, and pie plot. And this basically library was developed by John D. Hunter in 2003, right? And if we look at the Matplotlib, technically, right, it consists of 3 layers. The backend layer or the lowermost layer is known as the backend layer. Secondmost layer is known as the artist layer. And the topmost layer is known as the scripting layer, where we can write the code and it is we as users who write the code at the pie plot. That is why we always write import matplotlib.pyplot as PLT. We don't import the whole file because we as users are only allowed to work on the scripting layer. Clear? And the below layer is artist layer, which helps us to draw the rectangle, lines, circles, and other layers. Getting my point? And it is the backend layer which handles all the mouse clicks, strokes, how to draw figure canvas, and etc. Clear? So if we look at a particular figure or graph, it will have its own title. They can be a bigger figure, right, in which we can have multiple subplots or subfigures, each having its own title, own axis, X and Y axis, along with their legends, right? But how are we able to create multiple graphs in one figure area? We are able to create multiple graphs with the help of subplot function. Please try to understand. We are able to create those graphs with the help of subplot function. That is, we have the number of rows, number of columns, and the index. What do I mean by that? Please try to understand. How many graphs do you see on the screen? How many graphs do you see on the screen? 6. What are the number of rows? 2. Number of columns? As 3. So the subplot function, as I'm telling you, the first parameter is the number of rows. That means it consists of 2 rows and 3 columns. So all the subplot function contain these 2 parameters, 2, 3. And the last parameter is the index function, which tells me this is my first graph, second graph, third graph, fifth graph, sixth graph, etc. Clear? So now let's practically move on to 5.01 and draw graphs practically. Okay, So now let's move ahead and understand data visualization. It is nothing but the graphical representation of data to reveal patterns, trends, insights, and might not be easily apparent from the raw data. So obviously, now isn't it taking into account the human instinct? We catch images more than the text. If I say, what would you prefer? A Harry Potter movie or a Harry Potter book? What would you prefer? Tell me. Kamal, tell me what would you prefer, a book or a movie? What will give you more deeper insights and understanding? Book and then movie? Movie will give you all the points. So that's how a human mind has been trained, right? So when we are in our kindergarten days, we are always taught A for apple. So the image of the apple is there, B for ball, right? So that's how the human mind is made. And definitely the different types of charts, graphs, and maps help our understanding better to get more deeper insights about the data. Agreed, learners? That's how we humans are made, right? So we understand that Matplotlib is a comprehensive, widely used data visualization library in Python. It provides a flexible platform for creating static, animative, and interactive visualization. The different types of graphs are histogram, pie chart, subplot, tree chart, scatter plot, and bar chart. Can you tell me the significance of each charts? Why is each chart required? Because as you told me, different types of data. Now tell me what is the use of histogram. Do you understand histograms, learners? Anybody who can tell me the use of histograms? Frequency. No, it gives the distribution of the data. What in terms of frequency, Nancy? And what does the pie chart tell you? What does the pie chart tell you? That doesn't give the frequency, that gives the density of the data. Okay. It shows the proportion of the whole set. Very good, Devika. Very good. Subplot we have understood. It helps us to draw the different graphs on that same figure. What about the tree chart? What is the use of tree chart? Nobody understands the use of bar chart? Yeah. It is used to represent categorical data. Learners. Now let's move ahead. Categorical data is clear? That normally in data science, the data is divided into numerical and categorical, and therefore different graphs are required for the different analysis. Clear? Is this point getting clear to everybody? Got it, learners? Okay. The first and the very basic graph that we will understand in Matplotlib is the line plot. A line plot is a basic type of chart that displays information as series of data points which are connected by straight line segments. It is particularly useful for showing trends over continuous intervals of time. So here we are trying to generate our own data that is known as synthetic data by using the linspace function of NumPy. So can anybody tell me what is the use of linspace function? Yes, learners, do you understand the linspace function? Gurlat, explain. Mansi says no. 10 space function is that we start from 1 and we will end at 10. 5 will give me that now 5 values are generated which are equally distant from each other. It will create equally spaced values depending on the range of values that you pass. For example, if I now change it to 10 and now change it to 100 and now I want 5, well, not the step. Yeah, something like step also. Yeah, something like step. We start from 10, we end till 100, and here we are adding 5 values equally. So automatically it will do it for us. If I want 15 equal values, this is how it does it for me. Clear? Mansi, Ruby, Hatse? So here we are, obviously we are initially drawing two-dimensional graphs, right? And this is my x-axis and this is my y-axis. Right, learners? This is my x-axis and that is my y-axis. So I need to pass my x-axis data. I'm using my np_lenspace function with starting value as 0, ending value as 10, and I'm creating 100 equidistance points over here. Y is np.sinx, that y values are sine values of these x 100 data points. Clear? So definitely for drawing the graph, we require x and y values using the plot function. The label parameter adds the label into the graph. Color over here, I can change also. I can change the line style also along with the line width. Getting my point, learners? Right? And now, if I want to find the label given to the x-axis, I can use the x label. If I want to give the label to the y-axis, I can give y label. And for the title, it is the line plot. And I'm also adding the legend onto it. Clear? So this is my title. Please look here. This is my title. Line plot is equal to sine wave, right? This is my x-axis label. This is my y-axis label. This is the legend that we have added over here. The color is red. The design is this. Can I change the aesthetics of this particular graph? Yes, I can do that. Please look here, learners. Can I change it to green? Can I increase its line width to 4? Can I change the style? Let's see. So it says that this line style is not allowed. It's not valid. Either you use a single slash, double stack, slash, or a half. So, or even a colon will work. So let's do it with that. Yes, learners, do you see this? Have I been able to change the aesthetics of the graph, learners? I want to give you understanding of each and every line of the code. Yeah. Are we good to go? Okay. Can we move ahead? What is the use of scatter plot, learners? Tell me. What is the use of scatter plot? Not always correlation and magnitude, but you have to, yeah, it gives you correlation whether it's positive or negative. But you have to understand that it always helps us to find the relationship between two continuous variables. That's the answer I'm looking for, Mansi. That's the more technical answer. Clear, learners? Right? Okay. Now, each plot point on the plot represents an observation, and position of the point is determined by the values of the two variable. It is helpful in identifying patterns, clusters, and trend. Okay. So here we are using the function rand and randn from the np.random file. So what is the use of np.random library? Yes. What is the use of np.random library? Yes, learners. For generating random numbers. Okay. Now tell me the difference between rand and randn. Rand will generate 10 numbers between 0 to 1. And what is the use of randn? What is the use of randn? Random means normally distributed data. What does N? No, not uniform, had say. Normally distributed data. A normal distribution looks like this with mean value equal to 0 and standard deviation equal to 1. Clear? Is the difference getting clear to everybody? So here I am trying to generate the random value synthetic data. X-axis, I'm generating 100 values between 0 to 1. Y, I am generating linear lines between normally distributed. And now I am using this plt.scatter function. Plt.scatter function, right? To create a scatter plot in which I pass the X and the Y value. The color is equal to blue, marker is equal to D, and label is again random data. Now we are clear what is the use of X label, Y label, and title. They're self-explanatory, right? Learners, are you getting this point? Can I change it to different style? No. Do you see this now? Everybody is getting this point, learners. Questions? Any doubt till here? Can we move on to the next graph? Are you all understanding the code? Able to run it practically? Are you all understanding the code? Able to run it practically? Good. Now let's understand the bar chart. What is the significance of the bar chart? What is the significance of the bar chart? It is used to represent categorical data. It uses the rectangular bars of length proportional to the values they represent. This chart can be used for comparing the sizes or frequencies of different categories, right? So here again, I'm generating two different synthetic data for categories and value. So one of the column has to be categorical. Please be clear. One of the data, one of the axes has to be categorical, category A, B, and C. So PLT dot bar, again I pass x-axis as category, y-axis as values, color is orange, edge color is black, and that's why I get this output. Box plot helps us to represent the statistical summary of the data. Clear? So basically the distribution, like if we understand this distribution, this is normally distributed. All right. And if this normal distribution is represented in terms of a box, that's how it will be represented. The first vertical line will refer to the minimum value. The second one will refer to the first quartile value, that is 25% of the data. The middle line will represent the median, that it is not skewed data. This is Q3, that means it represents the 75% of the data, and this will represent the maximum value, right? Another important point from box plot is that the values that lie beyond this whisker point, Q1 minus 1.5 into IQR, IQR is known as the interquartile range, that is equal to Q3 minus Q1, right? Interquartile range, that these are known as outliers. So what are outliers? Outside of the distribution, or the extreme values in the data set are known as outliers, right? So what is the beauty of this box plot graph? That it gives a 5-number summary, minimum, maximum, Q1, Q2, Q3, along with the outliers. Okay. Now, this is the graph which it will show vertically. This is the lower whiskers, greater of the 25th percentile or the minimum value. The second one is the first quartile. This is your median, the 75th percentile, and the upper whisker. All right. Now, there is another parameter in box plot function known as the notch. The notch, the bend in this particular box plot gives that the median lies in this particular range. Getting my point? That the median will lie in this particular range, and the bigger one, the difference between the Q3 and Q1 is known as interquartile range, also known as the length or width of the box, depending on how we are drawing it, whether we are drawing it horizontally or vertically. Got my point? The bend is known as the notch, and statistically, it represents the 95% confidence interval of the median. Clear? right? So what is the use of notch? So if the two medians with the notch are, very close to each other, then it is difficult to judge whether A is greater than the value or the median of A is greater than B or the value of B is greater than A. But if the notches are very far separated from each other, then this is how it shows. So a box plot or a box and a whisker plot provides a graphical summary of the distribution of the data set. It displays the minimum, first quartile, median, the third quartile, or the maximum value. So here I have created this np.random normal. So what is this np.random normal? Again, it is giving with mean value 0, standard deviation 1, and I'm generating 100 values. This is what we were doing over here. So mean is equal to 0, standard deviation equal to 1.5, generating 10 values. Understanding the np.random functions? Everybody is able to understand np.random functions? Yes, learners. So it is np.random normal, np.random with 0 and 1.5 values, right? And therefore we have this plt.boxplot. So please remember the name of the function. See, obviously nobody can remember all the parameters. Definitely, we are living in this world of AI, so we don't need to remember that. Code A can be easily generated by AI tools, lot of online resources available. But what is the important point? The concept, what the graph is telling us, and are we able to interpret based on our data or our requirement, project requirement? Getting my point? So learners, do not get scared that I'm not writing the code. What will be the parameters? That's not the point of interest. The point of interest is, are you getting the concepts and are you able to interpret the output or not? Clear? So here in box plot, we only pass one value. So it's univariate analysis. We do the analysis of only one data, but we can do it for different groups. So group 1, group 2, group 3. Patch artist is equal to true and the notch is also equal to true. The parameter notch also is equal to true. Getting my point? X label, Y label, and title is clear. So here I am able to draw the graph. Yes, learners, are you getting this point? So tomorrow's session is going to be very, very important. Tomorrow we'll start with the Seaborn library and start practically working on the data sets. So tomorrow we'll do a lot of practical analysis along with the graphical representation. Tomorrow's session is very, very important because we will load a lot of data sets, do analysis on it and draw the graphs. Got it now? Are you understanding the flow of data science now? What data science is, we understood NumPy, Pandas, data visualization. Then we will move on to the linear algebra statistics part of it. Which material you want? A lot of material is already there on the LMS. Let's say you want my material, the PPT, the PDF that I create, my material. See, I would love to give you the material, but I keep on working on based on the different batches and requirement. I keep adding certain things and removing certain things. Okay, Hetze? So today I'll be uploading the Pandas PDF. Do you want me to upload the Matplotlib also? Are you liking the session? Is the pace fine now? Arun, Aswat, Deepak, I'm not going fast at all. Dhruv, Gayatri, Kanishka, Karthik, Kirtika, Madhuprita, Muthu, Nikita, Pankaj, Preeti, Sudhanya, Turlapati, Yogesh, Tarun. Is the pace fine? Now let's move on to a very, very interesting graph, that is radar and a polar chart. In normal daily lives, we do not use radar and polar charts because they are more used in navigation purpose, especially the polar chart for aeroplanes and ship. Radar chart is used for engineering purpose, and it can be also used for multivariate analysis. So what I'm trying to say over here is, suppose you have 8 variables and you want to do the comparison between 3 values in it, 3 subset values in it, variable 1, variable 8. Now, we can do it with the help of these bar charts also, but are you understanding the horizontal space it takes? Now from 8, if I make it 18, it will occupy a lot of space. But if I want to do the same analysis in more compact form, then I can use this radar chart. Do you see? Variable 1 and variable 8, exactly the same information can be achieved over here. Spider radar chart, right? I'm explaining you, Mansi. If you still have difficulty, then ask me. Okay. So the first point for radar chart, spider chart, web chart, they all mean the same, that it helps in analysis of multi-variable data, right? So what are the different elements of the radar chart? Please look here. The elements of the radar chart are its axis, that this axis represents low, medium, high, and urgent. Then the circular values are known as grid lines, right? What is the range of these values? This is 0, this is 20, 30, 40, etc. And these are my data points. Clear? Is this point getting clear to everybody? So we have the resolved and unresolved charts. Yeah. So a polar chart. Now is it better? Are the components or the elements of a radar chart clear? Right. So here we have these grid lines, right? And from this, for the polar chart, we start from this one of the axes, and then we calculate the, the angle, how far we are. And the angle is calculated in radians. And this is nothing but your, the radius of the chart. So the two components required for polar chart are its radians and the angle of rotation, which is always in terms of radians. Clear? To make the concept more clear, let's understand it practically. Now, this is a radar chart which is showing the employee evaluation, right? So what can you observe? The criteria for employee evaluation are communication, technical knowledge, teamwork, punctuality, and meets deadline. And the values range, grid lines range between 0 to 4, 6, 8, 10. So out of these variables, which one has got the maximum priority or majority? Which one has maximum priority? It is the technical knowledge. It's quite clear. What is the value of punctuality? It is around, it's not even 2, it lies between 3. Clear? Now the radar chart is clear, Mansi. The web, this is known as the radar chart, web chart, spider chart because of the shape. Now let's understand the polar chart. There are three axes to it. This refers to the $0. This refers to the $1 million revenue. And this refers to $2 million revenue, right? These are my grid axes, 1 lakh, 2 lakh, 3 lakh, the quantity sold. All right, Mansi, getting my point? Right? Now, if I look at this particular point, the product, what I can conclude that the product one, the revenue for product one lies between 0 to $1 million, right? And the quantity sold is 1 lakh. Now better. Mansi, Hadse, Navdeep, Yogesh, Kamal, Devika, Deepak, are you all getting this point? What about product 2? Product 2 lies between 2 million to 1 million of the product. And the quantity sold is 3 lakh. Similarly, product 3, it's the revenue is more close to 2 million and the quantity sold is more than 3 lakh. Now, are you able to interpret the graph, Mansi, Ruby? But still there is slight difference between the radar and the polar chart. The radar chart are also known as the spider chart or the star chart because of its shape, web chart also. It helps in analysis of multivariate data. With a radar chart, however, each radial axis acts as a dimension, allowing us to plot the multivariate data. A radar chart uses one continuous axis and one categorical or discrete. So the variable values can be discrete and one continuous. Radar chart is now clear? And if we talk about polar chart, that's more used for navigation purpose. You find it very less for real-time analysis. A polar chart typically plots two dimensions, one using the radial distance, as I told you, the r, and the other one is the angle. The use of polar chart is used in scientific as well as mathematical context to represent specialized data set. And polar charts are especially suited to cyclical data set as we saw it in this example. The radar chart is a graphical method of displaying multivariate data in the form of two-dimensional chart with three or more quantitative variables. So as we see that one of the axes can be categorical data. So we have these categories A, B, C, D, E along with the random values 1 to 10. Clear? We are calculating the angles over here using the linspace function 0 to 2 pi to the length of categories, the data and the angles. So which is the function which is helping to create a radar chart? It is plt.polar. We do not have any function. Please do not get confused. We do not have any function such as radar chart to draw the graph, right? So plt dot polar, and these are plt dot theta grids which draw the grids of the function. Clear? Are you all getting this point? Now better, Mansi? So now what is it? Which category is getting maximum value? It's very clear in one go. It is category D with value 8. So is it that confusing? No. Is it that confusing? Not really. Clear? Then we understand the area plot. Area plot is used to represent the cumulative sum of quantities over continuous intervals. Cumulative sum, what do we mean by that? No, it must be covered when you were doing data science before, Mansi. No? This is not covered. Oh my God. Now, what is the meaning of cumulative sum? Tell me, learners. What is the meaning of cumulative sum? Taking the sum of previous values. For example, if I want to calculate the, the sum of the sales of the, calculate the area of, calculate the sales of the car in the past year, right? Then we can actually calculate the sales of the car on quarterly basis. So cumulative sum means taking the sum of different values so that the analysis can be better. So it is effective for illustrating contribution of each variable in the quarter. So again, I am using my x-axis function for creating my x-axis data. y1, y2 are my y2 data. Again, there is no special function such as area plot. Here we are using plt.fill underscore between and passing the values x, y1 and y2 to create the graphs. The Matplotlib consists at the lowermost layer, we have the backend layer, then we have the artist layer, and on the top we have the scripting layer. Getting my point? And these are the different components required for any graph. That is the title, right? The titles for the different axes, X label, Y label, and legends to give the key points. Which is the function which is used to create more than one graphs in a single figure? Which is the function which is used to create more than one graphs in a given figure? Absolutely correct. They are subplots. What are the three parameters to the subplot? What are the three parameters required for the subplot? Index, rows, and columns. Yeah, the number of, the rows. The first one is actually the rows. The second one is columns. And the last one is index. Okay, Mansi? The index refers to which graph we are referring to. No issues, no issues. Then what is the use of this box plot graph? Yes, learners. Tell me, what is the use of box plot graph? Yeah, basically it gives the descriptive statistics plus the interquartile and covering the outliers. Perfect. So it gives the 5-number summary, that is the minimum, right? The Q1, the Q2, Q3, and the maximum value. So this refers to the box plot values. Clear? Is this point getting clear to everyone? Right? So here we have the minimum value, the Q1, the median, and the Q3 values. Interquartile range refers to Q3 minus Q1. That's the difference between, the Q3 minus Q1 is interquartile range, and the values that lie beyond these minimum and maximum are known as outliers. Clear? Clear to everybody? So this is the center data point. So what does this parameter notch mean? It does not refer to the median. It refers to the range in which the median lies. Please try to understand as we move along with the statistics. The notch will tell me the 95% confidence interval of the median value. That are these values lying in this range or not? Clear? Getting my point? So this is referring to your lower whiskers, these values, and the maximum values. Clear? So what is the advantage of using notch? So if the notch values are very close to each other, then it is difficult to say that which one of them, which particular value is higher or lower, right? And in the other case, if I use the notch, the value of C is more than the value of D if they are clearly distinguished from each other. See, if they cross this borderline, it is clear that this value is greater than that. But if the notch values are overlapping, then it is difficult to say which one is higher and which one is lower. Clear? Right? Then we understood the radar versus the polar chart. What is the difference between a radar and a polar chart? Tell me, what is the use of radar chart? What is the difference? What is the use? Tell me. I want everybody to respond. What is the difference between radar chart and a polar chart? Tell me quickly. What have you understood, learners? Respond. We've already done this. Nikita, Pankaj, Kamal, Joshika, Hadse, Aswat, Uday, Yogesh, Deepak, Dharun, Tullapati. Answer. Come on, what is the difference? Tell me. What have you understood? First of all, the radar chart is also known as the web chart or the spider chart, which is used for comparison to give a concise comparison of multi variables. Clear? Right? Then we have the axis and the grid lines, the component. But in radar chart, it is the radius r and the angle theta in radians, which is important. Okay. So radar chart helps in analysis of multivariate data, and each radial axis acts as a dimension, allowing us to plot multivariate data. A radar chart uses one continuous axis and one categorical or discrete axis, whereas the polar chart uses only two dimension, radial and distance, and one is the angle. Polar charts are generally used for cyclical data set and used in scientific and mathematical context. More used in for navigation purpose, for ships, for aeroplanes, etc. So this is the example you remember now. Do you all remember this example that we had done? That it's clearly that technical knowledge is the most important factor for employee evaluation. Well, it's not so much true, but according to this data, right? Learners, are you there? Am I audible? Can I get a response? And when only Mansi is there in this session, nobody else? Okay. And when I talk about cyclical data, this is the revenue in USD along with the quantity sold. So when I look at product 2, so product 2 says that it has revenue of 1.5 billion and around 3 lakh quantities are sold. Clear? Everybody is getting this point, right? We are supposed to start with tree chart today, right? If I remember clearly. We are supposed to start with tree chart. We had not done, or we had done this. Tell me, learners. We are supposed to start from this, Turla, Sudhanya. Yeah, we are yet to start tree. So tree chart is used to represent hierarchical data, right? The shapes are used to show the size relative to its area. And the tree maps are able to show how categories are divided based on each level of the hierarchy. Please, learners, look here. So normally in computer science, a tree has three nodes. One is known as the root node. Then we have the internal nodes, which are used to make decision. And then the nodes which does not have further branches are known as the leaf node, right? The structure looks like this, but the tree chart looks like this, square boxes. And what do these square boxes represent? If more is the value, more is the area of the chart, right? So H has more value. F has the least, so the area occupied by F rectangle would be least. So the chart does not look like a tree, but the areas relative to it look like that. Clear? Are you all getting this point? So tree chart looks like rectangular chart. Got it? Is this point getting clear to everyone? Yes or no? Right? So a tree map represents the hierarchical or the structured data as a set of nested rectangles. It shows the data set as nested rectangle. Each branch of the tree is given a rectangle, which is then tiled with smaller rectangles representing the sub branches, right? A leaf node's rectangle has an area proportional to a specified dimension of the data. Often the leaf nodes are colored to show a separate dimension of data. Getting my point? You're back now, Hetze. What happened? Where were you? I need to have my throat medicine. Where were you? So we have done all these charts. Now we need to begin with the tree chart, tree map. Learners, yes, ready? Oh, you were there with the LSM. Is your issue resolved? Is your issue resolved? Issue with your batch. Learners, you are rating me well, but nobody is rating me with full marks. Nobody is rating the session 5 out of 5. So my, the feedback goes very, very low. So I request you, if you're liking the session, please give me full marks. No, am I not teaching you nice to get full marks? You all are rating me around 4, which is not fair, or is it fair? So I request you all, to please share a good feedback, when you're doing that. Yeah, some rated 5 out of 5, but most of you rated 4 out of 4. So I request you, if you're liking the session, please rate me 5 out of 5, because then the average goes very low. Okay? Yes, learners, can we begin now? Uday, Raj, Nikita, Yogesh, Deepak, Dharun. Okay, now Kriya. A tree map is an effective way to visualize hierarchical data structures. It provides an overview of the entire hierarchy while allowing users to easily compute the sizes of the different branches and identify patterns in the data. Okay. So as we understand, the tree structure is represented as nested rectangles, right? So first thing, please do the pip install Squarify. So have you done the installation? Let's understand the code. So first we need to do the matplotlib.pyplot as PLT, then import Squarify, and we get this hierarchical dictionary structure where we get the root, branch 1, leaf 1 value as 10, leaf 2 value as 30, branch 2, leaf 3 value as 35, leaf 4 value as 5. Okay. Then we have created a function to flatten hierarchical data. All right. So here we are going to take the key value in the node dot items, and then we use the flatten hierarchy. Clear? And how are they created? They are created using the subplots function, right? And then we do squarify dot plots and pass these values. So the tree map hierarchy looks like over here. So it's very clear that leaf 2 has more value than leaf 1, and the maximum value because it has the maximum area of the rectangle. Got it? Everybody and the code without errors. Data set can we create? Yes, yes, yes. Dynamically in the sense what? Then you have to create this function and pass that. That's it. Squarify and create the code. Okay? That's it. Mansi, are you able to do it? Yogesh, Deepak, Pankaj, Kamal. Great, Tola. Great, great. Everybody is able to run it? Great. Now, one of the favorite, uh, charts that we have been studying from our school days is the pie chart, right? We all understand pie chart where we take the whole of data as 100% and divide the portions into different parts. So a pie chart is a circular statistical graphic that is divided into slices to illustrate numerical proportions. Each slice represents a proportionate part of the whole, and the entire circle represents 100%. These charts are commonly used to visualize the distribution of a categorical variable or the relative sizes of different components within a whole. Clear? Right? So we used to do calculation. Here we don't have to do any kind of calculation. Whatever values you are passing, 30, 40, 130, automatically it will divide it into the ratio of 100 and draw the graph accordingly. So category C occupies most of the portion as compared to category A and B. Clear? So plt.py gives the values. Labels is equal to labels. Autopcity. What is this? Autopcity. Yeah, Hatse, please wait. Autopcity gives me the decimal point value of each graph, right? So if I give this as, maybe make it as 3000, and now let's see the answer. So now do you see? It's able to give me the 2 decimal point places. There is some overlapping. So maybe, I can now reduce it to 300. Clear? Pie chart is getting clear to everyone. What is the role of autopcity? And if I change it only to 1f, it will only give the values to 1 decimal points. Clear? Yes, Hatse. Yeah. Back to the tree chart. Tell me, do I need to unmute you? Do I need to unmute you? Okay. Unmute. Yes, tell me. Yes, Hatse, please go ahead. We can't hear you. Hatse, we can't hear you. Are you able to hear him? I can't hear you. Others, are you able to hear you? You can hear us, but we can't hear you. I've already unmuted you. We can't hear you, Hatse. Please check out your mic and settings and then let me know. Okay? You can keep trying. I don't know, something is just not working because we have been hearing you a lot in the past all the sessions. So just check out your settings. Okay. In the meanwhile, what is the basic difference between a histogram and a bar chart? Yes, learners. What is the difference between a histogram and a chart? Distribution and the number of events occurring. So histogram tells me the number of, the data divided into different class intervals for continuous numeric data. And the number of class intervals that we divide are known as, what are these known as? The class intervals in which the continuous data gets divided in histogram. Good, Kamal. Yes, they are known as the bins. Getting my point? And bar chart is not used for numerical data. It is always and always used for categorical data, that is Jan, Feb, March, April, May, and etc. Clear? Is this difference getting clear to everybody? And the major use of histogram is that there are no gaps between the rectangles and it gives the distribution of the data. Clear? It closed, it worked, Trilla? Yeah. So whenever you face certain difficulties, it will work like that. Okay. But the number of bins also play an important role. If the number of bins are less, we tend to lose the shape or the correct distribution of the data. But as the number of bins increase, till here it is fine, and till 43 also it's clearly distinguished. But the moment it crosses certain values, we lose the detailed information about the bins. But we are always interested in finding the shape of the data. So the number of bins are also important whenever we are creating the histogram, when we are passing the number of bins. Getting my point? Right? And then we have the KDE plot, which is the kernel density estimate plot, right? The kernel density estimate plot is created by the sum of the kernels, right? Which tries to give us a smooth distribution of the data. Histogram also gives the distribution, but it is dependent on the number of bins that we are passing. And the KDE also gives the distribution of the data. Getting my point? Is this point getting clear to everyone? Clear? So the KDE plot is used for visualizing the probability density of the continuous variable. Again, it's used only for continuous data. Probability density, do you understand probability density? What is the probability of that particular event happening? That's the concept on which whole machine learning works. It depicts the probability density at different values in a continuous variable. We can also plot a single variable for multiple samples in more efficient data visualization. It provides a smooth representation of the underlying distribution of the data set. Clear? Are you all getting this point? So this is how a KDE is drawn. And if you want to do a comparison with an histogram, it's like, the kernel density estimate, like the individual rectangles over here. The individual rectangles over here refer to the kernels. And when the kernels overlap, they get summed. And when there is no value, that is why we see a dip over here. Clear? Getting this point? So the data points are the rug plot on the horizontal axis, right? Then we have the 3D plotting, right? Now we will understand another aspect of visualization, that is 3D plotting. What is 3D plotting? 3D plotting will now consist of three axes, that is X label, Y label, and Z label. All right. And Mansi, you wanted this kind of a cheat sheet, that what is the data type, when a particular graph should be used. I think so this will be helpful for everyone. Right, Turla? Hadse, Kamal, Pankaj, Yogesh. Clear? Okay. So now let's get back to the file. I want everybody to load this data and start performing the data analysis with it. Yes, Tulla. I've already shared this PDF with you. Yesterday only I shared this. Not really, Mansi. We would move ahead with 5.0. If you face difficulty, then let me know. Today, you'll do a lot of practice. Don't worry. I'll make you experts that you will be able to easily do the assisted practice. Don't worry. Yeah. Now I have sent this Adani ports data. I want everybody to load this data and start working on it. Load this data. So which is the command that is used to load the data? How do you load a CSV file in Pandas? Tell me, how do you load a CSV file in Pandas? Today we need to do a lot of practice, and I want you to be experts at least in few of the commands. So what are the basic 5 commands that you will use to do the analysis? Tell me, learners. Tell me 5 basic Pandas command that help us in analysis of the data. Tell me. One is the head. What does the head do? First is the head. What does the head command do? Yeah, it shows the top 5 rows. Everybody is able to run this code or not? Good, Mansi. What is the other command? Tail. What does the tail command do? What does the tail command do? It gives me the last 5 lines. Very good. Right? What does the describe function do? Good, Sudhanya. What does the describe function do? It gives the statistical summary of the data. Very good. What does the shape command do? Excellent, Tullah. Excellent. So you all understand? What does the shape command do? It gives the number of rows and columns. So Adani ports gives me 3,322 rows and 15 columns. So this is how we get the info. Do we understand info, learners? What does the info tell me? The number of rows. Are there any null values over here? Yes, maybe in trades. And these are my categorical data. Do you see that? Very good. Do you see the date is also categorical? Sorry, or the string data type. So how do we deal with the date? Data type? Yes, learners. We need to convert it into date time object. Why do we need to convert it into date time object? Why do we need to convert it into date time object? To perform arithmetic operations on the date, right? And to get it in the correct format. All the logical thing is being done over here. Clear? Can you tell me the command to check the null values? Can you tell me the command to check null values? How do we check null values? Very good. Anybody else? Is the command correct? Very good. So can we do that also? So this gives me the data in terms of all Boolean values, or it could be is now also your case. Very good. But to get the summary of it, I will use the sum function along with it. Right? So in data set, we see that the trades column has 866 null values. Got my point? But now what are we trying to do over here? Using this data set, we have our 2 columns, high and low. So rather than using these two, columns separately to draw the graph, what I will do is I will create a 3rd column. Please try to understand this. I am going to create a new column in this data set. Why am I doing it? Because this will give me a better analysis. That is the difference between high and low values. Got it? This code is getting clear to everybody? Yes, learners. Yeah. What does high and low mean in this data set? That's difficult to answer, but not that difficult also. So this is the data for Adani ports. So it's maybe the high and the low cost. I'm not very sure about it. I need to do that. Let's search this. Is it the stock prices? So here we go. We got it by the co-pilot. So open means date, the trading date. Open means the prices at the market open. Please look here now. Mansi, we got this answer. High is the highest price during the trading day. Low is the lowest price. Close is the closed. Adjacent closing price and volume, the number of shares traded on that day. Better? Yeah. I think so. I can copy paste it on the file itself so that it's easy to understand, right? Yeah, this is clear. The calculate the difference between high and low prices, right? So we have created, rather than now having two different columns, I have just found out the difference to get the, get the information about this new prices. Clear? Getting my point, learners? The another thing that I'm trying to do it over here is, yes, so H minus L is my new column added. And what is the advantage? That it has combined the high and low, and now I can use it to draw the graph. All right. Now I am creating another new column of data frame 100, moving average. So now I am creating this df.close. df.close rolling 100. That after every 100 values, it will take the mean of it. Right? So this also adds a new column in my data set. Clear? Got it, Hatse, Mansi, Yogesh? So now so what's the advantage? That I'm able to analyze more variables in the three-dimensional graph. So we create a 3D scatter plot. AX is equal to PLT dot axis. No changes, that just the change in the function and the parameters. That projection is equal to 3D. And now I am going to create ax.scatter function and pass the three labels. That's the x, y, and z labels. Getting my point? So this is ax.set x label, ax.set y label, ax.set z label. Clear? If we talk about more technical thing, that data analysis can be divided into three components. One is known as the univariate analysis, right? Second is known as the bivariate analysis, and the third is known as the multivariate analysis. What do we mean by the term univariate, learners? What do we mean by the term univariate? Can you tell me? One variable analysis. Very good. What does the term bivariate mean? Bivariate, two variables. and multi more than 2. Okay. So technically, can you tell me data is divided into two types? What are the two types of data? How data is divided technically, how we look at the data columns? Broadly, categorical and numerical. So does it have an effect on our graphical and analysis also? Yes. So when I want to analyze one variable, please try to understand. If I want to analyze one variable and if they are numerical value, then we are able to do it with the help of histogram, the violin plot, as well as the box plot. Clear? Is this point getting clear to everybody? Then we have this categorical variable, right? Categorical variable, we will draw the count plot, bar graph, and pie chart. Some graphs we know, but some graphs are new to learn in Seaborn, that is a violin plot or a count plot. Right? Right today, Turla, Kamal, Pankaj. Today, Ruby, I'm missing Ruby. Yesterday, Ruby Arora was there. She's missing today. Right? Then we are able to do the bivariate analysis for the two numerical values. It is known as the scatter. Oh, you are there. I was missing you, Ruby. You joined late. You were not there. I was looking at you. No answers were coming. You joined late? Okay. Okay. Sunday also you got late. In which time zone you are? It's early morning for you or evening? Or midnight? Oh, okay. Okay. Sundays it's more responsibilities, right? Some people do more of rest, but I think so now weekends are more hectic than the weekdays, isn't it? You have house, other activities, every activity needs to be done on the weekends, even any kind of recreation, any kind of stress reliever activity. So weekends are more stressful now than weekdays. Weekdays you're more relaxed, just have to do your work, just your professional life, right? You all agree with me, right? Right? Weekend, everybody say, oh, come on, it's a weekend. And there are other household activities also that needs to get completed. Oh, it's a weekend, let's do this. It's a weekend, come on, let's do this, do that, right? Hot point? Okay. So bivariate is analysis of the two variable. So if I have numerical values, then we can draw a scatter plot and using a join plot. If it is categorical, we will do it with the help of count plot. And if it is a mixture categorical value, it is known as the bar plot. We can use it as a bar plot, box plot, violin plot, as well as a dist plot. Clear? And if we want to perform multivariate analysis, we've still not done any kind of multivariate analysis that we will do over here using a bar plot, pair plot, heat map, as well as the histogram. All right. So definitely Seaborn is an advanced library that is built on Matplotlib, which provides more beautiful default styles and color palettes to make the statistical plots more attractive. Clear? Now clear to everybody? Yes? Great. So the different graphs that we are going to do in Seaborn is a dist plot, right? Basically, most of the graphs are combination of different graphs. Okay. So when I talk about dist plot, right, here we have, it is a combination. Sorry. It's a combination of a histogram plus KDE plot. So a disk plot is basically a combination of histogram plus KDE plot. Got my point? A joint plot, a normal joint plot, what does it look like? Which graph does it look like? A scatter plot. But what is the additional point over here? That you see the individual distributions along the opposite axis. This is the advantage. Clear? It was disk plot. Where did you see the disk plot? Oh, it's the disk. It's a disk plot. It's a disk plot. Yes, there is a typo error. It's a disk plot. It's a disk plot. Okay. Yeah. Now moving ahead. Now when my scattered or these circular values are represented as hexagonal bins, the same graph becomes a hex plot. Got my point? Yeah. And again, it is showing me the distributions on the individual axis. Clear? Right? Now here, this is the graph of box plot. Now box plot over here, if I'm doing comparison between different values, then this is used. It is basically a box plot represents only for one data. But if I use it for multiple comparison, it becomes a multivariate analysis graph. Got it? So it's used for, both the analysis. Clear? I are all these on the previous table. You should as which one to use and which. Yeah, you will understand that. Don't worry. Okay. Yeah. This is a KDE plot. The kernel density estimate plot. The darker color shows the density of the points over here. It's for the same data set. And this is for the opposite one. Got it? Now, multivariable variable analysis. Pair plots is an example where I have my x, y, and z variable along with x, y, and z. It's not only that it can be drawn for 3 variables, it can be 5, 6, or 7. But always a n by n matrix will be created. Clear? Getting this point, learners? We have the LM plots, also known as the linear model plots. Very, very important from the point of view of machine learning, that if we have these data points, we always want to try to fit in a straight line function. So that is where it refers to the LM. But my violin plots, why it is known as violin? Because the shape looks like violin and it is nothing but the combination of KDE plus the box plot. Got it? Is this point getting clear to everybody? Right? So the first type of plot that we will start over here is a relational plot. But let's first start with the file. So should I share the file with you? So Seaborn is a Python library for statistical data visualization that builds on the Matplotlib. All right. The advantage of Seaborn library over Matplotlib is that it provides better creative, attractive, and informative statistical graphics. It comes with several built-in themes and color palettes to make creating aesthetically pleasing visualization, and it is particularly well suited for exploring complex data set with multiple variables. And another beautiful part of the Seaborn library is that it has already predefined databases in it. So I don't need CSV Excel files separately to load. They're already part of the Seaborn domain, such as anagram, attention, brain underscore networks, car crashes, diamonds, flights, fMRI, iris, penguin, tips, Titanic, etc. Clear? Everybody is able to see this. So a lot of practice can be done now. Right, Mansi? Ruby, Hadse, Pankaj, Uday, Mohammed, Turlapati. Yeah, these are the file names. Yeah, these are the file names. So now how will you go about it? Simply you have to run sns load underscore dataset, just the name of the dataset, and you are good to go. Got my point, learners? So now can you perform the basic 5-6 functions of the analysis? I want everybody to do it on their own. I know the file might be containing it, but you should know how to do the data analysis on the own. Right, learners? Head, tail, shape, info, describe, checking the null values. Please do that, learners. If I have local files, do I need to give the path placing in the same folder? There is no need to place any file. They're already predefined in the Seaborn library. Let's say if you're talking about these files, these data set, no need. Otherwise, if they are separate files, yes, you can. Then you need to give them path. Otherwise, put it in the same folder. Okay. Can we move ahead? All right. So now if you look at this particular data set, this is the subject, the time point, the event, the region, and the signal. Okay. Another important point, are you all able to do the head tail? Basically, the shape gives me that this particular data set contains 1064 rows and 5 columns, right? Another important point to be noted over here is specifically for categorical data, which function is used to analyze the categorical data? It is always the value underscore counts. Please remember this point. So for all the categorical data, run this value underscore count. It gives a better understanding. Let's understand that. So describe gives me detail of all. So there are two events. This is the scan, the scanning of the brain, right? And there are two events. One is stim and Q. Anybody who's aware about from the medical department? Anybody from the medical department who can tell this? Nobody? So this is all about the data set, task format, spatial dimension, temporal dimension, purpose. We are still not. This is a little different data set. Yeah, this is the data, but we wanted a little detail of the columns. No, you're not getting it? Seaborn, column, details. Yeah. So are you understanding one more point? Whenever we get any data set, first we have to analyze the columns, what the data set is saying. Then we do the ahead with the graphical part of it. Okay. So this is synthetic. It's not that. So yeah. So basically the data set has long format structure. Subject is the number of participant or the patients. Time point is the temporal measurement, 19 points. Event is experimental condition. Type, I still don't know what is. Stim is stimulating. Q, I still don't know. Region is peripheral and frontal, the brain region, the front or the back. Signal is the bold signal amplitude. Should I share it with you all so that you can paste it in your... Yes, learners? Is it helpful? Yeah. Are we good to go now? The region over here, again, it's a very balanced data set. It gives me the equal values. Everybody is able to run the code? Ruby, Pankaj, Mohammed, Uday, Turla, or you're facing difficulty? Tell me quickly. Yeah. Are you getting this point? And subject over here refers to the patient name or the things. Clear? So again, I'm repeating, whenever any data set will be given you, and this is going to be exactly the project that you need to do. Okay, learners? This is going to be exactly the project that you need to do. The project that you need to do is that whenever you have any data set, you will load it, try to analyze its column, perform basic analysis on that, and then move to the visualization part of it. Right? Got it? Yes, learners, are you getting this point? Please remember, this is exactly going to be your projects like this. If you're not able to do it here, then it will be difficult. So if you're facing any difficulty, please let me know. Now let's start understanding the graphs in Seaborn library. The first graph that we are doing is the rel plot. Okay. Now what is this rel plot? That data is equal to fMRI. Okay. We are passing. This is the data that we are passing. Then we have the kind is equal to line. Right? We are trying to create a line plot. On the x-axis, we want time point. On y-axis, we want the signal. Column is equal to region. That means here we are trying to create multivariate graphs, right? Creating two columns. U. U is the third parameter that I am adding over here, right? U is the legend over here that, I'm adding in this particular graph along with the style. Clear? So what will happen if I remove these parameters? Let's understand this. Only one of the graphs is drawn, right? Try to understand the difference, learners. We have given the data line plot. X-axis is equal to time, Y is equal to signal, and I have given column is equal to region. And if I again, do this, I amend this, then I only get one graph, right? So are you understanding the beauty of Seaborn library now? Right? So you can add multiple outputs along with the hue parameter. Can I change this kind? Yes. You can also change it to the scatter plot also. Clear? See, look at the beauty. There is this one particular function and we can get so many outputs. So isn't it giving you now better insights to the data analysis? Just by exploring the different columns, different parameters, isn't it giving you better insights? Yeah. Now we are in place of plt.matplotlib. That is not required. I'm directly using the Seaborn function to get the output. Do you see that, Mansi? Is there any Matplotlib that is being used over here? Yes, it's much better, much concise, and gives a better output, right? And as we have seen, if I remove this kind, the kind parameter, automatically it gives me a scatter plot. So anything that we want to understand over here, that can be always, you can find out the details of the function using a question mark, that is the rel plot. Got it? Is this point getting clear to everybody? All right, so we have this relational plot. The relational plots can be used to, the basic function is the rel plot, okay? But it can be used to create the line plot and the scatter plot. Got my point? So the rel plot, this function provides access to the several different access level functions that show the relationship between the two variables with semantic mappings of the subsets. The kind parameter selects the underlying access level functions to use. So here we have the scatter plot, right? And it is which parameter of the function which creates a scatter plot? Using the kind parameter, which is also the default type, right? And if we want to draw a line plot, just by using the kind parameter. So look at the beauty. A single rel plot function can be used to draw a scatter plot as well as a line plot. Getting my point? What does it return? And we also saw the beauty of rel plot, that it can return more than one graph. And that is known as the concept of facet grids. Please try to understand. Facet grids are the frameworks to manage one or more subplots. Clear? So are you understanding? It helps in comparison of the data points very easily. So an object managing one or more subplots that correspond to the conditional data subsets with convenient methods for batch setting of access attributes. So Seaborn Facet Grid is a class in Seaborn data visualization library in Python that facilitates the creation of multi-plot grids, often referred to as the small multiples or the trellis plots. It allows the visualization of the distribution of the single variable or the relationship between multiple variables across different subsets of the data set. Clear? Yes. So facet grid manages automatically those subplots. So that's the beauty of the Seaborn library. That instead of getting one graph, you can get multiple graphs. With the help of few parameters, you can do a lot of comparisons between the different parameters and also create columns in it. Clear? I'll show you this graph. We've done this graph also. Now clear to everybody? Are we good to go? Let's say Yuvraj, Uday, Turla, Pankaj, Kamal, Mohammed. Now let's understand this tips data set. Now it is your duty to load it to understand the tips data set. I'm giving you the next 2 minutes to do that. Yes, come on learners, be active, start loading the data and try analyzing it. Yeah, Mansi says the data set talks about the tip with the respect to the total bill, gender, smoking habit, day, and time. Yeah. So it talks about a restaurant where we are trying to analyze the who all give tips more, right? Males give more tips than female. Smokers give more tips to more tips in a restaurant. And this restaurant is working for 4 days in a week. That's Thursday, Friday, Saturday, and Sunday. It serves for lunch and dinner time, and size represents the number of guests. Okay, Tulla, Uday, Mohammed. Yeah, we can say the tips being the output and other being the input. Right? Clear? Yes, learners, are you all getting this point? Info. Yes, tell me from the info, have you done the analysis of the categorical data? Huh? There, tell me, are the smokers more than non-smokers? The days and the time. Come on, do the analysis of the categorical data. Yes, learners, please do the analysis of categorical data. Non-smokers are higher in number. Okay, I'd say. What about male and female? Males are more than females. Okay. And others? Yeah. So males are definitely more than female. Have you been able to do this? Day value count, which day people go more? On which day people go more? Saturday. Sunday, least people go on Friday. Smokers, non-smokers are more than the smokers, right? People go for dinner more than the lunch. Clear? And it is mostly the people as couple go more. Are you all getting this point? The size looks like int, but it is actually discrete values, right? The size of the tips data set is nothing but the discrete values. Everybody is able to do. Please, learners, let me know. Aswat, Dhruv, Hariharan, Harshita, Joshika, Kamal, Kirtika, Kiruba, Malipudi, Mohammed, Arshad, Mohammed, Rifat, Mukesh Krishna, Muttu, Preeti M, Darun, Madhuprata, right? Yes, learners, are you there with me? So this is the rel plot I was talking about that we saw in the diagram, that SNS.rel plot between data is equal to tips, X is equal to total bill, Y is equal to tip, U we are calculating on the basis, the legend is a basis of 2, day, column is equal to time, and row is equal to 6 for male and female. Clear? Are you all getting this point, learners? Great, Sudhanya. Are you able to run the code now? Everybody was able to run these basic functions, load the data set. Now let's start the data visualization. So the first graph that we are using for analysis is a scatter plot. This scatter plot is drawn between the total bill and tips. So what do you conclude? Now, what is your interpretation about the graph? Now, try to understand the another aspect of analysis, that interpretation of the graphs and result. If you're not able to interpret, first point you have understood that you have to understand the column, the data set, then perform analysis of it. But interpret the result. Yes, the larger the bill, the larger the tip. It shows positive relationship. And the beauty of Jupyter Notebook is that you can draw the graph and as well as give the points over here. Clear? So based on the scatter plot, you can infer a positive relationship between the total bill and the tip amount, indicating. So it's always good to write your inferences along with the graph. Getting my point? Is this point getting clear to everybody? Right? So based on the scatter plot, you can infer a positive relationship between the total bill and the tip amount, indicating that the customers tend to tip more when they spend more on their meals. Another important point to observe over here is that there is still variability in the tip amounts of the given total bill, suggesting that the factors other than the bill amount may also influence the tips customers leave. All right. Clear? Got it? The rel plot is also clear. Now let's understand the line plot over here. Here we have added X as the days, Y as the total bill, and U is equal to 6. What is the use of U parameter in Seaborn library? Tell me. Yeah. Or we can say, had say, it adds the third dimension for the analysis, right? No, no, no. We will not say categorical data. We can say that, yeah, it could be generally categorical. It's easier. See, if I remove the U, it only gives the relationship between the day and the total bill. Do you see? Simple. This is the average. But the moment I add the parameter U over here, please look here. No, it does not give the 3D. The moment I add the U parameter, I understand the female's total bill is very much less on Friday as compared to other days, and it is the males where the total bill remains high. Can I change this parameter different? Yes, I can change this to the smoker type, right? So now the U parameter gives me that smokers, where is this? Yeah. So smokers, non-smokers are giving a positive relationship, but sorry, non-smokers are giving me a positive relationship, but smokers show a random dip and then increase. Yes? Are you appreciating the beauty of Seaborn library now? Yes, learners. Right? I can also change it to size also. So now it is completely up to you how you want to utilize it for your benefit. Now, this is not giving much information. So every graph is not suitable for every data. Use a different graph to analyze it better. For days also, it's not giving me a good picture. Clear? Everybody is getting this point. Important point that, as I've been telling you, always include the inferences below the graph, your interpretations or conclusions below the graph itself. Got my point? So the lines on the plot represent the trend of the total bill amounts across different days of the week, segmented by gender. Based on the line, here we have changed it to smoker. Based on the line plot, you can infer the total bill paid by the males is considered higher than the females. Got it? Are we good to go? Yes, learners. Yeah. So now we need to draw the histogram. What is the use of histogram? Tell me, learners. What is the use of histogram? It's used for distribution of the data. What are the two important parameters for the histogram? The number of bins and the KDE. Clear? So here I am trying to, and histogram comes under what kind of analysis? Univariate, bivariate, or multivariate? It's used for univariate. Univariate, I'd say. I'm only passing one variable. I want the analysis of the total bill only. Got it, Hadse? So here if I give bins equal to 50 and KD equal to true. But now if I change the bins to 5, do you see this? How the graph changes? And now if I make it to 15 and KDE equal to false. Clear? Kamal, Mohammed, are you all able to do it? Got it, learners? Clear to everybody? Can we move ahead? So what does this histogram tell? Read these lines. My reading will not help now. Now you are becoming experts as data scientists. Now my reading will not help. Try to infer all these points, that it displays the distribution. Each bar on the plot represents the range of the bin. It's not a balanced data set. It's right skewed. And you can infer most of the bills lie in 10-20 range. Please infer the histogram plot. So what is the important point? See, the concept remains the same. The concept of histogram or the box plot or the scatter plot is not changing. Only the functions and the code and the syntax is changing. That, we have different AI tools which can easily generate for us. Right?
And with that, we have come to the end of this course. If you have any doubts or questions, ask them in the comment section below. A team of experts will reply to you as soon as possible. Thank you and keep learning with Simplilearn.